why the studio is such a great party. This is why the studio is such a great party. Why the studio is such a great party. This is why the studio is such a great party. This is why the studio is such a great party. Why the studio is such a great party. This is why the studio is such a great party. This is why the studio is such a great party.
Music is all a part of another tomorrow, another kind of language, speaking things of nature, naturalness, the way it should be, speaking things of blackness, about the void, the endless void, the bottomless pit surrounding me.
This is why the studio is such a great party. This is why the studio is such a great party. This is why the studio is such a great party. This is why the studio is such a great party. This is why the studio is such a great party. This is why the studio is such a great party. This is why the studio is such a great party. This is why the studio is such a great party. This is why the studio is such a great party.
All a part of another tomorrow, another kind of language, speaking things of nature, naturalness, the way it should be, speaking things of blackness, about the void, the endless void, the bottomless pit surrounding me.
This is why the studio is such a great party. This is why the studio is such a great party. This is why the studio is such a great party. This is why the studio is such a great party. This is why the studio is such a great party. This is why the studio is such a great party. This is why the studio is such a great party. This is why the studio is such a great party. This
Good morning, everyone, and congratulations to Isaac Ewing and C. Strawn on Ascending. Good morning, guys. How y'all doing? There we go. Good morning too. Whoa, we got a big, who was the raid from? Oh, M Audio. Okay, thank you, M. Excuse me. Good morning, Strawn, Napo, Isaac, Serrata Cyclist, BTVR, Vectral, Steph, Maget, Nat, Aries, Dinara, Witchy Party, Shapetto, Harry, Das Razor, Not Again Now, Rub 8090, Pandar, Arrow Eric's, thank you, M, for the raid. Welcome in, Steph, Arca, I think I would have said you guys' names already. Pennant, Muddy, Taper, Joan, I think I already said Aries, good morning, Slater, good morning. Who else is here today? Laser Pew Pew, Sodai Fan, Kane, Jeltz, Kessler, Trixview, Morphe. Can't be laundry day again. Why don't you just finish some laundry? Get a shout out there for M. How is Fmod going? I'm excited for you to be learning it. Sounds like a really powerful tool. Hey Redshift Dante, how's it going? How's everyone doing today? How are you all? My desk is a mess. I should tidy this desk before we get started. It's productive yet emotional. Oh, emotional. We learned 3 things today. That's a lot of things. Well, we're gonna be learning more. We're gonna be learning more things today. Not Fmod though. You guys, it's a day of learning. First with M, now here. Hey Bad Nintendo. Hey Projectoroid. We are going to be learning enemy and NPC AI. Not like neural network AI, like behavior. Like, I think we need like a different term for it now, like enemy fake smartness. Not in artificial intelligence, it's fake smartness. Can I join your Twitch stream? Do you guys see a knock button? Do you see a knock button on the stream? I've not had anyone click it. I don't know what happened if I click theirs. I don't really know. If I see one of you guys on, maybe I will click it to see what happens, but I don't think I know anyone well enough to just click it, and I would feel bad to do that in the middle of someone's stream unless it's like a very chill stream or if I know them. I do when I raid in. Oh, you knocked before you raided? I didn't even get like a, I don't even know, like I didn't get any, no, but I did see the button. Oh, okay. Yeah, you guys can try knocking before you raid if you want. See what happens. Does this voice call kind of thing? Interesting. Oh, you guys want to be part of the... Oh, yeah, we can do that. Okay, this is private information. I wasn't gonna say. I made a separate group because I belong to a few and I didn't know which one I wanted to prioritize. And I was like, maybe we can do one with the community at some point. So yeah, send me a message if you with your Twitch handle, and that will make it easier. I can do that later. Nat, Pennant, M, Taper, Muddy, Pennant, any of you guys anyone here who streams, you guys are welcome to send me a DM about it. That sounds great. That'd be nice. All right. So for knock, yeah, I think you need to be streaming to knock, Because I always see it, but I'm only always streaming. And some people don't have it. I couldn't figure out how to turn it off either. What is it? Okay. Today. That doesn't matter anymore, I decided. Today, we're doing some important things. I'm gonna drop you guys the links. Here is the main link, okay? Here's the main link in chat. I'll put it in like more than once in case, just so that you guys, in case you accidentally miss it. Because I know the chat is scrolling so fast. Did you guys get that link okay? Do you guys get the link? Everybody see the link? No one missed it? What link? Can you send it one more time? Yeah, no problem. Here you go. Hey, Cajun, how's it going? Hey, Dust Razor. Hey, Baracco. Hey, my cats. I think I already said my cats. Thank you. I said hi to some people. It's hard to remember. Monty Avocado, I did not say hi to. Good morning. And Doom Cookie, good morning. And Becken, good morning. If I miss you, just keep talking. I'll catch your name eventually.
Here's a knock-knock joke for game developers, courtesy of chat. Knock-knock. Who's there? Dev. Dev who? Definitely going to need more time for this feature.
ChatGPT, not bad. ChatGPT stand-up set when? You're looking for the link? No problemo. Here you go. Okay, let me open it myself. So if you look at it, it is in fact a 21-hour course, and it's like video articles, so it's gonna, you can't really skim it. But we're gonna start with one section, and then we're gonna see how much we can cover today. But first, I'm gonna tidy up here. Verbs. Oh, let's put it over here. Ah. I have like a. I have this. Okay, I don't know what to do with this. I don't want to use it. It's a. What are these things called? Block? Mario block? But it's like a bath bomb. And it's too cool to use it. So, but it's like leaving bath bomb everywhere. I just got like a bath bomb situation going on. And you guys already know my traumatic story with the bath bomb. All right, I'm a little bit scared around them. You don't? Okay, so I thought you would have known it by now, but I'll tell you guys again. So I went to this convention and I took a train to get there, and at the convention I was helping somebody with something or another, and I was in a rush, and I was like there for most of the day, and I was taking the train back after, and I was like, oh my god, I don't think I ate anything today. So I'm like, they give out all kinds of stuff at this convention, like, you know, sample stuff, all that kind of thing. And so I was like, I looked in my bag, I'm like, maybe somebody gave out like some food. There's lots of like food booths. Surely there's some food. And so, I mean, you guys already know the punchline of the story because you know where it's coming from, but there was a cupcake in the bag, okay? And it looked like a normal cupcake as far as I can tell, and it was in a clear wrapper, and it was handmade. and it looked stale, but it looked and smelled like a cupcake. Okay, not even like a muffin. I was like, this is like a stale muffin, but I'm like, I'm starving. I'm gonna eat it. I don't know. It was just a cupcake in a bag. It didn't have any label. It didn't have any writing. It didn't have nothing, and I was starving. So I had this cupcake muffin thing, and I just was like, this is kind of stale. I took like a small bite and started chewing it. I'm like, this texture, I'm like, it tastes like a more solid. I'm like, is this like a chocolate or something? And as I'm eating it, it was like a bath bomb. It started foaming, and it was like awful. And I just like spat it into the bag, but I didn't have anything to like rinse my mouth out with. Oh, it was so bad. And then like the water, the train is like not potable, but I think I had to rinse my mouth out with it anyway because it was awful. So yeah, so I ate the bath bomb. Don't eat bath bombs. I learned the hard way. They don't taste as good as they look. And that's the bath bomb. That's my bath bomb history. So now I'm a little bit apprehensive around bath bombs. How was it? Honestly, soapy. It was soapy. I couldn't get the soap out of my mouth. I hope it didn't have bath salts in it. Oh yeah, I did the same thing with this is not the first time I've had this experience. I did the exact same thing with the vitamin C. Okay, let's move on. I don't need to, story time is over. All right. Learning time now. Let me make sure I got everything set up. Good to go. Hello YouTube as well today. Hey Y Student, hey Raziel Dean, hey Reki Maru, hey Neo. Welcome in, guys. I don't think that is showing up here properly, so I'll just have to keep an eye. We want more. Want to hear about the emotional morning I had? I do. Tell us another story. Story time. More stories. Hey, be later. The link didn't work for me? That link didn't work? This link? Did this link work? Okay, so there are actually two parts of it. Well, there's one main part, and then we're gonna look at a specific part of it. Okay, so ooh, sorry if that was loud. Hello, Adam. All right, so now that everyone's here, welcome in, everyone. Today we're going to be looking at artificial intelligence for beginners. Now it says for beginners, but it's going to be going into things like the math of AI, the physics of AI. We're going to be looking at goal-driven behavior, such as setting up a goal-driven goal-oriented. What does this stand for? Goal-oriented. We're going to learn that too, and we're going to learn. There's like in the math when there's vectors, calculating distance, dot product, cross product. This stuff's all very useful. This stuff I'm mostly familiar with, but we're gonna probably go over some of that stuff anyway. The A-star algorithm, that one's gonna be new for me, and it's something I've been wanting to look at. Waypoints and graphs, navigation meshes, finite state machines, autonomously moving agents, crowd simulation, goal-driven behavior, and behavior trees are all on this list. So the course itself is actually 21 hours and 5 minutes. So we won't be doing all of it today because there's not even 21 hours left in today. But we will start with the GOAP environment. What is goal oriented? It's gonna bug me. Action planning, goal oriented action planning. So getting your NPCs to do stuff with this. This one is, sorry, this is the beginning of it. This is the one here. Goal-driven behavior. So, I guess we'll be starting. That's the first part of it. Goal-driven behavior. We will be looking through probably we'll maybe start with the introduction to the AI stuff, and then we'll dig into this one because this one's already 4 hours. So we're gonna do intro into artificial intelligence. Then we're gonna do goal-driven behavior, and if we have time, we'll start looking at some of the other things like A-star algorithm, physics of AI, stuff like that, and see what we learn. We may do some more tomorrow of this if we don't get through enough today. I do kind of want to go through the whole 21-hour course in general, but for today, we're going to start with just some of it. So I'm excited to learn this stuff. I've been doing things, I've got things working pretty good at the moment with Strain, but it's obviously useful to learn more and see if we can iterate on it, make it better, have a better understanding. There's a lot of good tutorialists, our friend Code Monkey, but I do like to start with the official documentation for things, especially if there's like Unity Learn is made by Unity. So I think that they make sure to cover the stuff that they have. What I usually do is start with Unity Learn and then go on to YouTube tutorials or Udemy or whatever afterwards, to get a second person explaining it. And like, I don't know, I like to just digest information for as much as I can on a topic. Then you get like a really good understanding. So working in data science, ML, and AI, I'm very interested in seeing this. Adam, okay, I need to be very clear. This is AI in the sense of traditional game enemy AI, which is not the same as neural network type stuff, which is very interesting. It's very cool that you work in data science, ML, and AI. We have a couple people here who do that, and I love hearing about your guys' work, especially when it's like, especially when it's used in like really innovative ways. I think there's obviously controversy around like AI making art, especially generating art off of stuff that they found on the internet. There's a lot of controversy around it. That stuff's a little bit more like, it's like interesting, but comes with like some consideration. But there's some stuff that's people using AI for that's like, I don't know. I'm seeing it in healthcare and science and research. It's a pretty powerful tool. In any case, we're not doing neural networks today. This is going to be we should almost say like NPC behavior is basically what we're doing. NPC including enemies. Still interested, cool. So I'm referring to this kind of AI as heuristic-based AI for differentiate from the ML stuff. I think we just need to remove the word AI because I feel like AI was a concept that was created or that people talked about a long time ago before we had any like neural networks or the type of, we have so much technology now that we need to like better define what we're talking about, I think. Adobe Firefly removes all controversy, does it? Oh, there we go. So to do what exactly? Will this replace the code you did to control when the NPC gets more angry? It might. We might use this information to make that better. I mean, basically, Unity Learn wanted to work with us, and they're like, what would you guys like to learn? And I was like, I think this is a topic. I presented a few topics, and this was one that I thought was really valuable to most game developers, because if you can know this stuff, like, I should move this over so you can see. If you can learn these topics, like, you can just make so many more games confidently with these tools in your toolbox. I've been doing enemies and NPCs without having gone through this tutorial yet, and I'm getting it to work, but it is very complicated, and I still have more to do. So better late going through this than never. I'm going to have a better understanding after going through this. I can go back to my regular code, maybe adjust it to work in a different way if I need to, or just add to it in a way that that's like going to improve it. Oh, hello Spanish boy, how's it going? Which page is that? So here is the link again, if anybody needs it to follow along. Again, this is the full thing, so bookmark that. If you guys want to come back to it later, you can. Otherwise, we're going to start with, well, we're going to look at the first part of this, and then we're going to go into goal-driven behavior, which is a subsection of the Artificial Intelligence for Beginners class. Hey, King Beers! Thank you for 14 months. Thank you, King Beers. How are you doing today? Hello, an unrealistically beautiful girl. Oh, thank you. Why, thank you. Very kind, very kind. Glorp. All right. So, can you study algorithms? We may get into that. We've only got so much time in a day. So, let's dig in without further ado. Let's see what the intro to the course can tell us more about itself.
Hi, welcome to this course on AI for beginners. In it, we're going to be using the Unity game engine and C# to recreate some of the most popular AI techniques that are used in games. To begin with, we start with the mathematics and also the physics of games, characters, and how you can actually put that together in the Unity game engine and what programming is going underneath. Now, I won't lie, it's not that simple that it's like a complete breeze. So even if you do think you've got a good grasp on mathematics and physics, do just have a look at those two sections before you jump into the others. We're then going to look at one of the most popular, or I should say the most popular algorithm for searching through graphs and pathfinding and used all over the place within games, which is the A* algorithm. You may have heard of it. If you haven't, you'll certainly understand it and know how its importance in this course content by the end. I've got a few treats in store for you too. I've got a vehicle system that you'll be able to program the movement of vehicles around a circuit, and a little bit of AI in there that will help them avoid each other and from crashing. And if they do crash, they can reverse out of the issue. I've also got goal-orientated action learning, which is a concept that was used in the game Fear, and it's probably one of my more favorite concepts for developing a full sort of behavior and action.
Wait, is this Penny? I have done one of her courses, but I didn't see her in the course. I only heard her. Is this her? And it wasn't an official Unity one, so I don't know if this is her or not. Yeah, this is her? Okay, awesome. Yeah, I'm glad she's doing it. She's a good tutorialist. I wonder if this has faster... Are you guys good with one... I don't know. Why is it sad that I'm taking information like short so much that I have to put my speed up? Tell me if this is too slow.
For my NPCs. We're also going to look at behavior trees and a whole heap of other things that you will need to get under your belt if you want to start creating game characters that can really fool the player that they're alive. So anyway, I hope that you really enjoy this course. It has been a course that I've developed for many years, and I'm now just updating it once again to the recent version of Unity. So you should find all fresh new content ready to go for you. So you're not going to learn much sitting here and listening to me waffle on. So I will see you in the first tutorial where you can get your hands straight onto creating some game characters.
Yay! Okay, is that too fast? Should I go down to 125? All right. Welcome to the course. Good. Mm-hmm. 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 Okay, we'll do another one and we'll see. This is intro, so if we miss stuff, it won't be a big deal. It's more like, you know.
The most common question I get asked by students is not what is artificial intelligence, but what is the difference between artificial intelligence and machine learning, as there are many common misconceptions that the terms are interchangeable. However, they are not, and in order to understand the differences, we really need to take a look at what artificial intelligence is. In a nutshell, artificial intelligence is the intelligence demonstrated by machines, whereas natural intelligence would be that possessed by most living creatures. The field of AI became an academic discipline in 1956. The traditional types of problems that AI worked on were the replication of the human abilities of reasoning, knowledge representation, planning, learning, natural language processing, perception, and the ability to manipulate objects. When it comes down to it, AI is really all about having a machine learn to adapt to new situations. However, doing this currently with a holistic approach is somewhat daunting, as psychologists are still trying to figure out how humans work. Thus, we get this mass of much smaller and concentrated fields attempting to solve just one area that might be considered a part of intelligence. The many applications of AI include robotics, planning, vision, speech, expert systems, natural language processing, and machine learning. Notice how machine learning is just one very small part of the whole AI dominion. AI, as it is applied in games, until recently, could hardly be considered artificial intelligence in the pure academic sense. In the academic domain, researchers are trying to produce a truly intelligent machine. However, game developers are really only interested in simulating intelligence or creating something that a human player could be tricked into believing was real. So, academic and gaming AI are very different beasts. Though if I had to point to the areas in AI where games have pulled inspiration from the most, I would go to the planning and expert systems. But if I hear you jumping up and down on your seats, pointing at the screen and screaming, "What about machine learning?" well then you're absolutely correct. In recent years, machine learning has gained a lot of traction in games, as it has the potential to create game characters with the levels of intelligence to adapt to changes in their environments. Though to really understand machine learning requires a high level of mathematics and statistics knowledge, as well as an appreciation of how it can be applied in games. And currently, in about 95% of today's games, machine learning would be a complete overkill for the types of functionality that you require. However, what you're going to learn in this course are the bread and butter techniques of AI in games, the time-honoured methods we have been using for decades to get non-player characters to move around their environment, interact with the player, and exhibit traits of being digitally alive. So strap in for a fun-filled ride through the most tried and true algorithms as we apply them in Unity with C#, and I'll show you how you can apply AI to enhance your own game projects in the future.
Cool. Okay. I want to do the whole course. I don't want to have to skip it. Are these the length of the videos? I think it is. We're trying to get through as much as we can. We're gonna go in 1.5.
This is Stevie. She's here to demonstrate how important an understanding of vectors is for programming movement in games. Whether you want to move an NPC or turn a character, getting your head around the way they work is essential to ensuring your game behaves the way you intend. A 3D character has two vector spaces, one that is local and one that is the world. Each space is defined by the axis X, Y, and Z. Sometimes these spaces align, but more often than not, they don't. For example, as shown here, Stevie's local Z-axis is pointing in a different direction to the world Z. In Unity, the world space orientation is represented by a small axis system in the upper right of the scene window. To see a 3D model's local axes, you can select the character and press the W key to reveal the X, Y, and Z. A model will not be aligned with the world if it has any values other than 0 as its rotation. Movement in any space can be defined by a vector. They are represented by an arrow that has a direction and a length called the magnitude. The direction is specified by the number of steps in X, Y, and Z the vector covers. For example, in 2D, this vector covers 3 steps in the x and 2 steps in the y, and therefore it is represented by the direction 3, 2. Its magnitude is calculated using Pythagoras.
Hey Montresor, how you doing? Hey Heiner, hey anyone else joining? So if you guys are just joining now, we are learning enemy and NPC behavior with some complicated stuff, which I'm excited to dig into. We're familiar with some of these things, but not all of them. So if you guys know some of them, just consider it reinforcement learning. And if you are not familiar, then you can learn something new and maybe dig into it further and get that better understood. Hey Matt. So we're just at the intro right now. She's just talking about vectors, and then the next module, I believe, they go into the math a little bit more. So this is more of an overview.
Pythagoras' theorem. This takes the square root of the addition of both coordinates squared, or the square root of x squared plus y squared. In this case, that would be the square root of 3 squared plus 2 squared, which results in 3.6. We can then say the vector 3, 2 has a magnitude of 3.6. A vector in 3 dimensions has the exact same properties with the addition of the z-axis value. It is therefore represented by the steps in x, y, and z. This vector would be 4, 1, 2. Its magnitude would be the square root of 4 squared plus 1 squared plus 2 squared, or 4.6. A vector has no set starting position. It simply represents a direction. The same vector can appear anywhere. This makes them useful for specifying the movement of a game character. Adding a vector to the position of a game character will move them to a new location. Each of the x, y, and z values are added to the character's current position. In Unity, we can do this with a translate statement. It is elementary to perform this operation in your head, where the new position is the starting position plus the vector. When a vector is added to a position, the result is a new position, where the x values have been added, the y values have been added, and the z values have been added. If the same vector is added to 2 different characters at different locations, each will move by exactly the same amount. Though note, they will not end up in the same location. They are merely adding the same steps to their x, y, and z positions. And since they start in a different position, the result of adding the same vector will be different. However, because the vectors being used are exactly the same, the characters will move in parallel. Often when designing an NPC, you'll want the character to move to a goal location. Even seemingly random wandering still requires some point in the world for the character to aim for. This requires calculating the vector between the character and its target. The vector is found by taking the character's position away from the target position. Once you have the vector, you can use it to move your character towards its target. If you want a character to move little by little along a vector, then you can't add the entire vector in one go. You need to add a much shorter vector that points in the same direction, and add it with each update loop to give the appearance of movement. To find a vector that is shorter than a given vector but points in the same direction, we divide it by some value. For example, if you want a vector that is half the size of the original, then you would divide it by 2. This new vector's coordinates will be the x, y, and z of the original, all divided by 2. And although the coordinates of the vector changes, it still faces in the same direction. But how much should you divide a vector up for a character's movement? If you divided the vector by 4 and added the smaller vector each update, the character would take 4 updates to reach its goal. Here's Stevie trying out some different dividers for her goal vector. You'll notice the smaller the divider, the less updates Stevie will take to get to Granny. In addition, this makes her move much faster. As the dividers increase, the movement becomes more fluid and she covers the distance in a longer time. If you divide a target vector by a fixed number each time, then the NPC's speed will change depending on the distance. In this case, you can see that dividing both scenarios by 10 will give smaller vectors. But the smaller vector over the longer distance will be longer than the smaller vectors for the shorter distance. Here's Stevie putting it into practice. In both examples, the targeting vector is divided by 1,000. This gives Stevie 1,000 updates to get to her goal. As she has a long distance to cover in the same number of loops in the bottom, on the bottom she will move much faster. So rather than dividing all targeting vectors up by the same amount, we want to reduce the smaller vectors to a standard size such that they are all the same length. And this standard size is 1. We can find a length 1 vector pointing in the same direction as a larger vector by dividing the larger vector by its magnitude. This process is called normalizing. When Stevie uses the normalized vector to update her movement, it doesn't matter how far she has to travel, she will move with a constant speed. Unity makes working with points and vectors straightforward via its vector3 class. A vector3 has an x, y, and z value that represents the vector's coordinates. If you're familiar with Unity, then you'll have already been using vector3 properties, as the transform for game objects uses vector3 for the position and scale data. You can work out the vector from a character to a goal by minusing one from the other. This will result in a vector. It's easy to find the length of this vector using the magnitude property. To get the normalized version, you simply
use normalized. Vectors are an extremely powerful concept and there's much to learn, but now that you have a few tips under your belt with respect to using them to move a character, best we get started on some practical exercises.
All right, everybody got that? Wrote down some notes on normalization in your copybooks. Just say normalize vector, then speed times delta time, and move on. Well, they're breaking it down so you understand it. You don't just type in those things without not knowing. And I'm sure that we've all typed in some algorithm that we're like, I kind of understand it, but I can't really picture it. So hopefully this will help us picture it if we have a better understanding of the math behind it as well. Practical exercises. Normalizing, bring it down to 1, so it's a standard unit for the vector, so you can control the direction, and it's not going to be moving at weird speeds. For vector math stuff, if you alliterate mathematically like me, I can recommend Nature of Code. He explains it super well. Okay, cool. So there's some stuff we can dig into further. Hey, Passion, vector length. Hello, how's it going? Hey, Sleepy Dragon. Just popped in, did the goal-oriented action planning tutorial a couple months ago. Well explained. Glad to hear that you liked it. Up, down, down, right, left, A, B. What is it? A, B. Okay, so that's the not so scary vector math. We can dig into, how long did that say it was going to take? 20 minutes? Did that take 20 minutes? I'm trying to gauge if we have time to do everything. I don't think we do, even though I would like to. Cartesian coordinates, vectors, calculating distance, dot product, cross product, autopilot. This stuff I am somewhat familiar with, but it would be nice to do a review of it. The physics of AI. Let's see what the breakdown of this is. Time, velocity, acceleration, calculating trajectories. This is where my schooling comes in to help. Those things are relatively familiar, but a little bit, it doesn't hurt to get refreshers. A-star pathfinding. This one I would also like to learn. This one is 1 hour, 40 minutes, but we should probably do those before. Waypoints and graphs. Following a circuit and tracker using A-star waypoints, simulating graph API. I'm wondering if we need the other stuff to start this stuff. There are a good chunk of tasks here. Maybe what we do is we'll try to go through this, and if we feel the need to, we can go back and do the previous tutorials. Let's take a look at an intro to goal-oriented action planning.
Goal-orientated action planning, or GOAP for short, is an AI technique that was devised by Jeff Orkin of MIT in the early 2000s. It was successfully applied in the game Fear to control the behaviour of the NPCs. If you want to learn more about it, you can read through the research papers available at this address. GOAP has all the elements of a finite state machine, but works with them very differently. For example, the finite state machines, as you have seen before, define behaviours and conditions to drive the NPC at fulfilling some goal. To achieve this with a finite state machine, you could have one massive graph or divide it up into smaller units. GOAP also uses graphs for its processing, but differs from finite state machines in that the actions and goals are decoupled. Actions are free elements within the system that are mixed and matched to meet goals when they are presented. Instead of having a set list of actions that need to be performed to achieve a goal, GOAP allows for numerous solutions to be chosen from. So instead of a system that looks like this, in GOAP all the links are removed. Then when a goal is presented, an appropriate course of action can be chosen from all of the available tasks based on the state of the agent and the world. For example, if an agent were asked to kill an enemy and it didn't have a weapon, it could choose a physical fight. However, if it did have a weapon, a different set of actions would become available. Every action in GOAP has a precondition and an effect. The precondition is a state that must be met before the action can take place. The effect is how the action leaves the state of the agent or the world after it has occurred. A set of actions forms a kind of puzzle or set of dominoes, where the preconditions can be matched with effects and the effects matched with preconditions to create action chains. Let's look at an example. Consider this set of actions. If you take a close look, you will see they focus on eating. If you take a closer look, you might be able to see two plans that you could form yourself. One for ordering pizza and one for baking. An agent with these actions won't do anything until presented with a goal. In this case, let's trigger the goal hungry equals false. The goal is the end state of the agent, not the starting state. If you think about it, a recurring human goal is to have hungry equal false as often as possible. Plans can generally only occur when the world and or the agent are in a particular state. For this example, let's add two. Has ingredients is true and has phone number is true. The planning stage in GOAP always works backwards from the goal to see if it is achievable. It does this by matching the effects with preconditions into a chain. It works all the way back to the world states. If it can't find a matching world state at the end, the plan is abandoned. In this example, there are two possible plans available: order a pizza and bake something to eat. Notice the reuse of the eat action. It fits into both plans and illustrates how actions can be mixed and matched to form different plans. As long as the preconditions and effects fit together, any actions can be chained together. Now that we have two plans that will achieve the goal, which one do we choose? Simple, we add a cost to the plans. We might assign each action a monetary cost. In this case, the pizza plan works out dearer, assuming we already have the ingredients for baking. We might instead opt for a time-based cost as well. This would make the baking option more costly. With costs assigned to each plan, when there are multiple, the cheapest one can be selected first. If there are multiple plans with the same lowest cost, then one can be picked at random. A conceptualization of a GOAP system looks like this, with actions, goals, and world states being fed into a planner. The planner chains the actions together according to the goals and starting states to determine which plans are achievable. The planner uses the A-star algorithm to find the best plan using the cost values. Once a plan has been generated, the agent goes about achieving it using a very, very simple finite state machine that basically moves the agent to where the action needs to take place and then performs the action. The agent works its way along the chain of actions until a goal has been achieved. Before each action is performed, it is always checked to see if it is still valid. If not, the entire plan is discarded and another one is generated. The beauty of GOAP is that more and more actions can be added to the pool available to the agent, and these will automatically be picked up by the planner. This means very little extra programming to recognize graphs like the ones in complete setups of finite state machines, as the graphs are generated on the fly by the planner. This makes GOAP a very powerful and flexible option for programming the behaviors of your NPCs.
That is actually really cool. That is not how I have strain set up right now. I'm using a state machine. So this is pretty interesting. Let's take a look. I wonder if we'll need to know the A-star algorithm stuff for this. Again, if we need to backtrack and like go through some of the other stuff, we will do that. But let's keep going.
In this lecture, we're going to start putting the GOAP system into practice. So what I want you to do is create a new Unity project and bring in the starter package that's attached to this.
Oops, sorry. I'm muting it when we're listening so that we don't get like feedback from my mic. But I'm just setting up a project. We're gonna do LTS 2022. We'll do built-in for now. We don't need to connect it to anything. I'll put it in a place that I can find it. We'll say GOAP tutorial. That's the folder. And there we go. And while that's starting, we'll continue watching.
Lecture. You're going to find when you open up the basic working hospital scene that's in there, a very simple little hospital, which looks like this. Okay, now what you're going to find with this hospital is it has a nav mesh on it, and we're going to use the nav mesh to get our agents to move around between their different goals. Over in the inspector, I've also got my navigation tab open. Now, if you don't have that, you can go to Window, AI, and Navigation to bring that up. If you add new objects or move things around, create new walls and that, make sure you'll always come back into the navigation and click on bake so that those things will be taken into consideration. And if you click on something in here like this wall, just grab hold of that, and over in the inspector, you'll see that it's actually set to a navigation static. If I bring that in, and everything that you want to be excluded from the nav mesh or to be a barrier in the nav mesh has to be a navigation static. So everything you can see in here, the plants included and these cubicles at the back are all navigation static objects. Okay, so we need some agents. What we're going to do in this
Oops, there we go. Okay, I think our project's ready. So let's bring in the package so we can follow along with this. Import. And this is the scene. There we go. And hey, Jo, how's it going? You did this course? Nice. Okay, did she say to do anything yet? I missed the last little bit there.
we need some agents. What we're going to do in this simulation is a very simple little hospital. Patient's going to come in and get registered at the reception desk, which is just over here. Then they're going to go into the waiting room over here. We'll have some nurses. The nurses will stay over in the staff area if they need a break. Otherwise, they're going to come out and get a patient. So patients will come in, register, go in the waiting area, wait for a nurse. The nurse will pick them up and assign them to a cubicle. They get treated and then they'll go home. The nurse will be freed to get another patient or to go and take a break. The first thing we'll need are some agents who will be our GOAP agents that have some goals to achieve. If you open up the prefab folder, you're going to find some medical staff and a patient. I want you to get hold of your patient and drag and drop it into the scene. Okay, and just lift it up so it's sitting on the ground. Okay,
I encourage you guys to join along. Again, there's the link. We are on the goal-driven behavior section of that tutorial, and we are currently on the first step, setting up a goal-oriented action planning environment. There is a package that you can download from here, and you bring it into your project, and then you guys can follow along as well. So we're looking at prefabs, patient, and looks like he's in a good spot. Let's keep going. Love learning all kinds of game AI stuff. Yeah, this is gonna be good. Oh, you built it already. Cool. Some of you guys have already done this. That's awesome to hear. Awesome. So we'll go through it together. Again, maybe it will be a good refresher if you guys forgot.
This patient is just a model, so he doesn't have a nav mesh on there. So let's just get in a little closer so we can see what we're doing on this patient. I want to make sure he's lifted up so he doesn't go through the ground. Okay, so the first thing, go over to the inspector, add a component, and add a nav mesh agent. Now, when you add that, it's going to center itself in the middle of his body down there and go above. And if we just move over a bit closer, you'll be able to see that a little bit more clearly. So we need to move it down. Over in the settings for the nav mesh agent, you've got a base offset, and you're going to just slide that until it hits the ground. Now,
let's do this before I forget any steps. So we need a nav mesh agent. We want to make sure that I need to install the AI navigation package. Oh, I'm being, let's do it this way. Oh, should be in there. What is the problem? An operation exclusively requires access to a resource. Already running. You know what? Let me reopen the project and see if it just needs to be restarted to solve some issue there. Hey Loot, what's up? Hey Arkansas. Ooh, good Jack Skellington emote. Hey Beach Bun. Really cool course. I've done it and using it in my game. Oh, very nice. I mean, yeah, join along, guys. Maybe this will be good enough that you can use it to start. There's our error. Our error's gone now. Good. Maybe it's good enough to even do like a mini game out of. That would be awesome if we could do one by the end of this. If not, we might do one. I'd love to make some kind of little mini project based on this, just to kind of practice. So we added an NavMesh agent, and there was an adjustment she made to it. Where was that again? Not on here. I can see the outline is not quite right. Humanoid. Oh, it's not actually. There it is. There it is. It's not adjustable from here, it's adjustable from there. Okay, that's better. Let's close this and continue.
We want to make sure that it's near the bottom of the character. So he's going to be about unit size, and you shouldn't have to change the size of your nav mesh for it to fit the character quite nicely. Okay, so that's the patient. Now you also need to do that with the nurse that we'll be using in this tutorial. So just drag the nurse out, bring the nurse up a little bit, and then over in the inspector, again, we add a nav mesh agent, and we want to set the offset. Now the patient, we already set the offset, and it's at 1.05. Let's just make that 1, nice rounded 1. So we know if we go back to the nurse and we change her offset to 1, then it's going to come down and fit her quite nicely.
Okay, let's bring in the nurse. I can't see the bottom of it, but it looks like it's just the bottom of the character. Or like, offset is what it was. Radius. Oh, that's the bottom of it there. Weird. Okay, so let's bring in height. Base offset. Okay, there it is. Yeah, I'm familiar with this, but it's a little bit different than some of the other. I'm surprised I didn't do like the similar collider that we use on other, or the collider adjuster. I'm surprised that's not the same thing here. That is pretty good, and let's get the nurse doing the same thing, I'm assuming. Let's stick to base offset of 1 again, and that pretty much does it. Okay. Oops.
Now, throughout the simulation, the agents need to know where the waypoints are that are going to be sitting on this nav mesh so that they can move about. The patient, which is this little guy here, he's going to come in through the door. So there'll need to be a waypoint at the door. We're going to have them register. There'll need to be another waypoint there, and then one in the waiting area. The other waypoints they also need to know about are the cubicles, and then also a waypoint outside of the map to get home after they've been treated. The nurse will need to know about the nurse's waiting area, which is in here, the waiting area where the patients are going to be waiting, and also the cubicles that are up here so that they can assign patients to cubicles. If you go over into the hierarchy, you'll see that I've got game objects in all of those positions. So the very first thing on the list, starting at waiting area, is in the waiting area. And if we just go and see where that is, just here, you'll see, if I move it right up, that it is actually a cube that has been flattened out. Now let me put that back to 0 in the Y, so it's kind of sitting on the floor. The waypoint itself is that position there, not the actual size of the cube that I created, but when I started this, I was just planning out where these areas would be. It's very important that if you do use a cube or something as your waypoint, that you make sure that you don't have the collider turned on. If you want to see where it is, then that's fine. Turn on the mesh renderer so that you...
Wait, I lost my place when I went to wipe my nose. You're right, I do have a bit of a cold. Okay, sorry guys. So she added a cube.
that has been flattened out. Now let me put that back to 0 in the Y. So
wait.
See, if I move it right up. If you go over into the hierarchy, you'll see that I've got game objects in all of those positions. So the very first thing on the list, starting at waiting area, is in the waiting area. And if we just go and see where that is, just here, you'll see, if I move it right up, that it is actually a cube that has been flattened out. Now let me put that back to 0 in the Y, so it's kind of sitting on the floor. The waypoint itself is that position there, not the actual size of the cube that I created.
Sounds good, Laser.
But when I started this, I was just planning out where these areas would be. It's very important that if you do use a cube or something as your waypoint, that you make sure that you don't have the collider turned on. If you want to see where it is, then that's fine. Turn on the mesh renderer so that you can see where you've put everything, but afterwards turn that off. Now, the reason you don't want the box collider on is that the patient, in trying to get to this particular waypoint, will hit the outside of the box collider because they do respond to physics and never be able to get to the destination, which is here. Now, I've got another cube that I put over in the staff lounge over in this area, and again turned all of the rendering and colliding off. There's also a door. Now, the door position is in the center of this doorway here. Now, I guess you don't really need it because the pathfinding, if you were to go to the actual reception, would find its way through here anyway, because it is the only gap to get into the hospital. But when I started testing this, I actually didn't have any walls, so I was just making sure it went through there. So I've still got it there, and we're still going to use it as one of our destinations. The cubicles themselves are also destinations, as I said, and they're all just sitting there. And the reception desk. Now, so our agents can figure out where all these objects are when they get instantiated, I have put tags on them. So if you have a look at the waiting area, you'll see that it's tagged with waiting area. The staff lounge, the door with door, and etc. And if we go and have a look at those tags I created, you can see how they're spelt. And how they're spelt is very important because you need to use the string of the tag in order to match it and find it for your agents. Now, if you remember back to the previous video where we were talking about all the different actions that our GOAP agents can take, they're all matched together like dominoes using preconditions and effects. They will also be string values that we have to match, and therefore our spelling and capitalization needs to be exactly the same for each one. And therefore, we really should sit down and plan it out on paper or in diagrammatic form before we move ahead, just to make sure when we do go and type everything in that we know what things are called and we know which strings have to match with what other strings. So we'll come back in the next video and actually start planning out the actions for each of our agents and work out what is going to be needed for them.
Cool. All right. Yeah, it does take a bit to install Unity, Steve, but don't panic. We haven't covered too much yet. The package is at the beginning of the tutorial. So far, it's mostly been an introduction. All we've done is add a nurse and a patient and give them a nav mesh agent. And then we've adjusted the nav mesh agent base offset as well as the height to make sure that it matches the shape and size of these little characters. And she's just explaining the setup so far. It looks like we have these, I'm blocking it now at the top. We have the waiting area with the tag waiting area. And it looks like we're going to be using the tags to identify things in code. So these are important parts of it. So let's look at the next one. Yay. Okay, and if you guys watched the ad, welcome back. We are doing a course on NPC and enemy behavior. We are just at the beginning still. This is the pre-planning the agent actions. Let's take a look.
The idea of GOAP is very simplistic. However, figuring out the dynamics of it is not. There's goals and actions and states and all manner of other things to take into consideration. Debugging an entire system is very challenging, so it's best to start on paper. The GOAP system we are about to build isn't the be and end all of how to develop such a system, but just one way. You can use it as you like and modify it for your own needs. But basically it will work like this. We have an agent. The agent has a number of goals. These goals drives its sequence of actions. Some actions are only possible after other actions have been completed, but the environment or game world and other agents also play a part. For example, some actions might not be possible without the help of another agent, and other actions might not be possible without the use of a resource. When using GOAP, you are actually building a simulation, so you need to think about how you want the game to look and how the characters are going to move around the environment. In this case, we are going to create a very simple hospital simulation. There will be two types of agents, patients and nurses. Let's think about how we want the patients to work. We want them to come into the hospital, register at the front desk, go to the waiting room, be treated when a nurse and cubicle are available, and then go home.
Look at them. I know. I was like, I don't know. These are all made out of primitive shapes in Unity. We've got capsules, cylinders, spheres, and cubes to make these. I love the little mask on the nurse. They're really cute. Sue says, it's your very first meeting with my computer science friend, professor's computer science club last Friday morning. Looks like it's going to be a fun ride. Was it intro week? Surprised most of my fellow students decide on game dev and technology for the semester. Awesome. That's exciting, Steve. Glad to hear that. Shadow on it's so good. So dramatic. Yeah, it's true. Okay, this is great so far.
Each of these things involves moving the character to another location.
They are like little
They
pieces
be
of
our
Fisher Price.
actions. In GOAP, each of these actions exists as a single and complete task that are accompanied by the agent simulating some event. If you were to put together a plan for the agent to take to get through these actions, what would it be? Take a moment to consider it.
What are we going to do, chat?
How did you go? You probably came up with something similar to this. Go to hospital, register, wait for nurse, get treated, and then go home. Definitely a legitimate plan. But what we're going to do in our application is structure it a little more like this, so that the patient has 3 sets of plans. The reason that we're doing this is because in the simulation itself, the agent has other resources and other agents that it's going to rely on in order to continue through the actual game. Now, if you just wanted your agent to come into the hospital, go to the registration desk, go and wait, go over to a cubicle, and then go home without any other dynamics going on, then you could just have a single plan. Once we get into the programming of this, you will see why I have structured it like this with the 3 different sections. But for now, just trust me as we go through this. Now, if you remember, the whole point of GOAP is that every action is decoupled, okay? It's not linked to any other action. So when we want to create a plan to move through actions from one end to the other, we're looking for a particular goal that we're trying to achieve and then working backwards in order to match the actions together to come up with a single plan. The first one in this case is the top one that you can see on the screen, which is go to hospital, register and wait for nurse. Now, this will involve the patient having a goal of is waiting. And working back from that, we then think of what are going to be the preconditions for waiting for nurse. Well, that means that we have to have registered. This will then be the precondition for wait for nurse. That means that the register action needs to have has registered as its effect. And then moving back from there, before we can register, we actually have to be at the hospital. And so we have to make sure that we have linked up enough actions that have preconditions and effects that are going to match so that we do end up with a plan when the system is trying to find one. As for the other actions, in this case, which are forming a plan which only have one action, they must have an effect because that effect is the final goal that your agent will be looking at. And therefore, we also have to give them a effect. And if you want them to fire off, also a precondition. Our nurse character is going to be a little more simplistic and have 2 sets of plans to choose from. The first will be to treat a patient. Therefore, their ultimate goal is treat patient, and that's going to require a plan of picking up a waiting patient, which will require a patient to be waiting in the first place, as well as there being a free cubicle available. This will then link to our go to cubicle, where the treatment is basically taking place, which will satisfy the treat patient. Now, to make the nurse just a little bit more interesting, rather than standing around when there's nothing to do, there's also going to be a rest goal, and that goal will trigger when the nurse becomes exhausted, and therefore the nurse will then go to the break room. Before we start coding, let's have one more look at how this is going to conceptually fit together. We have an agent, and that agent lives in the game environment. Now, the game environment is going to have a set of world states, and that's going to be things like how many cubicles are available, how many patients are waiting, and they're things that the agent can draw on when it's trying to determine if it can achieve a goal. So in some cases, it will be some of the preconditions towards the goal. Now, the agent itself is also going to have a set of states about itself because, for example, if it is sick, that belief or that state belongs to the agent itself, not the actual game world. So I'm calling it beliefs in this case, but it really is just like the local world states that belong to the agent. Now,
Is this how humans work, guys? As our beliefs just our local world, what does she call it? Local world states? Whoa. I'm seeing our simulation more clearly with this tutorial.
belong to the agent. Now, the agent is also going to have a set of goals and a whole set of actions. Now, in order to align up all of these actions so that the goals can be achieved, we will have a planner. So every agent will have a planner. That means that with the information from the world states, the beliefs or state of the agent, the goal that needs to be achieved, and all of the actions that are available, the planner is going to come up with a plan, give that back to the agent, and the agent will then execute it. Okay, so that is the GOAP system that we are about to develop. That's how it's going to conceptually work. And once we get into the code, although it's essentially quite simple, there's still a fair bit of it to write and put together. So why put it off any longer? In the next video, we're going to come back and actually start the coding.
Okay, let's dig in. Beep, beep. Steve says, as a fellow lover of hospital stays, saying sarcastically every other year, I can confirm depending on the hospital branch. Aw, sorry you have to spend so much time in hospitals, but maybe this will feel, maybe you'll be the experts now on them. and how patients and staff will move around in it. Okay, world states. Looks like we're still going to start getting into some coding now. I didn't miss something, did I? Last one said it was going to be pre-planning the agents. Okay, I think we're good. Let's keep watching.
Ready for some coding because there's quite a bit to get through, and in fact we probably won't even get to a point in this particular lecture where we can run anything. But what we're going to do is start with the very basics and create some really base classes that we can build onto, and that's going to be the world states, the agents, and also the actions. So let's go ahead and create those files. So down in your project, let's create a C# file. I'm going to call that G agent. Then we're going to create another one, and we're going to call that one G action. And another one, which we'll call G world, and one more, and we will call that world states. Okay, so let's open up world states and we'll edit that one first. At the very top, I'm going to include, just above the actual class itself, another little tiny class, and we're going to make it serializable so that we can see it inside of the inspector. So system.serializable.
I'll put my code off to the side so that I can type along while we watch, and you guys, I'm sure, are probably going to be typing along. And then we'll take it from there.
And then we're going to have a public class world state. And in that state, what we're going to do is create a public string key and a public int value. Now, we're doing it so that you can actually edit these items in the inspector, because once we start building the system, you'll want to drag and drop a lot of things around as much as possible. Now, the reason that we're creating a world state with a key value and a value is that we're going to create a dictionary with these in. And the key itself is actually the world state. And then I've also added in this value, and the value is some kind of integer that you want to associate with the key, should you want to associate with the key down the track. For the most part, we're not actually going to use that, but we're using a dictionary, so we do need to have these two values in there. But let's say that down the track you wanted to have a world state was like free cubicles,
and then you could have in here that there were 5 free cubicles or something, and then you could test it when you extend this system. All right, so that is our little class with the world state, and we will use it inside of other classes. So let's go ahead and now do our world state here. Now, first of all, it's not going to be a mono behavior, so you can get rid of that and all of the other code that's inside of here. First of all, we're going to create something to hold all of the states of the world. So public dictionary, string int, and this will be called our states. So let's create our constructor, and that will be a public world states, and inside of here we just set up our dictionary. So states equals new dictionary string int. All right, so that's all that we need in there. Okay, now we're going to add a whole bunch of methods to help us use the dictionary. So to add things to the dictionary and to modify the dictionary and also set the states that are in the dictionary. First of all, let's ask if the dictionary has a particular state in it. So public bool has state, and we will pass through the key, and then we will return states dot contains key. Nice and simple there. You'll start to see why we're using dictionaries for this, because they're just so easy to manipulate and add stuff to, and to look for things without having to write an awful lot of code. All right, the next one will be to add a state to our dictionary if it's not there. So void add state string key int value, and then this is simply a states dot add and then a key and a value. Nice and simple. Next, we're going to add in a modify state. So public void modify state string key int value, and in this case I'm going to put if states dot contains key. Then obviously we've already added that state to our dictionary. Now, if it's in there, what I want to do is actually increase its value by whatever we pass through here, which means you could also take away by sending through like a -1 from here. So let me put in here, if states contains key states at that particular key plus equals value. If the state at that key is less than or equal to 0, I'm actually going to get rid of it. Now, that's because of the way I'm using this particular dictionary. If you're not going to use that and you actually do want negative values in there, then that is entirely up to you how you deal with this. So what we're going to do for this as an example is if we have a state like free cubicles, and there's 5 free cubicles, and then you send through another free cubicle 1, then it will update the number of cubicles to 6 that are available. If a cubicle is not free anymore, so you could send through a value of free cubicle -1, it will actually take away the number of cubicles that are available for use.
Hey Eleven, how's it going? Hey Hira. Welcome in, guys. We're doing some learning of NPC behavior. So we're following this tutorial from Unity Learn, and yeah, I'll go through this with the video, and then we can review it at the end to make sure that it all adds up and we understand it all.
Okay, so once we've done that, we're just going to go else states.add key value. So if it doesn't exist and we're adding our first cubicle, so cubicle 1, it's going to add that in there rather than incrementing it. Now, we haven't written remove states, and we'll get to that right now. So public void remove state string key, and then in here if states.contains key, then we will states.remove the key. Easy, especially if you spell it correctly. All right, so that's the modifying and the remove. Now let's have an actual set state. If we need to not modify it as far as adding a value to it, we just want to set what its value is. Public void set state. Again, we want the string key and the int value. And in here we're going to if states.contains key again. Then we can go states key equals value. Else we can add that state in. So state dot add key with the value. All right, so that's all of the sort of management methods that we need. Finally, I'm going to create one that we can return all of the states or return the actual dictionary. So public dictionary, string, int, get states, return states. So this will actually be used by the planner when it needs to get hold of all the states of the world and all of the states of the belief. All right, so I've just noticed I've got one little problem up here with that space in there, so I'm going to get rid of that. And the rest of the code is...
Her code is fine, but I think I need to do some correction, so I'm going to pause it here. Can you overcam to the other side? Oh yeah, am I blocking? Oh yeah, I am blocking, but thanks for the heads up. Let's move it over here. Okay, so let's review this. We have the class up here, world state, with a key and value. We have world states. We're setting the dictionary called states, which is a string and int. And then public world states sets the states equal to a new dictionary. And then the bool has state, takes a key and returns whether or not it's there. Okay. Add a state, takes the key and value and adds it. That's pretty straightforward. Modify state, takes in the key and value, and if it already has the key, it will states at the key, it will increase it by the amount, and then if state's key is less than or equal to 0, we remove the state. Okay, so in case that's negative, then this will get rid of it, so it doesn't contain it anymore. And if it doesn't contain the key, then we add the key with that value. Removing a state, which we do up here, takes in the key, and if world states contain, is it supposed to be world states? I think this is just supposed to be states. I think I might have auto-corrected on me. So if the states contains a key, then we remove it. And if we're setting a state, we check that it contains it, and we set the key to that value. Otherwise, we add it. That one's interesting. Okay, I'm not sure how we're going to work with that one. And then there's a dictionary of... Oh, this is returning a dictionary from get states, so we can get it from using that function. Okay, that's pretty straightforward, I think. Hey, silly goose. Hey, Heiner. Hey, Cuddles. How to handle chat's behavior. Maybe we can work with that. Maybe we can work with how to handle chat's behavior once we know some more skills. Any thoughts, questions? Chat, how you guys all doing? Shall we continue? Let's continue.
Is good to go. So we can save that now that we've...
Road to Vostok has interesting AI. The behavior is decided on heuristics, but the behavior is simple goals themselves. Yeah, this sounds like a fun way to go about things. Hopefully we can make like a little mini game out of it by the end of the day. Let's see.
Written our world states class. All right, so just quickly back into Unity so I can open up our G world class, and that is also not going to be a mono behavior, but what we're going to do with it is create a sealed class, and this will help us a little later when we start using queues and that to queue things up so that we don't get any sort of conflicts in trying to access particular parts of this class, which really should only be accessed one thing at a time. Okay, so first of all, we're going to create a private static read only G world instance, which equals a new G world. Now, I didn't mention this, but we're also going to make this into a singleton so that
we can access it pretty much everywhere, and we only ever want one version of the game world environment states because there's only one game world, so we don't want to have copies of it with different values in it. Okay, so private static world states. World. That's our dictionary holding all of our states. Okay, so let's get rid of those starts and updates because we don't actually need them. Then we will have our constructor, so static G world, and in here we're going to create world equals new world states, which is just a new dictionary. And that's all we need in there. Okay, then let's create a private G world and set everything up so that we can actually grab this with a singleton. Public static G world instance, and this will be a get return instance. Okay, and then one last thing we'll put in here is a public world states for get world so that we can actually return the status of the world. Return world. Okay, so that's all we need currently in world. We'll come back and create a few more methods and other dictionaries in here as we need them as we start building the simulation. Okay, so that's our basic world and our world states.
Okay, cool. Next, actions. Looks like we might need this.
Hi, welcome back to our building of this GOAP system from scratch. We're now going to, having already created the world and the world states, is work on the programming of the actions. The first thing we're going to build are some actions. So let's go into that script, and the action itself is going to perform the action. It's going to take...
Oh, I just realized I want to catch up on the YouTube chat as well. Eileen's sister, hello. Hello, Neo. I think we're all good. Cool.
Care of the, not necessarily the running of an action, but all of the details about a particular action. Now, we're not going to use this G action as itself, okay? We're actually going to inherit from it. So we're going to create an abstract class in this case. Now, before we continue through the rest of the code, we also need to use the Unity engine.ai because we're using a nav mesh and therefore we need to access that, and you'll see that a little bit later. Okay, so up the top, let's go ahead and declare all of the things that we can set about a particular action. So these will all be public so that you can set them in the inspector. First of all, we have an action name, and you might just want to set that to action just as a default there. Then a public float for the cost of the action. We'll set that to 1 by default. I should mention about this cost is that your planner will find the cheapest plan to work through. So each action has a particular cost, and it's going to try and go with the one that's going to be sort of the less strain on your agent. Doesn't mean that you'll necessarily always do the lower cost plans, especially if they're not achievable, and you might have to do another. But I guess you can think of cost as like, does the agent actually want to do that particular action? Like, you know, how much does it really dislike doing that action?
I like that we're assigning these types of things to the character. It's like, I don't want to do that one. I don't want to have to do that one. And I feel like that has the opportunity to make some interesting NPC behavior.
so that it will do something that's a little bit easier. And I guess you could think of it in terms of games like The Sims, where they will have things that are their more favorite actions and that they'll do, and they'll do them more automatically. But if that's not available, then they will do something they don't like. And if they don't like it, because its cost is much higher, then their emotions get affected. So you could also use this cost in factoring in how your agent feels if you want to go into that kind of emotional side of programming these agents, which we're not here, I must say. So next we need a public game object for the target. Now the target is the location where this action is going to take place. So we have to move our NavMesh character from one spot to the other. Okay, then we're going to have a public game object target tag. And this is so we can pick up game objects using the tag, find them if they exist in the hierarchy, just in case we don't actually have a target up here. And you'll see that used shortly. Public float, we want a duration of the action. How long is it going to take? How long should we have our agent standing around at a particular waypoint virtually performing the action? And then we need some world states. So we need a public world state for the preconditions, and we need a public world state for the after effects. So these are the items that our planner is going to match on either side of the action, if you think back to the diagram that we had with all our actions linking up like matched dominoes. Okay, so next we need a public NavMesh agent, which is our NavMesh agent attached to our agent for moving it around. And then we're also going to create a public dictionary, string int preconditions, and a public dictionary string int of the effects. And what we'll do with these world states here is this allows us, remember how we made the world states system serializable up here and we're using world state, we can see these in the inspector. So you can type in all of your preconditions and your effects in the inspector. But when we want to go and plan with them in our planner, it makes a lot more sense for them to be in a dictionary. It just makes it way easier to actually work with them. So we're going to use this to get them by the inspector, and then we're going to put them into these two dictionaries. Next thing we need is another public world states, which are our agent beliefs or the state of our actual agent itself. So it's got an internal set of states that we'll work with. And then we finally up the top here, public bool for running. So are we performing this action at this time? And we'll initially set it to false, because when we are performing an action, then we don't want to go on and be performing another action. So now let's go ahead and write our constructor. So there'll be a public G action where we declare our precondition. So preconditions equals new dictionary string int, and the effects equals new dictionary string int. Okay. Now, what's going to happen on the awake? Well, we need to set up all the bits and pieces that are going on with our actions. Initially, we're going to have to populate these two dictionaries with the values that are put into the inspector there, and we also need to get hold of the NavMesh agent that is on the same game object. So let's create a public void awake, and we'll set our agent up first. So agent equals this dot game object dot get component, and we're getting hold of our NavMesh agent for that. And then we need if preconditions does not equal null, so there's actually something in those preconditions in the inspector, then we're going to loop through them. So for each world state W in preconditions with a capital C, then we're going to go and add it to our preconditions dictionary. So preconditions dot add W dot key and W dot value, like that. And then we need the same thing again for our after effects. So let's just copy that and put it down here. This will be if the after effects aren't null,
Then we're going to get all the world states out of After Effects, and we're going to add them to our effects. Okay, so we're now going to add in a few helper methods here that our planner is going to need. And first of all, we'll say public bool.
Wait, I've got some underlines here. Hang on. After Effects. Let's take a look together. I'm curious also. M asked why it's called Mono Behavior, and Jo said he looked into it. So Mono is an open source version of .NET Framework. Framework here is basically a middle layer where we can code in the framework and trust the framework will translate our code to the appropriate instructions needed for whatever processor hardware is running on. Normal .NET Framework by Microsoft, but open source one here lets Unity tailor it for a bit better use. These were called mono behaviors in Unity because at one time you could also have like JavaScript behaviors. Interesting. According to Mono Project's documentation, what does the name Mono mean? Mono is the word for monkey in Spanish. We like monkeys. Interesting. So it's not like meaning one like it usually does. It's just a term that they have for it, mono behavior. That's hilarious. It's for monkey behavior? Monkey behavior? All this time? All this time we've been using monkey behaviors? Whoa. I didn't realize that. What did I do wrong here? Oh, not After Effects. I thought she was saying she meant After Effects. I was like, I'm reading it like, what? It's this. I was like thinking of the software, like After Effects, like video editing. I see. So effects is not null. So if preconditions are not null, for each world state W in preconditions, we add those key value pairs. And for the if the effects is not null, for each world state in effects, we add those pairs. Why am I getting an underline here? What am I missing? Do I have oh, no, After Effects. Oh, I see. So we have preconditions and preconditions. And here we have, oh, we have After Effects here. We're adding it to effects. Okay, so we didn't name this one the same one as the other one. We named this one just effects. That's why I got confused. Okay, I see. So it is After Effects in the no. The world state is After Effects. The dictionary is just effects. Okay, I think I got it. Let's continue.
Is achievable to determine if we can actually achieve this particular goal. And inside of here, we're just going to return true.
That's a question I ask myself all the time. Is this goal achievable? I have run this function very frequently.
Just assuming that we can. And then the more important one, which is a public bool, is achievable given. And this will be, is our action achievable given that there's certain preconditions coming in? Okay, so this will be dictionary, which will be our string int for conditions. And then inside of here, we're going to go for each key value pair of string int. So our precondition in precondition. So we're looping through our preconditions that we've got stored for this particular action, and we're looking for each of these conditions to make sure that it actually does match them. So if there's no sign of conditions dot contains key of p dot key, then we will return false. So we can't actually do this because the preconditions aren't met. And then we will return true if we've made it all the way through and found that we have matched all of the preconditions for that. Now, finally, we just need to, and we'll get rid of those two methods because we're not going to use them. We're going to add in two public abstract methods, bool pre perform and public
abstract bool post perform. So remember, we're going to inherit from this particular class, and we want to make sure that we force there's a pre-performance and a post-performance method that you write, and that will allow you to put in customized code for each action that you can do other checks before an action actually starts, which is to do things like ensuring certain resources are available or other agents are available, and then any other post conditions that might come out of the particular action as to whether you're going to affect the world state with that action or whether you only affect the agent. All right, so
Hey Tom, thank you. And thank you, Donald. Just catching up on some stuff here. Hey Twitch Dog. Hey folks joining. I know, I was thinking of Adobe After Effects with that function or that variable name.
we'll save that now that we've got the action done.
Oh, okay, that lesson's done anyway. Okay, cool. Dude, I need this for anything? Did she mention this action script? I don't think so. Maybe it's just a script so that you can double check it with your own. I do have it, but I don't know if I want. It's a package. Let's take a look at what the package is. gaction.cs. So I already have one that would replace it. I think it's just in case you need a reference for the script. Hey, Original Speedster, hey, Arbona. Oh, Tom's Unity Dev, cool. What kind of stuff do you do? There's going to be a few basics, like how to format a function with brackets instead of just func things kind of stuff, but other than that, should be very similar. Okay, cool. Unity is cool. All right, awesome. Let's continue. How far into this are we now? I want to learn everything. Agents. All right, let's begin the agents one. Probably gonna need to open the agent script, I assume. Let's do that now.
In this lecture, we're going to start building the agent class. So open up your basic agent class that we've already created. At the top, we need to add in the link library. We'll be using that a little later for sorting our goals based on their priority. So it'll be system.link. Okay, we also need.
If you guys are not familiar with the link system, it has a bunch of stuff like finding the max value of something, finding the, ordering stuff. It's got a bunch of things that you could just do yourself, but it does it for you. So it's like you don't have to reinvent the wheel if you are going to be using this a little bit.
Need to add a little helper class at the top, which will define our goals. Now, usually in these systems, you can create just a single goal that the agent has, and the agent can go off and satisfy that goal and then come back. But in this case, we're going to create a whole bunch of goals that have sub-goals, and that will make the system a little bit more flexible if you want the agent doing really complex tasks. So we'll create a public class for sub-goal, and it's going to be quite short, but it's going to have a dictionary, of course. So public dictionary, and it'll be the same structure that we've been using all along because we need to keep it very consistent. And let's call it sgoals in here. And then we're going to also have a public bool remove. The reason being is that some agents, you want to be able to give them a goal. When they've satisfied that goal, then the goal gets removed from their list of intentions that they want to do. So for example, in the case of the patient might need to be treated. So he's going to come in. Once he gets cured, he doesn't need to go through all those things again, and therefore that goal can be removed. But if you want a goal that keeps getting triggered over and over again, then you can create one that you're not removing after it has been satisfied. So for example, the nurse is going to have a goal of resting. So the nurse can go off and have a rest period during the work shift. Now that will keep coming up over and over again. So that's a goal we don't actually want to remove from the system after it's been satisfied. It's just going to be sort of like an idle goal until one of its conditions gets satisfied. Okay, so let's now create this. So public sub goal, and we would pass through a string for our key value int I for its actual value, and the bool r for remove. Then in here, let's just set sgoals equals a new dictionary for our string and our int, and sgoals dot add the one we're passing through, so s and I, and then we're also going to do remove is going to equal whatever r is when it's passed through. Now, the agent itself is going to have a list of actions and a list of goals and those sorts of things. So let's at the top, first of all, declare a public list of G actions, and the G action will be the actions that we've given our agent to achieve. So here we have action, and that's going to equal a new list of G actions, or action, singular, don't put an S in there. And then we also need a lot of goals. So it's going to be a public dictionary of dictionaries. So basically it's a dictionary of sub goals, which are basically another dictionary. Int for our value, goals equals new dictionary, and then we want sub goal and int. And then we need a planner. So we'll call it G planner. We haven't actually created the planner yet, but this is going to be our class that goes off and does the planning given the goals. What it's going to return is a queue of the actions. So we're going to use queue in here. So it'll be a queue of G actions, or G action. Let's call that our action queue. And then a public G action for the current action, so we can keep track of what the agent is doing at any particular time. And then also the same thing for the goal. So sub goal, and that will be the current goal, and we will record that. Now in the start, we have to create our array of actions.
Thank you, Lucas, for 21 months. How are you doing? Should have to type it like she pronounces it, G planner. I keep thinking if everything's G, I'm thinking of like G fuel. That's an energy drink, right? I'm not imagining that. G fuel, G action, G planner, G fuel. It fuels gamers. G-force. Okay. Where are we now? Sub goal. Okay, let's go.
We're going to make this so that for our agent, you can create versions of the G action class up here and just drop them onto the agent in the inspector, which means that we need to pick them up when the agent starts working, and they're all going to go into an array. So G action, and let's call this acts equals this dot get component G action. And not only do we want one action, but we'll be able to put a lot of actions on there. So it's actually get components. So all the G actions that are sitting on the agent will get picked up and put into that acts. Then what we're going to do is for each G action A in acts, we're going to put that into our actions list. So actions.add A. Kind of a similar thing that we did with our actions, where we were creating these public arrays that would come up in the inspector, and then we were populating our dictionaries with those down in the awake. But in the agent, we're doing that inside of the...
Hang on, I've got a typo. So G action, so an array of G action, acts, get component. Oh yeah, if you're doing an array, you have to do the S on the components and actions. Okay. Welcome in. It has to be. If anyone's joining, welcome in. My name is Lena. I'm a game developer. Today we are working with Unity Learn, and we are following a tutorial that I thought would be a fun one, both one that I am wanting to cover because it's going over behaviors of enemies and NPCs. And in the game I'm making, Strain, I want to make sure that my enemies and NPCs are both lifelike and interesting, and you can feel immersed in the world. And I think a strong NPC behavior is something that is important to create that sense of immersion. So we're going to see what this tutorial teaches us, and then we're going to bring it back and try to improve the combat, try to improve the interaction with NPCs, try to improve what they're doing when they're hanging out, and see what parts we want to take from this and include in the game. And if you guys are following along, I hope you are. If this is new, then you can get the link here. I lost it. Let me find the link to this, and you guys can feel free to go along with it, or you can just chill and like watch me do it. And then if it's something that, if I cover something that you like, then you can you can know where to find it, basically. So that's hopefully catches y'all up. Thank you, Tuttle, for the Tina image in chat there. And we're currently on this G-Agent script part. We're at the... Where are we? We're in goal-driven behavior on agents. So we're almost halfway through this part. Then we'll see if we can make something. If not, we'll go back to the main overview and see which things we want to look into next.
The start method here. All right, so now that we've got our start, we've picked up our actions, we still actually do need to declare our G planner. Now I noticed that our actions here, I probably should just put a little S on the end up there to make sure that we've got our list named the same thing down into our start. Okay, and then what we're going to do to run the action, so the agent will run through the plan that it's given up here, and that will happen down here in a late update. So let's make our update a late update. And for now, we're going to leave it empty because we need to work on this planner. So the planner is going to get the goals that are needing to be satisfied, a list of the actions that we have available to us, as well as the world states. And from there, it's going to build a tree of all of the actions. So you're getting essentially a graph. And that graph, we then search through the graph from one end to the other, where we come up with a plan that's going to satisfy the given goal. The planner is quite complex code, so I'm going to leave.
You guys love how she says planner, and the sub thing got it wrong. Planet, planner, planner. I can't do an Australian accent, but I know where to reference a good one though. What game are you making? Hey, the word. There's a game I'm working on. Today we're just doing some learning together. We're covering some more in-depth topics like crowd control, enemy behavior, goal-oriented action planning. Should be fun.
That until the next video so that we can dedicate the whole entire thing to the structure of the planner and how it puts together the actions that will satisfy the goals.
Okay, cool. We're at the end of that anyway. All right, the planner. Best Australian accent, in my opinion, is "I'll say sorry, but I'm not taking off my glasses." What was that from? My favorite part of the Australian accent is when people say no, no, no. One day I will learn how to do that properly. We have a few folks in chat who disapprove of my no, Australian no. One day I will get their approval. No. Can't do it. All right, let's go.
So far, we've looked at the theory for constructing a GOAP-based plan, but now we have to program one. In the end, what we're after is an algorithm that sorts through the actions and matches their effects with other preconditions to construct a plan. So we start by getting all the available actions an agent can perform. These are given to the planner, which checks through all of them to see if, in principle, they are achievable. Remember that little is achievable method we wrote for the actions that always returns true? Well, this is the test for that. Now, if you needed to put some other logic into that method that would have an action rejected by the planner before planning even takes place, then this is where you would put it. But we are just working on the principle that all actions are going to be achievable. Then we start building a graph, beginning with an initial node. Now, this initial node is going to have the world states as its effects. We then look through all the achievable actions for ones that can be performed given the states in the first node. Each matching action creates a new node and a new branch in the graph that we're constructing. We then explore each branch for another action that can be attached using the preconditions and effects. This process continues down each branch until a path is satisfied that matches the initial goal, or the planner runs out of actions. If a path is found, that path becomes the agent's queue of actions, and then the agent starts to perform them. So let's start creating this planning class. Right-click down in your assets and add another C#. We're going to call this a G planner. Then open that up, and first thing we're going to do is at the top add using system.link again for sorting things like our dictionary. And we will also create a helper class at the top, so a public class for our node. So remember, we're constructing a graph and we're doing that with the planner which will link all of our actions together in a plan. But rather than link the actions to other actions, we're actually just going to create a set of nodes that are linked to one another, and then they will just hold on or point back to a particular action. Okay, so first of all, we're going to have a public node, which is the parent of this node, then a public float, which will be the cost for the action, which will be used in determining which plan is actually the cheapest, should there be multiple plans. Then we want a public dictionary, and you can probably imagine what's going to go in here. Yes, string int for the state that we're going to store. Initially, that will be the world states in the first node, and then the public G action, the action that this node is talking about or pointing to. Okay, so that's the properties of that node. Now let's construct it. So public node, node, parent, float cost, dictionary, string int, all states, and finally the action G, action, action. Okay, and then inside of here, we'll just make sure that we set each of our property values to their desired one. So parent, I should say this dot parent equals parent, this dot cost equals cost, this dot state equals all states, but not all states, because it'll point back to that dictionary. We actually want it to be a copy of that dictionary. So in order to do that, we create a new dictionary of string ints, and we give it our all states to make sure that we've definitely made a copy, and then this dot action will equal the action. Okay, to our planner. So down the planner, we can actually get rid of our update and our start. It's just going to be doing processing on our graph and constructing the graph, so it doesn't need to be a mono behavior either. Okay, so first of all, we're going to create our method. So it's public, it's returning a queue, and it's going to return a queue of G actions. So G action, and we'll call it plan. It's going to require a list of all of the actions. So G action, which we have, the agent has a hold of that because it constructs one itself. So actions, the dictionary of the desired goal. So dictionary and string int goal, and the world states as well. So let's put world states and call that states. Okay, so in here, first of all, we will find out which of the actions that we've got is actually usable and hold on to those. So we'll create a list of G action, usable actions equals new list of G actions, and then for each G action A in actions, if A dot is achievable, then we will add that one to our usable actions. So usable actions dot add A. Okay, so that's going to siphon out any actions that can't be run. Right, now after that, what we're going to do is set up our first leaf for our graph. Okay, so we want a list of nodes. Let's call them leaves equals new list of node, and the starting node, node start, is going to equal a new node, and it's going to have a null parent because it's the first one. It's going to have 0 cost again because it's the first one. It's going to have a list of the states, so that's going to be inside of our worlds singleton. Okay, so that's gworld dot instance dot get world dot get states, and then null for the action that it's pointing to, because again it's just that very first node. It's not actually pointing to a particular action. Right, now once we've done that, we want to build the graph. So we're going to return true or false based on whether we've actually found a path. So it'll be bool success, and that's going to equal what we return from build graph that we're yet to write. We'll pass it the starting node, the list of leaves, which at this point is empty, the list of usable actions, and the goal. So that's our build graph. Now, when we come back from build graph, we will test if we have a success. If we're not successful, then what we can do in here is say that we haven't found a plan. Now I'm going to put a debug.log in here to make sure that we do get some kind of feedback, because there's a lot going on once you start planning and running your agents as to trying to figure out what
No plan. I have concepts of a plan.
is actually going on within the system, and you might end up with an awful lot of debugs throughout the whole thing.
I have no plan.
It's natural until you get your head around the way that these
Debug of my
nodes
life.
and the actions all sort of fit together. So at this point, we will return null. So we're actually returning no plan whatsoever if there is no plan, which makes sense. Okay, what we're going to do then is, if we've got this far, then we do have a particular plan that we can follow to achieve our goal. So now we're going to find the cheapest. So node cheapest equals null initially, and then we'll do a for each node leaf in leaves. Okay, and we're going to loop around all of these. Now at this point, we want to check if the cheapest...
Guys, I'm having a revelation. What if we program stuff like this so that we didn't have to think anymore? We could just program our own. We're like, what am I going to eat? What am I going to wear? What am I going to do today? We just run it through the system and it just tells us, and we don't have to waste our brain on this kind of computing stuff. Okay, I've got big plans for this. I'm gonna just program my whole life. It'll be way easier.
leaf or node. So if cheapest equals null, then the cheapest node that we have is just going to be set to the leaf. It means we've not found anything that is actually cheaper, so we'll just use the one that we've got. And then else we're going to put if leaf.cost is less than cheapest.cost, then we're going to say cheapest equals leaf. Okay, so now at this point we have found our cheapest leaf node. Once we've got our cheapest node, we're actually now going to work backwards through it and back up the chain to get the sequence of actions, because we've gone down through the graph, we found our cheapest leaf, which is right at the end of the plan, and now we need to make our way back up it. Okay, so we're going to create a list of G actions, which will be our resulting plan, and that's going to equal a new list of G action, and then node N equals the cheapest, and then while N does not equal null, we're going to say if N dot action does not equal null, and it should only be null if we've hit the starting node anyway, as we work up backwards along the path. Results dot insert at the beginning N dot action, and then N equals N dot parent, so that we're now got the parent in N, and we're going to get its action, and then we're going to get its parent and loop around.
Okay, I feel like I've been typing for a while and I need to like sit and go over this and make sure I understand what we're doing. Do you guys ever feel like, I think in a tutorial, if it's something that, how do I put this? It's useful to type it out and follow along, but I think it's good to review it. And honestly, sometimes if I really want to like digest a tutorial, make sure that I'm getting it, I'll change all the variable names so that when she's like type cost, and you're like cost, node, leaf, like you have to actually go and be like, oh, that when she says cost, she's referring to that specific thing. I feel like that makes me understand tutorials better. But what we'll do is we'll go through this. Hopefully I can make sense of it all. And then after, once we have it working, we can like we can alter it to make something. Like, for example, this is a hospital and you're doing like a patient doing this and that. Maybe we can take it and put in some different like assets, put in a different setting, make them do different things, and like just alter it little by little. And that will help us get a better understanding of it. Yeah, so, okay, let's go through this. So this is our plan. We do have a plan, unless this happens, and then we have no plan. So our plan takes our actions, takes the goals, and it takes the world states. So we have a list of usable actions, which are these G actions. For each item in the actions that were given to this. We check if they're achievable, and if they are, then we add them to this list we made called usable actions. The where did we put is achievable? That was in the other thing, wasn't it? Other script. We then create a list of leaves, a list of nodes called leaves. And the node we made up here, which is a parent, it has a parent, a cost, states, a state, using a dictionary, and an action, G action. So we have a list of these nodes, and they're called leaves. Then we make a node called start. So this is our first one. Our first node. I'm just spacing this out so I can see it better. And we have a bool, and success is equal to build graph, which we haven't done yet. We put in all those parameters, including the list of nodes. And if everything is a success, then we continue. If it's not, there's a problem. Okay. So then we create a node called cheapest. And for each of the nodes in leaves, which we'll call leaf, and then leaves are the list of nodes that we did earlier. If the cheapest one, which is null, is equal to null, then we assign it to leaf for each of these. So wait a second. We just set the node cheapest to null. For each leaf in leaves, if cheapest is equal to null. Okay, so if it's empty, we give it this. Otherwise, is this the right? Did I write this correctly? If cheapest is equal to null, set it equal to leaf. But didn't we just set it right there? I'm a little bit confused by that one. If leaf cost, otherwise, it's not null. I don't know when it wouldn't be null. Let me keep going and see. Oh, I'm seeing there's other things. Okay, I see. I think this will make sense in a bit. Leaf dot cost. The leaf is one of the nodes in leaves here. So the leaf, the cost of it, if the cost of it is less than the cheapest, then this is now the cheapest. Oh, I see. So we start by making this one the cheapest. I see. Cheapest is the leaf. I see. And then we set cheapest to, wait a minute. Gotta look at this again. Cheapest, if cheapest is null, then cheapest equals leaf. Otherwise, the cost of the leaf is less than cheapest, and cheapest equals leaf. A little bit. Is to initialize the first leaf. Hey Artorias, how's it going? Hey dissidents. Okay, let's see. So then the result is a list of G actions and a node where n is cheapest, equal to cheapest that we just set. While n is not null, we added two actions of the parent. Okay, let's continue.
Until we've got all those. So essentially you've created a linked list out of these nodes which represent your graph. Right, now that we've got that, we can actually create our queue, which will have our actions that our agent can go ahead and perform. So queue, G action, let's call it queue with lowercase, equals new queue of G action. And then for each G action A in result, we're going to go queue dot NQ, which puts an item on the end of our queue, A And that's it. So we're just transitioning them from our list into our queue. Now, at this point, if we've made it all the way down to here, well, we obviously have a plan because we've put that plan together. So let's just go debug.log the plan is. And of course, if you start getting just way too many of these debug lines as you're running the simulation, then you can, of course, comment them out. So for each G action A in queue, and this is purely looping through it just to print them out so that you can see that you've got a plan. So debug.log of queue and plus a.action name we'll use. And then finally return our queue, and that goes back to our agent with the plan. So that is the bulk of the queue method. Now we have to write the build graph. And because there's still so much more code to type in, we'll do that in the next video.
Yeah, I see. This is complicated because we've got to go through a lot of steps before we can even see that it works. But we will do that and we will get through it all. And eventually it will hopefully all work and be really cool. And then we can use it to mess around with and edit and, you know, get familiar with. And yeah, should be cool.
Welcome back. Let's get stuck right in and continue coding with our build graph method, which is a little bit more complex than this because we have to build that multi-branched structure of all of the nodes. It's not just one great big long line. And for that, we're going to use so I hope you're all up to date on your use of recursion because it's a complicated thing to get straight in your mind, but it's a very, very powerful programming concept. And basically it's when a method calls itself. And so you end up with all these versions of the method running on top of each other in memory. And at some point you have to sort of dig your way back out of them. But I'm going to show you how to do this, so don't panic. So we're going to create a private bool build graph, and it's going to take our parent node, so node parent, list of our leaves, a list of G actions, which are our usable actions, and our dictionary with our goal in it. Dictionary, which is remember it's a string int, and that will have goal. Okay, so this is build graph. So the first thing we're going to do is bool found path equals false, because at this point we haven't found a path and we need to keep track of whether we have or not. Then we're going to do a for each through each of our actions. So for each G action, action in usable actions that we're passing through, and I think I've spelt that wrong, but I'm going to keep the wrong spelling in there. And now if action dot is achievable given the parent state, then this action is definitely one that we're looking for. So at this point we'll go dictionary string int of the current state equals a new dictionary of string int, but it is being copied from the parent state. So the first time we come in here, the list of states, remember they come from the very first node, and that first node is the starting node, and it has a list of all of the world states in it. So the first time we come through into this, current state is going to be filled up with the states of the world. Now the idea with current state is as we go through all of our actions and build up our branch is that we keep track of everything that's being satisfied and all the conditions that are changing as we're going through. So it's kind of like doing a sort of a pre-test run through the branch. And because this current states has all of the states that are going to be achieved before you get to that action, it helps to match them as we're going along. Okay, so we've got this is achievable.
By the way, if you guys are following along, if you guys are ever following along a tutorial and it's complicated or you're losing track or it's a little feeling like it's over your head or anything like that, or it's hard to digest, this one is a complicated one, especially because we're doing a lot before we see it in action. So it's hard to get a good sense of how something you're typing is affecting the game. I find like going through the tutorial, like I said, going through the tutorial, you could even go through it again, changing the variable name so that you have to really fully get what's happening in order to follow along. playing with it, making variations of it, trying to change and adjust it. And honestly, maybe I'm like, I don't know if maybe this is a weird thing to suggest, but I find that if I still am not fully feeling like comfortable with it, what I do, especially, this is like it's free for anyone to view and use this tutorial. You could just have it playing. Sometimes I'll just have it playing in the background instead of like a podcast, and you just hear it. Sometimes it, like, I don't know, for me it like sinks in better if I just hear the tutorial more, especially if I've gone through it already and I have an idea, and you hear little things like her comments throughout. It just reinforces that learning. So just putting that out there.
Parent state, we've got our current, and now we're going to create a for each key value pair, which will match up string and int. So the key values of the effects in action.effects, and then if not current state contains key in the effects dot key current state dot add effects dot key and effects dot value. So now current state is going to have not only the state of the world, but we're also adding to it the effects of the current action. And then as we move on, the effects from the next action will be added, and the next, so it is keeping that really long list. All right, so we're going to finish our for each loop there. Then we're going to go node, and node equals new node. So we now create the next node along, and its parent, and the parent.cost plus the action.cost. So the cost value here, you can see that we're getting each cost of the individual actions, but as we move through all of our nodes, it accumulates. And that's how we can do that get cheapest node up the top in the code here, and know that we've found the plan by just looking at the very last node on the end that is the cheapest. Okay, and we're also going to set the current state here, so we're giving it to our new node, or passing along this accumulation of states, and then also the action. And then if goal achieved, which we're yet to write, where we're going to match up the goal that we're looking for with the current state. So somewhere in the current state, if we have achieved our goal, then we are in fact finished. So leaves.add our node, and then found path equals true. Now else we haven't found a path, so what we do is we go to the next node along. So we've created our next node along already here, but now what we're going to do is to create a subset of the usable actions to take out the current action that we've already got in our node. So first of all, list g action subset equals action subset, another method that we're yet to write, usable actions action, and this is going to take out of our usable actions the action that we've already created a node in our graph for, so that as we go along the branches, this list of usable actions becomes smaller and smaller, which means that you can't create a circular path anywhere. So you're not going to end up with some kind of endless circle that you're searching through for creating a plan. Okay, so bool found, and that's going to equal build graph, and here you can see our recursive call where we now send through the next node. We still give it our leaves, but instead of usable actions, all of them, we're just sending through our subset, and again we're sending through the goal. So as build graph keeps getting called over and over again, we're sending it the next node, and then the next node, and the next node that have been attached, and this usable action set that's getting smaller and smaller and smaller into subset. And at some point, if found happens to be true from this, then found path equals true, and that then finishes our else, and we can finish our if, our for each up the top, and before we finish our method we can return found path back to our planner. Okay, so that's our recursive function that's doing all of the work for building up our graph. Right, the last thing we need to do in this
code file, and I promise, well, it's not the last thing, it's the last thing you get to do for now before we can kind of get started on creating something, is to declare these two methods. So you want goal achieved and action subset. Right, so we're going to put that underneath here. So make sure that you're still inside your class, but outside of the previous method. So this is going to be our private bool goal achieved. And it's going to use the dictionary again, surprise, surprise, int goal, and then dictionary int state. And in here, for each key value pair, which will be again our string and int, G in goal, so looping through all of our goals and making sure that they exist in the effects. Okay, so if not state dot contains key, G dot key, then we will return false. Otherwise, if we make it all the way through looping and checking, then we're returning true, that we're able to satisfy all of the goals. So that's goal achieved. Straightforward as far as checking. And then we need our action subset up here, which gets rid of the current action that we've just assigned to a node out of the usable actions. So this again will be a private and list of G action, action subset, list G action, actions, and G action remove me. So that'll be the action that we're passing through. We're looking for it as we loop through, and then we're just going to get rid of it out of this particular list. Okay, so it's going to be list G action subset equals new list G action, and then for each G action A in actions we've passed through, if we find the one that we're going to remove, so if we don't find, I should say, if not action dot equals remove me, so the one that we got to just leave out, then we kind of are just ignoring it. Otherwise, subset dot add A, and we'll put the action into there. Then after we've done our loop, we will just return our subset. And that basically is removing that action out of the usable actions. Okay, so you'll be relieved to know we've finished with our G planner for now. Right, next we can actually start making some actions and start pressing that play button in Unity to see things working and how they work, and
awesome.
Start building on it from there.
Cool. That's going to be exciting. Hopefully it will all come together. Okay, executing a simple plan. Any comments from chat before we continue? How's chat doing? I think with a few NPCs it won't be a big deal, but maybe if there was many of them. But there is more in this the overarching tutorial, Artificial Intelligence for Beginners. We are doing goal-oriented action planning, but there's a bunch of different things, including crowd simulation. So I wonder how they'll handle that in the tutorial. Could be cool. I wonder if it'll be different from this. All right, let's check it out. Hello, Orga. This beginner tutorial recursive is the easiest to explain, but nothing's stopping you from going with linear or binary. That's a good point. Saturn 9. All right, let's continue.
In this lecture, we're going to continue writing some code that will allow our agents to execute a plan, and then we're going to put a simple plan onto our agent. And before you start, if you want exactly the same project file that I've just started with here, it's attached to this lecture as a starter project. Now, to do this, we're going to go into our G agent script. So open that up. Now, if you remember from earlier on, there was a late update and we didn't actually fill this out. So now is the time to add the code. Okay, so the first thing we're going to do in here is add in the planner. Okay, so I'm just going to come down a little bit because I want to come back and put other things above this a little later on. First of all, we're going to say if the planner is equal to null, or our action queue, which gets returned from the planner, equals null, that means that the agent currently has no plans to work on. So what are we going to do in here? Well, we're going to create a new plan. So we create a new planner, first of all. So planner equals new G planner. And then we're going to sort through all of the goals that we have. Now, do you remember when we created our agent and we allowed it to have multiple sub-goals? Okay, so if we go back up the top here, a goal is not just a single goal, but there's multiple goals. And then we also have the name of the goal, and we're storing with it a integer value, which is going to be how important this particular goal is in order to satisfy. So we're going to sort through all of our goals and put them in order from most important to least important, so that we can then loop through them one at a time until we find one that we can do. So we're going to do a var sorted goals, which is going to equal our sorted dictionary, which will be using a link command. So it's going to be from entry in goals order by entry dot value descending select entry. Okay, and that's going to take our goals array and order it and stick it into sorted goals. Okay, now once we've got that, we're actually going to loop through each one at a time. So for each, we want the key value pair of subgoal and int. So this is subgoal in sorted goals. Then in here we will say that the action queue equals the planner dot plan. So this is where we're calling plan. So we're taking the most important goal that we know about and trying to create a plan for it. So planner.plan needs the set of actions that we've got, the goal, so we've got, that's the subgoal.key.s goals. So that's all of those subgoals that make up that goal. And then we need to pass through the state, not the world states, but this is the beliefs of the agent. And we actually haven't put those in yet. So at this time, we're just going to pass through null. Okay, so we're not using the belief system. It's just going to use those world goals that we've got. So then we go if action queue after we've done this is...
Oh, sorry. Sorry. Yeah, let me know if you guys are getting reverb. That just means I forgot to mute the audio on my side. And Dissident says, the same dude has on a motorcycle has driven down my street 6 times now. They're probably practicing, or there's... Yeah, that's funny. Okay, sorry for the reverb.
To null, then we must have a plan that we can follow. And in that case, we're going to set the current goal that we're working on to equal the SG, the subgoal key value. And then we're going to break out because we don't...
Sorry, I missed some YouTube folks. Hey, Sylvan. Hey, Texel. How you guys doing?
Need to keep looking through those goals for another plan because we've already got one.
I got distracted by chat. Let me catch up here. So action queue is that if action queue is not null, then the current goal equals SG key, break the loop.
So that is basically our planner. Now remember late update, if the loop is going to loop and loop and loop. Okay, so when it loops the first time and we don't have a planner or an action queue, then we will get a planner. Now, if we do have a action, then just above this, I want to test for it first. So if we're in the middle of performing an action, then I'm going to return out of this late update before we get down into the planning stage. So up here we'll go if current action does not equal null and current action dot running. So there's a bool that we can set to say that we're actually working on our action. Now, if we are working on our action, what we're going to do is put if current action dot agent dot has path and current action dot agent dot remaining distance is less than 1f. Now this, as you will recognize, is navmesh code, and so we need to have this in here in order to move the agent towards the goal.
I do recognize that, but I also realize I just put in 2 T's on this and it's throwing me off every time. There we go. Okay.
Now, as soon as the agent has a goal and it has actually reached that goal, and we're saying in this case like less than a distance of 1, then we're going to run the end of our action, which is to run basically the completion of it. Okay, now remember that we put in each action a duration. So when we've got to this point, we've reached our goal location, we then need to wait for the duration of it. So let's say that you've rocked up to the registry desk and you're registering. So you've arrived there physically, and then it's going to take 10 seconds to actually complete the task that the agent is doing there. This is the code that will do that. So we're going to say if not invoked, and I'll explain this in a moment. And if not invoked, then we're going to invoke an external method called complete action, and that's going to be sent through the current action.duration, or actually it's going to be invoked in that 10 seconds later on, and then invoke equals true. Now when we start, invoked is going to be false, and I'm just going to put it up here. Okay, so bool invoked equals false. So we know that the first time we come into here, this will be false. It'll allow us to go in here, invoke this complete action method in however many seconds, and then it sets invoked to true. So we're never going to come back into here again at this point. We can't, it won't let us. But the complete action method that we're going to write just up here is going to set invoked back to false for us. So we want a void complete action, and then inside of this method, current action dot running equals false. So this is where we finally say we're finished running our current action, and it will force our planning system to go and plan again. And so we want current action dot post perform, which is the method that we run right at the end, and then we'll set invoked back to false. Okay, so that's what happens when we finished a current action, and then after however many duration it is, we're going to have running set to false, which means that this will then fail. Excuse me for one moment while I butt into my own video just to say that I've missed a return statement that you'll need to put inside of that if statement. Now,
that was such a weird interruption sound, and I totally missed it too. Let me bring that back up for a sec. So if the current action is null, after the if statement here about having a path, we return. Okay.
Own video just to say that I've missed a return statement that you'll need to put inside of that if statement. Now, at that point, you've either run out of actions or you still have more actions in your queue. So if that's the case, we now need to consider that. So underneath our if statement for our planner, we're going to consider if action queue does not equal null. So we actually have an action queue, and the action queue dot count equals 0, which means that we have an empty action queue and we've actually run out of things to do. Then we can go if current goal dot remove. So if the goal that we've just been working on is one of those removable ones, then we can say goals dot remove our current goal from there. And then we're going to, after we've done that, set planner to equal null, which is going to trigger getting another planner the next time this loop goes through. Now, finally, there's one more if statement condition we need to consider in here that might occur, and that is if action Q does not equal null and the action Q dot count is greater than 0. It means we still got actions left sitting in our queue that came back from the planner. In that case, we can start running them. So we're now going to get current action, and we're going to go equals action queue dot DQ, and this will take the action that's sitting at the top of our queue off the queue and put it into current action. Now we then perform the pre-performance method that we've got for our action. So it's going to be current action dot pre-perform, and in there we can do any checks that we need to do, like for physical attributes that need to be set, if the number of, say, cubicles is available, and all of those sorts of things. And then if that is true, we want to go if current action.target equals null and current action.target tag does not equal an empty string, then what we're going to do is go that current action.target equals game object dot find with tag current action dot target tag. So we can set the target for the nav mesh agent to move to by setting it in the inspector, or we can find it using a tag. So if you've made a prefab of your character, it's going to be much easier for you just to set the tag, so then it does this search when it gets into the environment to look for it. Now, as you can see, I'm getting errors with our target tag here. If I just quickly save that and switch back into my G action, and you might want to have a look here, you can see that we set target tag to be a game object.
Got it,
when in
Nisku.
fact, it's meant to be a string. So that was just a little mistake I made before, and will still be in your code. So just save that, and then we can switch back to our agent. The other thing you can see here is that the game objects to find with tag needs to be a capital G in there. Now let's finish this if statement. We've got our target object, then we're going to go if current action.target does not equal null. So it still could be that we end up having nowhere to go as far as moving our agent around. And if that's the case, we're going to check that it's not equal to null. So if it's not equal to null, the target, not the tag, I should say, current action dot running equals true, and this is where the action actually starts to take place. Let's get rid of that T. And current action dot agent dot set destination, and that's our nav mesh agent setting the destination to the current action dot target dot transform dot position. Okay, so that is the starting point for setting the destination for our agent.
Yeah, no, I mean, it was clear Jason was going to win. He's got a huge YouTube following, so it's a quantities thing, but he's also a really great content creator, so he did well. It's well deserved, and thanks for letting me know. And congratulations to Jason. He definitely deserves the award. He provides a lot of really good tutorials and stuff. You guys are sweet. Thank you, guys. Thanks for voting for me and everything.
And then up higher is where we're actually testing if we've made it to the destination. Now remember, the nav mesh agent code is going to go and do its thing automatically in the background as far as moving the agent around. Okay, so we're just going to end that if statement. Now, else if...
Yeah, and it was an honor to be nominated, and we already won before. We got to let other people win too. So congratulations to him and everyone else who won. I wonder who else won some of the other awards, because I mean, it's cool just to see people highlighted, honestly, like the people who were nominated. It's nice to see them. I don't know. It's nice to just have a spotlight on people who are working hard on assets or tutorials or streaming or whatever it is. It's nice that Unity showcases people working with their software.
If we can't do our pre-performance method, we're going to say action Q equals null. And that will then force us to get a new plan. Go back to the goals, get a new plan. Now, if any one of your actions that you're working through or trying to work through fails, then it's going to replan the whole thing, which may in fact replan the exact same sequence of actions, but send you back to the beginning so that it makes sure that you do that. And it also makes sure that your agent doesn't get stuck somewhere through the middle of a plan. Okay, so now that we've got that, let's just save it. That is our main code for our late update. Right, let's go back into Unity. We're now going to create our basic...
A few people are just joining. If you guys are just coming in today, hello. Hey, Original Speedster. Anyone else who's joining? Today we are working with Unity on Unity Learn. The sponsorship was basically... They wanted to highlight Unity Learn, or they had a few things. I actually picked the Unity Learn because I think it's a great resource for people to learn game development. I like Unity. I think it's a great place to start learning game development. It's a great place to continue and stick with. I've been doing that. I use Unity Learn all the time, and I picked this topic because it's something that I would like to get better at, and I think that it's something that many developers can use these skills. It might be useful for you guys to see me go through it. Ideally follow along, but if not, at least you can see sort of what it encompasses, and you can listen in, hear what she's saying, and then if you guys want to follow along later, there is a link here for you. You guys can dig into the tutorial more at your own time, but at least you can see sort of what you can learn a little bit of it, get a bit of a preview, and then when you're ready to go into it, you have a better understanding of some things, and you're going to see how it looks at the end and throughout it. So it gives you some info there. I want to make a coffee. I'll finish this session and then we'll take a little break.
Class for our patient. So right click and create a new C# script. We're going to call this patient, and then open this up. It's going to be very short code. So the patient is going to inherit from GAgent, and it's not going to have an update. It's going to have a start. Now in the start, we want to call the base.start. That's going on in the GAgent script. And then we're going to create a subgoal. So subgoal S1 equals new subgoal, and the subgoal will be is waiting. And we'll give it a priority of 1, and we will say true, which will remove it from being a goal. And then we have to add it to our goals. So goals.add S1, and its priority in this case is 3. Now, this particular start and our GAgent, let's just save this. Let's go back to GAgent. I just want to point out something that you need to fix in here that I just did before, is to...
Am I partaking in the Unity Web Game Jam? No, but if you have a link to it, there might be people who would be interested. You're welcome to share it. I think I'm gonna I'm already probably gonna participate in the Twitch Game Jam. So I don't think I can do 2 at once. I don't know if I can do 1 at once. I'm already a month late on a month and a half. No, I've got 2 weeks on a month and a half game jam. So I'm going to already be cramming. I don't think I can fit another one in. But if you guys want to look at the Unity Web Game Jam, Saturn, we'd love to see a link. I'll bring it up after this module.
Add a public to the start. Otherwise, you're going to get an error when you try and call that base.start. But basically, base.start is going to set up all your actions that you've attached to your patient.
I haven't seen that done before. You can call start before the first frame update if you go public void start and call it. Okay, let me add that in. Public. I noticed she put that on another script, and I haven't seen public starts and updates before, so this is interesting.
And then you can go ahead and run the rest of this patient code. Right, so we're going to save that, go back into Unity and grab hold of that patient script and drag and drop it onto your patient.
Mine is still getting an error even though I set this one. Hers also had underlines here, but this should be solved here, no? Public start now. Base.start. Is hers having underlines?
GAgent. I just want to point out something that you need to fix in here that I just did before. And our GAgent.
Oh, it's inheriting from mono behavior still. GAgent. There we go. Okay, now
let's just save this. Let's go back to GAgent. I just want to point out something that you need to fix in here that I just did before, is to add a public to the start. Otherwise, you're going to get an error when you try and call that base.start. But basically, base.start is going to set up all your actions that you've attached to your patient, and then you can go ahead and run the rest of this patient code. Right, so we're going to save that, go back into Unity and grab hold of that patient script and drag and drop it onto your patient.
It wouldn't let me do it because the other script has an error still. I thought hers still had an underline. We'll go back if at the end of the module if it's could have sworn. We'll check.
Yep, and there it is. Now we actually need an action to follow. So let's make a quick action. And in here, let's go create C#, and let's call this go to hospital. Open that up to edit it. And this time it's not going to be a mono behavior. This is actually going to be a G action. And inside of here, we're going to get rid of our start and update. And all we need to do is put a public override bool for our pre-perform, which we will just put return true in there. And then a copy of that down here for our post perform. So that is a basic stock standard action. So just save that. Now switch back to Unity.
My autocomplete keeps not letting me write this. Okay, let me see. Let me write perform, pre-perform. No, god damn. Okay, there we go. And I'm gonna just copy and paste it so it doesn't give me trouble trying to write pre-perform again. Post-perform. Okay.
So that is a basic stock standard action. So just save that now.
I'm going to be honest, I don't know how acute the public void start comment she made. It doesn't say that in the documentation. That's interesting.
Now switch back to Unity. We're going to attach this go to hospital to our patient, which will give it access to be able to perform.
So my script, it looked like her script also had errors, so I'm not sure how she's adding these. I'm going to go back and check, but we will, once we double check, once they are all working, patient and go to hospital need to go on patient. I'll keep that in mind.
That particular action. Now this action, remember we've got preconditions and we've got post conditions that we can put in here. Let's say that just for now, there's no precondition. The after effect is going to have to match whatever our goal is. Now the goal for our patient, if we go back into the script here, is looking for is waiting. Okay, so back in Unity on our patient, we're going to add one after effect and it's going to be.
Okay, she's almost done and I'm still getting errors, so I'm gonna check it now after all. This was in G agent. This is where it was an error. Current action. Oh, I said because I have target tag. It should just be target, I think. Is that why? Maybe not. Let me see. It's around this area. Oh, here it is. Current action, target tag does not equal null or nothing. Gives me an error, but it did not give her an error here. It did earlier. Maybe I imagined it. Yeah, what did she do?
Nav mesh agent to move to by setting it in the inspector, or we can find it using a tag. So if you've made a prefab of your character, it's going to be much easier for you just to set the tag. So then it does this search when it gets into the environment to look for it. Now, as you can see, I'm getting errors with our target tag here. If I just quickly save that and switch back into my G action, and you might want to have a look here, you can see that we set target tag to be a game object when in fact it's meant to be a string. So that was just a little mistake I made before and will still be in your code. So just save that and then we can switch back to our agent. The other.
Okay, that seems to have fixed it. I didn't catch her fixing that mistake. So let's add those two patient to the patient and go to hospital. And here's the after effects she was looking at, which is cool. She's adding one here with a key and value. Let's see what she puts in.
Access to be able to perform that particular action or is waiting. Okay, so back in Unity on our patient, we're going to add one after effect and it's going to be is waiting, and this is where it needs to be spelt correctly. Now the value in this case doesn't matter because we're not really using it for anything. The other thing we need to know is where the target for this action is going to occur. Now, because the agent is in the scene, in the hierarchy with, let's say, we're going to go to the hospital in the waiting area. So get the waiting area and drag and drop that into your target. It's going to be okay. It's not a prefab, so we don't actually have to look for it using the tag of the waiting area. Okay, so now if we press play, our agent is going to formulate a plan to make sure that is waiting goal occurs. And as you can see, it has done that because all it needed to do was run the go to hospital script in order to satisfy its goal. So there we go. There's our very, very basic, very, very simple plan system working in our GOAP system that we've just put together. So now onwards and upwards to more complex actions.
Cool. All right. So we are getting through this, and let's double check. Wait, before I even say we're done that step, let's check it. Will it go to the waiting room? There he goes, our little guy, walking around the hospital, looking to speak to a doctor. All right, cool. I am gonna make another coffee, and then we will move on to the next section of this, where I don't know what we're gonna do next. I guess we'll do all the other stuff. I'm just looking at where we are. So its next step is just loading here. The next step is creating a multi-step plan, adding agents, adding more resources to the world. Wait a minute, is this the one? Yeah. Implementing the inventory system, moving the nurse, adding goal change challenge, and taking a break. That's for the main, this is for the main Unity Learn thing here. So we are going to be doing this one next. Time for a little coffee break. Don't forget to take a stretch yourself. We'll be back in a few minutes, and we can continue on. If only I didn't have to wait 5 minutes to play some music. Holding. Can skip in 6 seconds. All right, here we go. Okay, I'll see you guys in a few minutes.
KMH is normalizing the discussion about substance abuse. They're normalizing the discussions around mental health. That's how we break down stigma and eliminate the shame that are holding people back from getting the help that they truly, genuinely need.
That client review was brutal.
We're gonna be underwater for weeks.
I'm already so pruny.
This is fixable. Just use Grammarly. Grammarly can look through the proposal to find what's missing. And look, Grammarly knows the audience is non-technical, so it can take out the jargon and make the benefits easier to understand.
Cool. And with Grammarly working across...
I hate ads. Damn it. Can't even make a coffee. And it's a friggin' ad on Twitch, which I also can't turn off. Oh, I know. I would turn them off if I could. Okay. Okay. Where were we? How's everyone doing? Hello, Arata. Hey, Mimo. You switching over to Blue Sky sometime? Yes, actually, I think I might start using it. I got an account. I haven't started using it. Let me see, what is my account? Sign in. I honestly don't. Choose a service. You can use a custom server. My handle is this. You guys using Blue Sky? Add me if you guys are, I'll add you back. Add me, I'll add you back. In theory, you could tap into listening Twitch events and ad comes up, the video player goes straight to floating screen mode. You detect that. Then you can mute the main window and unmute the mini player, thus ad blocking, sort of. Wait a minute. Hold on a second here. You mean for Twitch? Oh, you mean like a Chrome extension? Or whatever browser extension? What is Blue Sky? It's like the Twitter alternative. Oh, someone added me. Dinara. Follow back. Oh, Gabriel. Follow back. Ooh, nice art. Dinar, you are my first follower. Thank you. Wow. If you guys use it, let me know. Hey, Gunda Mash, how's it going? No thanks. It's a Twitter alternative because I think it's becoming popular lately because if you guys haven't noticed, Twitter is filled with like political stuff and it's nobody wants to see that. I mean, some people do. Yeah. The bigger thing actually is that hey Roger. Hey Steve. The bigger thing is that they're gonna use your Twitter posts in their AI. So if you want your game art to be fed into an AI, continue using Twitter. If not, people are switching to Blue Sky. I wasn't convinced until that, so there it is again. If you do make an account, my profile looks empty, but that's my profile. It's just a yellow thing. Here, I'll put a picture up so it doesn't look like shady. Let's see. I should make a new profile picture. Oh my god. It just played an ad. And I'm okay, I have to close this. And it won't let me not skip it. Is it just me, or have things gotten more aggressive with ads? Am I like imagining this? Okay, hang on a sec. All right. I gotta get a better ad blocker. Freya, Miz, and others. Yeah, I'll make a post tomorrow. I think Mastodon is out of style and Blue Sky is in style. Go at the end.
Candice, if you feel like you're overwhelmed, just remember I am writing nuclear maths physics on Tuesday, doing like 10 jobs, and taking care of my family. On the bright side, I modeled finances on production data, and the banking manager was impressed with my model outcome, and I came right with a portion of the 1CL NAM SVM machine learning model. Also, let's start a business that offers one-way trips to the surface of the sun.
Poor Sean. You'll get through it. We're here to help you. Ads on ads, yeah. Do artists don't understand that their stuff will be scraped no matter where they post? Yeah, maybe you're right. I don't know. Good question. I wonder, is there a way to avoid that? All right, let's continue with our tutorial. Okay, 1 second actually.
Now that we've created one action, we're going to string two actions together. So before I just do that, I'll just mention a warning that you could be getting in the console when you press play. Let's press play so we can get that warning to come.
Oh wait, sorry, I missed. Nat got an email from my uni saying that my application was deferred to spring 2025, and I started freaking out because I thought it meant my application status was delayed until the spring semester. But we Gucci? But it just means if I get accepted, I'll be able to start in the spring. Oh, okay, that's good. How long were you panicking for? Good luck with it. What are you applying for? Application. Cool. Okay, let's start this. I'll message you with texts now so we can follow through this.
Come up, and it's about world states and unreferenced behaviors and missing things. Just ignore that. It's being generated by the canvas in the world, and even if we stop playing for a second, turn that canvas off and press play, you still get the same error coming through, or warning. It's not going to affect anything at the moment, and we'll fix it later. Another thing I'll get you to modify before you start creating more complex plans is the late update in your G agent code. So we were testing previously for the agent having a path, and then also using the agent's remaining distance to the object that it's going to. And you might have a different value from 0.5 in here.
But the thing is, once you start moving your agent between different markers, the accuracy of that seems to break down, or if it jumps to another waypoint before it's finished the path and that, you can get some skipping out of your agents where they will look like they're going to go and complete their entire plan, but they actually just skip on and go home because of the issue with that nav mesh accuracy. So instead, inside of this late update for G Agent, I'd like you just to change your if statement, that's the first part inside of here, and we will actually calculate our own distance to target between
Okay, let me see. In our late update, we were doing float distance to target is vector 3 distance, current action, target, transform, position, and then this, the distance between that and transform position of this entity. Okay. And what's after that?
Between the current actions target and the position of the agent, and then we'll use that as a comparison inside of this if statement instead of the old code here.
Okay, so instead it's if current action agent has path distance to target. And then she's added a debug here for distance, oops, debug log, distance to goal, and current action agent, remaining distance. Okay.
And that should and will, I promise you, stop your agents from skipping out on the plans a little later down the track. And if you want to see the difference, then when you do get multiple stepped plans that the agent has to go through, you can always come back and put this code in to see the difference in the behavior. Okay, so let's now add in another action that we can basically hook up to go to hospital. So currently all we've done with go to hospital is have the agent go into the waiting room. Let's now make go to hospital where the agent has to go to the front door and then go in the waiting room. Okay, so that's going to make go to hospital to begin with. We click on the patient to find where we've hooked that up. The script itself, so the action name, we should probably change that to go to hospital because you'll be able to see this plan in the console when it's worked out.
Let's see. I need to look at that again. So on the patient, go to hospital, action name. I've got that. I've got this. Let me bring that one over here so it's less messing around. And on the patient, I already forgot, actions? Did she make a new action? No? Oh, action name, go to hospital. Then we can see it. Okay, I see. Cool.
Now the waiting area itself is the target, but go to hospital, we want to just set it to the main door. Now the door, remember I've got this empty game object essentially that's just a position in front of the door, and we can see it in the scene view. It's sitting just there. So that's the spot we want to get our agent to go to. Now the door is tagged with door. Instead of assigning the game object of door to our patient, this time what we're going to do is use the tag. So let's just null out what's in there, and I think if we just hit delete on it, it will make it empty. And then in here, let's type door, which is our tag for the door. Make sure it's got a capital D, so that once this patient becomes a prefab a little bit down the track, it's going to find the door when it's instantiated rather than the game object itself using the game object. Okay, now the duration you can see that I've changed to 5 in the doorway, so you'll see him pause when he gets into the doorway, and 5 seconds is probably a little bit too long. Let's put it down to 2. And the after effect now, I've got it as is waiting, but it will be something else. So let's change it to has arrived.
Now, after has arrived, we want him to go into the waiting room. So we need another action that will link up to has arrived. So grab your go to hospital script, duplicate it, Control D, and then what I want you to do is rename that to go to waiting room. And then we're going to open that up in the editor and change the class name to go to waiting room as well. So up here it will be go to waiting room, and we're just going to save that, switch back into Unity. Now get go to waiting room and drag and drop it onto your patient. The action name we'll set to go to waiting room, and the target tag will be our waiting area. So let's just see what that is tagged as. So it's waiting area with no spaces in it and 2 capitals. So waiting area. Our precondition this time there's going to be one of them, and it's going to be has arrived, which is up here in the go to hospital as the after effect, and that's what's going to link these two actions together. So has arrived, and then the actual effect of go to waiting room has to be our goal. Otherwise, the agent will not run this. And our goal is waiting. And if you remember in our agent code, that's the actual goal that is being run. Now, the duration for the waiting room is 0 at the moment. That's kind of the end of our action plan. So there's no need for a real duration. Okay, so we've got that. Now we're ready to press play. So press play, and our patient should.
Let's see. We'll watch from here and from here. Okay, so goes to the door. And then goes to the waiting room. Okay, let's see if that's what we want.
Head over to the door, and then when he gets to the door, he's going to wait for 2 seconds, because that's the duration of the task of arriving, and then he's going to turn around and go into the waiting room. Okay, great. So that's linking up 2 actions. Now I'm going to set you a challenge. What I'd like you to do is to create a 3rd action and put it in between go to hospital and go to waiting. And
go
this
to the
action
registration
will be
desk.
Register. So I want your agent to go to the front door, then to go to the reception desk and wait there for 5 seconds, and then go into the waiting room. So pause the video now and go off and add that action in and make sure you attach it to the patient and you've got all the right pre and post conditions all set up for it. And when we come back, I'll go through how to put that together.
Okay, so I'm assuming, let's see, here's our patient. Let's bring him outside so it feels realer, like he's coming up to the hospital. We should also have him dripping blood. Help! And there should be blood, drips a trail of blood behind him. And they're like, I see that you're bleeding out. Please go take a seat in the waiting room. And we'll wait in the waiting room for a duration of 7 hours. Okay, so I guess we need another go to hospital, go to waiting room. We need go to reception. Go to reception. There will be blood. And we need to name it over here. Go to reception. And then, hey tech, we're just looking at Unity Learn today. It is a collab with Unity. Here's the link. We're following this and brushing up our NPC behaviors knowledge, basically. So now we need a go to, let's add to the thing, go to reception. And I might as well put it after. So go to hospital, has arrived, and then has arrived should be on our precondition here. And we will do one that is has arrived. Let's call this one has registered. And that will be our precondition for this one. Let's see if that works. And either way, we'll watch the video and see how she does it. We'll watch it here. Okay, so he's going over to this guy, to the door. Oh, he's supposed to wait at 5 seconds at the reception. Let's see. Go to reception. Oh, I need the target and tag, which is reception. Let me do that. Patient. Target tag. Reception. Duration. Let's say 3 seconds. Okay, now let's test it. Okay, so he comes to the hospital. Help! Help, I'm injured. He opens the door. He gets to the registration, talks to someone, and then he goes in the waiting room. Very cute. All right, sweet.
Okay, how did you go with that? First of all, what I'm going to do is just create another folder in here, and I'm going to call it GOAP, and move all of these base classes in there, because as you start creating more and more actions, the whole thing is going to get very populated with scripts, and trying to find them will get annoying. Okay, so these are the high levels that we've got. We've got the patient and go to hospital and go to waiting room. Now we need another one of these, which is going to be register. So I'll just duplicate it and I'll call it register. And then open that up. And in here, just rename it to register. Save it. Now let's go back into here. We'll select our patient and we're going to drag and drop register onto the patient. Let's first of all call it register. We'll give it a name for its action is register. And the duration, I said 5 seconds. Now the target tag in this case is going to be our reception desk, and just click on it and its tag is reception. So let's go back and put reception in there. The preconditions are going to be the post conditions or the effects of go to hospital. So we want to put a 1 in there for the size, and then inside of here we want has arrived. Okay, so let's put has arrived. And then the after effects, we're going to put 1 in here and put has registered.
We did this. I'll go quickly through.
Now that has registered will become the precondition for going to the waiting room. So up in the go to waiting room for your precondition, change that now to has registered. Okay, and now they should all link. Your goal is still the same, but your agent is now going to, well, go through these 3 steps. Right, so let's press play and just check what the agent does. He's going to go over to the main door, which is essentially simulating him coming into the hospital. I know he's already in the hospital, but he would be outside the hospital. 2 seconds there. He's going to come and register, which takes 5 seconds, and then he's going to go and wait in the waiting room. Okay, nice. Right, so now that we've done that, you might want to spawn some more patients. And I'm going to leave the challenge of creating a simple spawner for these patients up to you for the end of this video. We'll come back in the next video and continue working on this. So just...
Okay, we have a new task. Do I dev in VR? I have. I've done stuff, but it's not my main focus at the moment. VR is cool. Actually, I will be doing VR stuff probably in about 2 weeks, I think, because I'll probably be doing characters and the Twitch integrated game for the next 2 weeks, and then, or like, we'll see how long. But eventually I'm going to get on to finishing the environments for the first part of Strain, my main project, and I will be putting that into VR to see how they look in VR, because I find that that's an easier way to level design. Okay, so we are going to create a patient spawner and have them instantiated outside the hospital. I want to do it the way that she's walking through. I almost want to just see how she does it. Patient spawner. Using these systems, I'm not sure how I would do it. I know how I would do it on my own. Let's see how she does it.
In the previous lecture, I left you with the challenge of creating a spawner to spawn patients. All right, so what we're going to do now is to actually write that, and I'll show you my method. Yours might be a little bit different, but as long as it gets the patients instantiated and onto your map, then we're all good. Okay, so first of all, we actually need our patient to be a prefab. Now, if you remember, he did start out as a prefab. So we've made some changes to our basic patient. So you want to go and click on your patient, and then let's just drag that in, and I'm going to come up into the inspector, and we want to override all of these things that we've done to our patient. So click on apply all to apply those back to the prefab. Okay, so now let's create a spawner. In our hierarchy, let me just scroll all of these things up. We're going to right click and create an empty of spawner. Okay, and that's going to be the position of where our spawner will be. Now it's currently just positioned there, so let's drag it over here. Now, if you want to see where it is besides these axes, you can use the trick that I've done before with the waiting area and the reception, which is to add a cube mesh renderer or a box collider or something so that you can actually see it. Now, it needs to be outside of the hospital, and it needs to be near the ground. Now, the ground's at 0. So over in the inspector, I'll have a look at my Y for that. I'm going to actually set it to, let's say 7. It doesn't matter if it's slightly up in the air, because they will spawn there and then just drop down to the ground and then move in. All right, so let's leave that there. Now we're going to create the code for that. So create C# script and call it spawn. And let's go ahead and open that up and edit it. It's going to require, first of all, our game object, so our prefab. So it'll be public game object.
Did I find the Unity VR tutorials helpful? I haven't done a lot of them, to be honest. I've mostly just used I used an asset for the initial VR stuff and then worked with that. But I bet you they're good if I were to dig in further.
Patient prefab. And then how many patients we want. So let's put that in here. Public int num patients. And then down in start, we're going to create a for loop for int I equals 0, I is less than num patients, I++, and then inside this loop, we will instantiate our patients. Okay, so we want to instantiate, and we're going to use our patient prefab, and let's see, we want to put it at this.transform.position, which is your spawner position, and Quaternion.identity for basically a default rotation. And we spell transform correctly. Now, the problem with this that I'm just thinking now is if we loop through this, all in the start, we're going to end up with, 100 patients straight away. Now, that might be what you want. I'd rather have this spawning them at particular intervals. So instead, I'm going to go down here and put void, let's go spawn patient. And inside of here, I will move this instantiate code. So Control X, put that down there. Now, that actually makes our num patients and our loop superfluous, but now you've seen how you would do that if you wanted to create a whole bunch of patients all in one go. And let's just leave that there actually, and we will do that anyway. Okay, so we will then put this instantiate back up there. So this is all your initial lot of patients, and then what we're going to do is invoke spawn patient. After, say, 5 seconds. And then inside of spawn patient, we will get it to invoke itself. So you keep getting patients being spawned. And now in here, we're going to have random.range for the time between patients. So let's say we want patients every 2 to 10 seconds. That's going to do it. So now you can see 2 ways that you could actually spawn. Right, so we'll save this. And let's go back into Unity. And we want to get our spawn script and drag it onto our spawner over here. And then we're going to assign our patient prefab, which is back in our prefabs folder. So if we go to our prefabs folder, we've got our patient there. We can. Right, so we'll save. This, and let's go back into Unity. And
sorry, was I muted for that? Yeah, I just put it in. We're good.
And we want to get our spawn script and drag it onto our spawner over here. And then we're going to assign our patient prefab, which is back in our prefabs folder. So if we go to our prefabs folder, we've got our patient there. We can drag and drop him into the patient prefab. And the number of patients, this is the initial number that get created, and then, 1 gets spawned every 5 seconds or whatever it was set to. So let's create an initial amount of 5.
What's the difference between ++1 and... I don't think there's ++1. If you do +1, you're adding it. If you do it after, it's you add, wait. I++ is you add 1 to I. If you do something +1, then it's like you're adding 1 to that thing. Or I to that thing. If you do +I, then you're adding I to that thing. Sorry, that was, I don't know if I explained that. I fumbled that. Sorry if I made it more confusing.
And then they're going to drop out of the sky, basically, and start coming into the hospital. Now, this little guy here that's already in the hospital, you can delete him or just turn him off if you want to use him for testing things a little bit later. Okay, so let's just press play and have a look.
Oh, my bad. So you can do ++I to increment the value before use. I didn't know that. Huh. What do you know? What do you know? You learn something every day.
At what we get here. So there's our 5 that are initially spawned, and they're all coming into the hospital. And then here comes the extra ones. So if we go over into our game view here, let me just set this to a high resolution.
They can barely fit through the door.
Now they're going to come and register, and then once they've registered, they will move away.
Accurate hospital simulation.
After they shuffle past each other, and then go into here. Right, so some little bits of debugging information at this point. If you find that they are not getting to their destination, skipping over steps or whatever, it's going to happen as you're trying to test this. The most common thing in this particular scenario, or the use of the nav mesh, is that the agents can't reach their destination. For example, down here, we're getting a big pile up in this waiting room. Now, remember that the waiting room has a specific location, which is one little tiny point. If I select that, and let's just come over to here. Okay, it's right there. So that means the agents have to get to that specific point to be considered in the waiting room. And if we have a look in the code for this, let's just pause. I'm going to go back into the agent's GOAP code and have a look at our G agent code. In order to consider that they've actually reached a destination, if we have a look in the late update, we've got this line here for remaining distance. So it's going to consider that you've reached a destination waypoint on the nav mesh if you're within 1 distance. Now, if you're using units,
I don't see where this, so this isn't G agent. Your late update. Current action is not null. The current action is running. Oh, she changed this later on. Okay. We'll keep following and see if we can make it make sense.
sized agents like I am.
Yes, this is Unity we're using. All of these are free. All this information is free to use. If you guys are interested in game development, all you need is a basic computer and you can learn how to do it. Holiger, thank you very much for 22 months. Hope you're doing good. And congratulations! Glad to see that you won. Asset Store Publisher of the Year. Can we get a round of applause for our friend Holiger, aka Pavel, who's on a very small team of very talented people making gorgeous, realistic assets. Glad to hear you won. Congrats. Well deserved. Okay, let's continue on.
I find that 1 is quite acceptable. You might want to make this a little bit bigger if you find that your agents just aren't reaching that location. Now, the other thing that could happen is if you set this to 20, then the agent will consider himself having reached a waypoint when he's like 20 units away, which will make the actions look a bit odd. So it might make an agent look like he's reached the waiting room when he's still standing out here, which is something that you don't want. Okay, so that's one thing. Now, any agent that doesn't reach a waypoint will still be trying to execute one of the actions. Okay, and you can tell if you select an agent. So let's find someone who's actually still doing stuff, this guy here. And over in the inspector, let's find his parent patient. The go to waiting room, go to hospital, and register. If you have a look on all of those things, you'll see that there is a public tick box at the bottom called running. That will tell you which action he is still trying to run. So this particular agent over here, he's at the reception desk, so he's obviously still registering. If we have a look at his register, it is ticked to say that it is still in fact running. Now if we press unpress pause and wait for a moment until he's finished, you can see now that that has been unticked and he's now going to the waiting room instead. Okay, so now whilst this is going on, let's pause again. Another way to have a look at debugging this is if we go into the console, you'll see that it's printing out the plans. And so here you can see it says the plan is go to hospital, register, go to waiting room. So this plan is actually happening in order. And I've collapsed down what's going on in the console because it will just be writing this out for every particular agent. But this is showing you that this is what the plan is that they've come up with, which is the plan that you wanted them to come up with. So that is at least all good. Right, so that is getting a whole bunch of agents running and spawning them. When we come back in the next lecture, I'll have to talk about a little bit more of debugging these scenarios because that's actually quite a big part of this, and we'll begin working on getting our nurse to run.
I don't know why. I thought there was more in this video. Oh, here's the other one. Oh, there's a few within this. Okay. Okay.
So far, we've got one agent that can put together a string of actions to satisfy a single goal. And we can tell what's going on with those goals if we look in the console at the moment, which gives us a little bit of an idea of the plans for the agent. In addition to this, I've created and attached as a resource to this video a agent visualizer. So if you download that zip, unzip it, and then just drag and drop that folder into your assets. Hold on, first of all, we should stop pausing and playing. Drag and drop that in, so it's the agent visualizer here. Now, the agent visualizer has 2 scripts in it. It has one script, which is the G agent visual that you can attach to any of your agents. And then there's a G agent editor. That needs to go into a folder that's called editor. So go back to your assets and just create a new folder, call that editor, and then open that up and grab that G agent editor and drag and drop that into editor.
So I believe we make the editor folder here. Drop agent editor into that, and then agent visual into that. But we're getting an error on agent editor. Let's see, hopefully it won't be an issue.
Looks like I already had editor in there. Okay, so that one's now empty. I'll just delete that. Okay, so now that we've got that, you can grab your G agent visual, and if you click on your patient.
Okay, a couple things. First of all, the spawn, I'm going to just do it the way she has it. I'm assuming we're going to make it better later rather than spawning 5 all at once, but until then, let's keep it the same. Close that. And then the spawner, okay. And then this one seems to be S goal. Is there no S goals here? S goals. I think it's just called goals. Let me see. The key of G, which is G agent. Is there something goals? S goals. Ah, it's lowercase g. Okay. There we go. That fixes it.
Drag and drop that into the inspector. And
G agent visual, and we're putting it on patient, okay? G agent visualizer on patient. Okay.
And then we're going to just make sure that we put these changes back to our prefab. So go up to the top of the inspector, and where you've got overrides, just click on that, and there's an apply
Hey, Eternal
all
Divine
button
Fox.
next to it. And that'll make
Very similar to Night Fox / Divine Dev. Hope you're doing good.
Make sure that all of the patients that get spawned from your prefabs have the same things on them. Now, this G agent visual actually uses inspector editor code, which I'm not going to go through in this course. But if you're interested, I guess you can have a dig around in the code. Now, if we press play, you'll see that, and then pause it, that this agent visual actually shows you what the current action is, what the goals are that the agent is trying to satisfy, and the actions that it has. Now, it's not currently printing out the plan, but there's no reason why you couldn't do that. And if you have a look at the script, then it will give you a pretty decent idea of how you grab the data from your agent and actually put it into this little area. But I just created this to help me to make sure that I can see everything, and that we can also see very quickly the preconditions and the effects, and to make sure that things are spelt correctly and that things are going to all line up when we start to press play. Now it's time to program the nurse, and this is where things start to get interesting. The nurse can't go into action to get a patient until there's a patient waiting. So first of all, let's create our nurse script, just like we have our patient script, and then we'll work on it from there. So let's just grab the patient script and Control D to make a copy of it. Then we will call it nurse and open it up, change it from patient to nurse. Okay, so the nurse is going to run the base start, as did the patient, but the goal in this case will be not is waiting, but treat patient. And then we add the goal. So we'll just leave one goal in there at the moment. So save that. Let's go back into Unity, and we will attach that to our solo nurse that we currently have. So grab that and put it onto the nurse. Now, the nurse's action to get patient will be the first one that we write. So let's just grab hold of one of the patient ones, like go to hospital, and copy it, Control D, and I'm going to call it get patient. Then open that up and rename the class to get patient. And then we'll save it, go back to Unity and attach that to our nurse. So get patient is just there. Now the action name will be get patient, so we can name that there, get patient. And our after effects for now will be the goal that we just added. So we're going to add one and we will call it treat patient is going to be our after effect. Okay, now we need a precondition. So what is the precondition that we're going to set? Well, the nurse hasn't done anything to trigger this. We actually need the world to trigger it, or we need something to change in the world that's going to trigger it. So in these preconditions, what I'm going to do in here is just add one, and the precondition in this case is going to be waiting, or patient waiting. Okay, so we've got this waiting. Where is waiting going to come from? So whose goal or whose state is that going to be? It's going to be the world state, and it has to be triggered by the patient when the patient starts waiting. So what we need to do is go into our patient's waiting code, and in the post perform, what we're going to do here is add in a world state. So gworld dot instance dot get world dot modify state.
Wait, we're doing this on go to waiting room. Okay. Go to waiting room. All right, let's continue.
Waiting one. So it's going to add one patient that will be waiting. So now that the patient is going to inject this waiting state into the world, we're going to go back and start monitoring it. And that's where this canvas item that's being disabled, sitting here, causing you a few warnings throughout, comes into play. So just turn that canvas back on. You'll see that there's a text box called world states. And this is just to display what the world states are. And purely just for you to see. And then when you're not using it anymore, you can just turn it off. But we need to update the world states to what's in the dictionary of world states, and that means writing this script that's missing down the bottom. So let's go and right click in here and we'll create a new script.
Dimlo, thanks very much for subscribing. Welcome back. Hope you're doing good. Yes, we are artificially intelligent now. I didn't see where she had the text here. It's missing a script, which is weird. Test. I don't see it. Oh, it's there. Okay.
Called update world. Open that up, and it's going to be very short. First thing it's going to do is be given the text. So public text states, and then in the late update we'll do this because we don't want to do it very often. Get rid of the start, and then we want a dictionary, which is of course our string int, and world states equals gworld dot instance dot get world dot get states. Now you could just use this directly in the next for each statement that we're going to create, but I've just done it there to make the code just a little bit shorter. And then we'll just put states.text equals empty, just to get rid of that text. And then down in here we want for each key value pair, which will be a string and an int s in world states. And then we will just put states.text plus equals s.key, so that's our string, plus a comma, space, plus s.value in case you're actually using that value. And because we're modifying it, it will update as we're adding patients. So it's going to go waiting 1, waiting 2, waiting 3, and actually tell you how many are waiting. And put a new line in there. Now, in order to access this text that it doesn't seem to like, don't forget right at the top we're going to need using.
It's funny, she didn't put using Unity UI, and like every time she spelled text, it autocorrected to something incorrect.
Unity Engine.ui in order to pick that
There it
text
goes.
up. And
This
those
should be
errors
text also.
should then go away if we redefine that as a
There we go.
text. Okay, good.
Okay.
So save that. Let's go back into Unity, and what we're going to do is click on our world states object in the hierarchy and just put that missing script back into where it was. And the text component, which is up here, you can just drag and drop that down into the states. Okay, so it's this one that's on the same object into states. And now when we run it, we're going, it's this one that's on the same object into states, and to pick that text up, and those errors should then go away if we redefine that as a text. Okay, good. So save that. Let's go back into Unity, and what we're going to do is click on our world states object in the hierarchy and just put that missing script back into where it was. And the text component, which is up here, you can just drag and drop that down into the states. Okay, so it's this one that's on the same object into states. And now when we run it, we're going to see that when our patient comes in and goes to the waiting room, then we will get waiting appearing up here with a number. So let's just wait till one of these guys gets in there. Okay, here we go. He's in there. He is now waiting, and waiting is 1, 2.
Yay.
And as they bunch up,
It worked.
and remember they actually do have to hit the right spot in order to be classified as waiting, but it is eventually growing. So now it's this particular state here that we want to affect the nurse and inject back into the nurse's get patient action. Now that is in fact happening, but why is the nurse moving? Well, we haven't set the nurse's target. The target needs to be the patient that the nurse needs to pick up. But just to test that the nurse is actually running this get patient, let's just for now give the target to the nurse of that waiting area. So she'll be moving towards there, but it's not the right way to go because we want her to find her actual patient. So let's just test this again, and we'll press play. Now, while we're waiting for these guys to come in, I hope I'm not being too gender biased or sexist or whatever you might call it by calling the nurse a she and the patient a he.
I need to put the get patient on here. I thought I already put that on. Let me take a look. What's going on? Nurse. Nurse. There's only the one nurse. Did I put the thing on the wrong thing? Let's see. Get patient should go on here. Oh, I put it on the wrong one. Okay. Get patient, waiting, and treat patient. Patient. Ooh. Precondition is waiting with a capital W. That's from the world state. And then the treat patient is happening there. Was there anything else that we did here? I don't think so. Let's remove it from... We don't want the patients to get the patients. That's going to cause a whole bunch of problems in this hospital. If patients are treating each other, we're in for some lawsuits. Let's put the waiting area in and see if this works.
But to me they kind of look like that, so I'm just going to go with it. Okay, so here we go. Here comes our patient. He's in there. Should trigger the nurse, and there goes the nurse into action, running that particular get patient. Now, she's not going to do anything else because that's it. That was the only thing she knows how to do. But she's only going into that waiting
She's a very
area,
junior nurse.
not getting the patient.
Getting
and
the patient is her only
functionality
skills.
When we come back in the next lecture.
Okay, cool. All right, let's take a look at the next lesson.
In the previous lecture, we got the nurse to go to the waiting area where the patients will be. We're now going to match up the nurse with a particular patient so that she can then take them to a cubicle. So somehow she needs to know about the patient. And later down the track, the patient and her need to know about these cubicles over here because that's where the treatment is going to take place. So now we have to add in a functionality where we can deal with game objects, and not just static game objects like the ones we've got on an AVMesh, but ones that move around and that will be assigned dynamically. So we're going to do that in the world script. So we need to go back into our GOAP folder.
Thank you, Eternal Divine Fox. Good luck with your stuff as well. We have a nice break. Panda, we don't get a break. No breaking. We've got too much to learn. Yeah, exactly, Vicious. We'll take a break in a little bit. Let's get as far as we can with this. We are currently, excuse me. We are doing this section of the AI course. I'm losing my voice. You know what? We'll take a break when I have a voice again.
Find G World and open it up. And now we're going to extend the world. So the world is going to have a private static queue of game objects. And this first queue that we're creating will be our patients queue. As the patients arrive into the waiting place, they'll put themselves in the queue, and then the nurse can get them out of the queue in order to make them her target location. So we need two methods down here to work with our queue. First of all, we need a public void add patient, where we pass it the game object P, and what that does is to enqueue that. So patient dot enqueue for P. Now, at some point, we'll also have to remove the patients out of the queue, especially when the nurse has been assigned to them. We don't want them assigned to any other nurse, so we will go remove patient. And in here, what that's going to do is actually return the first game object in the queue. So let's make that our game object that it's returning. And in here, it'll be if there's a patient in the queue to get hold of. So if patients dot count equals 0, then we're going to return null. Otherwise, we're going to return patients dot dequeue. Now, of course, before any of this code is actually going to work on your patient queue, you also need to initialize it. So let's go up to the top here and go patients new queue of game objects. So game object. Otherwise, we won't be able to put anything in the queue or get anything out of it. Okay, great. So save that. Now we're going to go back into our action that is injecting the waiting state. And that was in, do we remember? It's the waiting room. There it is. I found it. Okay, so here at the same time as we're injecting this waiting state into the world states, we can also add ourselves, or this agent can add himself into the queue. So it's going to be the world queue.instance dot add patient, and it'll be this dot game object. So it's the game object or the agent that this waiting is particularly on that's going to go into that queue. Okay, so we will save that. Now, what's the nurse going to do? Well, we go back to the get patients script, and in the pre-perform, so the first thing we do before we start running our plan is to get our target and set our target. So target's going to equal gworld dot instance dot remove patient, and we're going to remove just one. Of course, we can't get any more. Then we have to remember to test that we've actually got the target, because if we don't have a target, then the pre-perform should fail, which will make the whole plan fail. So if target equals null, then we're going to return false, and that will actually allow that get patient to go back into the queue of goals for the nurse so that it can plan to do that again, rather than continuing if there are other goals that needed to go on.
Hopefully, there we go. There's my voice. All right. T2, thank you so much for the raid. How was your stream today? What are you guys up to? Welcome in, welcome in. My name is Lana. I'm a game developer. I'm working on a game called Strain. It's a narrative survival game. And today we're taking a little break to do some learning. We're working with Unity, and we're looking at Unity Learn, specifically this Unity Learn guide on AI. It's called AI for Beginners, but I'd say it's a more intermediate course. If you're a beginner, it's definitely, you can follow it, but I would recommend learning some basics before you dig into this. And an ad showed up right as everyone's coming in. Well, I guess no point explaining what we're doing if no one can hear me. Let's continue. I love ads. So glad I can't turn them off. Where were we? Let's continue with the video.
On with. So if you return true, then the nurse would actually go ahead and go and do that. Except I guess that in this case, the condition is with the nav mesh and the nurse actually has to be in the right location. Okay, anyway, so we've got all the code. So let's save that and let's go back to Unity and we'll give this a go. All right, so with those changes made, let's have a look at the nurse. Now, we're looking for this target here to change. I'm just going to select this and hit delete to make it none in there. And let's press play to watch what happens. So when the agents come in...
I got distracted on the last bit. Whoops.
Have a target, then the pre-perform should fail, which will make the whole plan do that. Except, I guess, that in this case... to change. Okay. I'm just going to select this and hit delete to make it none in there. And let's press play to watch what happens. So when the agents come in, they're going to eventually register themselves in the patient queue and the nurse should get one from there and head over. Now you'll know that that has occurred because the nurse will end up with the target in here and be able to go and find that particular patient.
Oh, sorry. So okay. Oh my gosh.
Here we go. Here comes
okay, I'm not muted.
Bang. There's one in the queue. The nurse.
So many things running at once. My game, the video ads. 6 months. Aw, thank you, Pandar. That's so nice. Aw, that's nice. I'm happy to have you subbed for 6 more months, Em. Nice to see you. Thank you, Pandar. Okay, we'll keep going. I'll say hi to the, if Raider's stuck around, I'll say hi to them in a minute when the ads are over.
Nurse has that target
and
this. Off the nurse goes into the area. Now, it's still going to look exactly the same as what we had before because the nurse and the patient do not have any further plans after sort of meeting up. So when we come back in the next lecture, what we're going to do is extend the plans of the nurse and the patient so that they make their ways over to a cubicle.
Yeah, you're stuck up with us for 6 more months at least. So she should go back to the waiting area again, but this time she's actually trying to get to the NPC. Oh wait, she didn't do it. Okay, something didn't work. Okay, what did I miss? We removed the target here, but it should have filled in the target with the... Where was it under? Here it is. Add patient this game object. That's on G World. Oh man, I got... Okay, so the ad is over. If you guys are still here from the raid, thank you for sticking around. I hope you guys had a nice stream, and sorry that I can't turn off ads on Twitch. We are just following a tutorial on enemy eye. I wonder if I can see the transcript and see if I missed anything. Probably easier to go through this.
The target is going to equal gworld dot instance dot remove patient, and we're going to remove just one. Of course, we can't get any more. Then we have to remember to test that we've actually got the target, because if we don't have a target, then the
Sticking still got American Embassy ad myself again, McDonald's. Yeah, what ads did you guys get? Weird. American Embassy from McDonald's? Very strange. The very political, the very official ambassador of the US, McDonald's. Oh, that's what you're joking is. I thought there was an actual ad for it. Okay, what a part of this did I miss? That nurse did not... Let me see the setup of the nurse once we're done the code. I think I followed all the code. I got thrown off there. Hey, welcome in, Robin. How you doing? What am I doing? I am... today we're working with Unity Learn, and we're following a tutorial about
patient queue, and the
NPC
nurse
behavior.
Should get one from there and head over. Now you'll know that that has occurred because the nurse will end up with the target in here and be able to go and find that.
So she didn't get a target. I think that there was something I needed to...
Alright, so with those changes made, let's have a look at the nurse. Now we're looking for this target here to change. I'm just going to select this and hit delete to make it none in there. And let's press play.
Okay, so it wasn't that. Skim through here. G World, did we add this? G World, static queue of patients.
Oh, cute. First of all, we need a public
We did
void.
these things. You know what? Let me run it again. I'm not sure what happened. Maybe I just missed something. Did I save everything? Let's see. Treat patient. Nurse no longer has the target on it. Let's run it and see. Good, doing good. That's good. Doing pretty good myself. Is it because there's no action on her? No, I don't think so. We have nurse, get patient. And get patient. Waiting. So the world is waiting, but she is not going to it. Oh, let's take a look at her. This is not running. Why is this not running? All right, let's take a look at this. So where was the patient stuff? I gotta like look at the video again. There's a lot of stuff happening here. So maybe if I play it at super speed, and without audio, I can catch what she's doing. Try to follow along. Probably the fastest way to debug this. Hey, Mikado, how's it going? G World. Patience. And then we do void add patient. And then remove patient, which was a game object. So far, so good. Oh, no, wait, we did that. Patient's new queue game object. And on G World, yeah, it's all good. Go to waiting room. We added the add patient line. Target G World instance, remove patient. And if target is null, return false. Remove patients. Me doing my taxes, you know what I mean, guys? Okay. Let's see what hers looks like.
Here to change. I'm just going to select this and hit delete to make it none in there. And let's press play to watch what happens. So when the agents come in, they're going to eventually register themselves in the patient queue, and the nurse should get one from there and head over. Now you'll know that that has occurred because the nurse went up with a target in here and be able to go and find that particular patient. So here we go. Here comes the agents. Bang. There's one in the queue. The nurse has that target.
Oh, sorry. I said let's start with one patient, and the nurse is not seeming to get the target. When he gets the waiting room, this should get set. but that doesn't seem to be happening. Did that change? No. Did something change? No. So this guy is now... What's he doing? Go to waiting room. He's in the waiting room. It's no longer running, so it should have triggered the script to say that he's done that. I don't know. What's missing here? His waiting has registered, waiting area. This is actually a test for you guys. Who was paying attention? If you're paying attention, what was missing? Okay, let's see. What does her nurse say on... Let me see. This is the nurse. Get patient. Action name patient. Target becomes patient. Get patient. Cost 1. Nurse. Get patient. Cost 1. No target. Nurse. Is there a nurse thing on hers? Oh, here it is. Oh, okay. It's missing the nurse action. Got it. Sorry, this. Self. Okay. Let me see if that does it. Don't worry if you guys are not absorbing everything from this tutorial. That's fine. Hopefully you'll get a little bit of understanding, or at least, you know, you can see what steps are being taken. And that way, if you need this in the future, you know where to come find this. Still nothing. Maybe that's not what we needed. Let's on play. This becomes nurse. Yeah, so there's nothing to start. Treat patient, waiting. Treat patient and waiting. Ah. Wait, nurse, no, get patient has, it's called get patient. Waiting and treat patient. No, we got that. Do I go through that video again? This is not getting put in. The target is not getting added. Where would that target on get patient? Let me look at the get patient script. Get patient. This removes the patient on the pre-perform. What could it be? Instance, gworld, targets. Let's watch it again with audio on. I'll go quickly this time.
In the previous lecture, we got the nurse to go to the waiting area where the patients will be. We're now going to match up the nurse with a particular patient so that she can then take them to a cubicle. So somehow she needs to know about the patient. And later down the track, the patient and her need to know about these cubicles over here because that's where the treatment is going to take place. So now we have to add in a functionality where we can deal with game objects and not just static game objects like the ones we've got on an AvMesh, but ones that move around and that will be assigned dynamically. So we're going to do that in the world script. So we need to go back into our GOAP folder, find GWorld and open it up. And now we're going to extend the world. So the world is going to have a private static queue of game objects. And this first queue that we're creating will be our patient's queue. as the patients arrive into the waiting place, they'll put themselves in the queue, and then the nurse can get them out of the queue in order to make them her target location. So we need two methods down here to work with our queue. First of all, we need a public void add patient, where we pass it the game object P, and what that does is to enqueue that. So patient.enqueue for P. Now, at some point, we'll also have to remove the patients out of the queue, especially when the nurse has been assigned to them. We don't want them assigned to any other nurse, so we will go remove patient. And in here, what that's going to do is actually return the first game object in the queue. So let's make that our game object that it's returning. And in here, it'll be if there's a patient in the queue to get hold of. So if patients dot count equals 0, then we're going to return null. Otherwise, we're going to return patients dot dequeue. Now, of course, before any of this code is actually going to work on your patient queue, you also need to initialize it. So let's go up to the top here and go patients new queue of game objects. So game object. Otherwise, we won't be able to put anything in the queue or get anything out of it. Okay, great. So save that. Now we're going to go.
Is it just me or did that get removed?
Back into our action that is injecting the waiting state, and that was in, do we remember, it's the waiting room. There it is, I found it. Okay, so here at the same time as we're injecting this waiting state into the world states, we can also add ourselves, or this agent can add himself into the queue. So it's going to be the world queue.instance dot add patient, and it'll be this dot game object. So it's the.
Let's see that this is happening. So, I mean, I don't see why I wouldn't want this. I would normally actually just put it like that. But let's stick to this. So on the, what is it under? Go to waiting room. Go to waiting room. Post perform. Let me see. Adding to queue. So this should be where we add this game object under G world. And in G world, oh no, add patient. So under go to waiting room, add patient. We're adding that game object, patients in queue. In queued patient. And then, well, then it will take it away after. But let's see if those things happen first. Let's test that part. Does it get queued up? Hey Scott, how's it going? Okay, so this guy's going here. Console is spitting out all kinds of stuff. Such as no plan, saying no plan a lot. Let's collapse these. There, the plan is that get patient. Okay, you know what? It didn't do the debugs I just did, which is interesting. Let me take a look. Go to hospital, go to waiting room. Here's go to waiting room. Post perform. Post perform is not getting called. Add to queue. Modify state, waiting. Oh, let me look at this again. If this says waiting, then that should work. Use chats, bro. Oh, and queued patient. Okay. And waiting. So those two things happened. And queued patient, adding to queue and enqueued patient are both here. Okay, good to know. But the nurse did not get this game object. Get patient. Target equals remove patient. So this is interesting. Target remove patient. You know what? Let me see the next video. Let me see. I feel like there should be something there to add the patient.
Game object, or the agent that this waiting is particularly on, that's going to go into that queue. Okay, so we will save that. Now, what's the nurse going to do? Well, we go back to the get patients script, and in the pre-perform, so the first thing we do before we start running our plan is to get our target and set our target. So target's going to equal gworld.instance.remove patient, and we're going to remove just one. Of course, we can't get any more. Then we have to remember to test that we've actually got the target, because if we don't have a target, then the pre-perform should fail, which will make the whole plan fail. So if target equals null, then we're going to return false, and that will actually allow that get patient to go back into the queue of goals.
Okay, so we are getting the remove patient, which returns patients.dq, which is the game object. Let's see here. The count. Let's get to see what this is. Maybe this is 0 for some reason. And then it should return patients.dq. Let me look up DQ. I'm not familiar with that. I've used it only a little bit. Would that return the game object? Patients.dq. DQ. Let's see if I do return there. Where was I just? Get patient. And then okay, let's see how that goes if I run it. Okay, so okay. Oh, I don't think I changed anything. Did I change something? I put in debugs. Did I change something? Well, I guess I'm happy if it works. Oh, maybe I didn't save? Is that all it was? Well, let's take a look. Usually I remember, but could have been that, I guess. Okay, let's check without the debugs. Acute patient. Hopefully this works and we can move on to the next step. Yeah, okay. All right. Maybe it was just a lack of saving. All right. Easy peasy. Thanks, MixNets, by the way. All right, adding more resources to the world. This should be interesting. We're getting quite a ways through. We have done all of this already, which is the bulk of it. And if we look at the thing, the list here, the ones we've done actually are the heavier, the meatier ones. I've got 2 meaty ones left. This one and one more, but then a couple others. So we're doing pretty good. We're gonna add resources, implement an inventory system, moving nurse, adding goal challenge. Okay, cool. I'm just gonna take a short break and then I'll be back.
isn't a laptop launch. This is a U launch. The new Lenovo AI PC has built-in AI that learns from you.
Oh my god. Where were we? Okay, adding more resources to the world.
In this video, we're going to start adding the cubicles in as resources that are available to the patient and the nurse. First of all, what we need to do is to go into our world, so G world, and add in here a queue of cubicles just the same way that we've got this queue of patients. Now I'm going to leave that as an initial challenge for you to do, and I'd like you to think about the setting up of the cubicle and how the values of each cubicle that's already in the game world are going to get into the queue in the first place, because they're not like the patients that can kind of inject themselves in there when their goals have been achieved or an action gets to a certain place. Okay, so go away and try and do that. So add a queue and add all the necessary bits and pieces that need to go throughout this whole G world class in order to look after that queue. And when we come back, I will show you how to do that and put it together. So pause the video now and good luck. Welcome back.
I'm hilarious, I know. I think I'm speedrunning this tutorial too fast to do that. I'm going to just follow along.
How did you go? Well, first of all, we have to create a queue. So that should be pretty straightforward for you, which is to copy the patients, place it in there and call it cubicles. Okay, we can then go ahead and in the world is construct that queue. So let's just grab that.
Cubicles.
And make a copy of it, and we'll call that cubicles as well. Okay, so then we need two helpers, which is our add cubicle and remove cubicle. So we will just copy those and put them down in here. So we'll just rename them as add cubicle and remove cubicle. And then we'll also change the queues inside of those so that we've got the correct ones. Cubicle and cubicle. Right, so now we need to actually populate that queue, because these cubicles are things that exist in the game environment. So one way you could do it is you could write a script that you put on each cubicle. So as a resource, it has a little script, and then it says in the start method, it says something like G.
Wait, what is the clip?
Oh look, there's a monster under the bed.
I am hilarious. It's true.
World cubicles, add cubicle, and then injects itself into that queue, which is fine. Okay, that would work fine, and that would be good if you...
Wait, there was more?
Oh look, there's a monster under the bed.
God, this isn't fair. I live stream long hours every day. You guys see all the dumb stuff that happens to me, okay? I went through great efforts to hide that monster under the bed and apparently also dropped it in the process.
If you wanted to add cubicles dynamically into the world. But what we're going to do here is actually just pick up all of the cubicles that are in the world. So we're going to do a game object array, and let's just call this cubes equals game object dot find objects with tag. Remember that all of those cubicles are tagged with cubicle with a capital C. So we can go through the environment and pick up the ones that are already existing. Then we can loop through them. So for each game object C in cubes cubicles dot NQ. So we stick them into the queue and we're putting C into that queue. Then after that, we also need to insert a state into the world about the cubicles and whether they're free or not, just like if a patient is waiting. So initially we're going to say if cubes dot length is greater than 0, then we want to put world dot
modify state, free cubicle, cubes.length. And then when that goes into the world states, it automatically gets picked up by our little updater that's putting it into that GUI that's on the screen. All right, so save that and switch back into Unity, and we just want to test that it's working. So just press play, and because the world is doing it itself, we're not reliant on any of our agents updating the state. Okay, so now you can see it says free cubicle, and there's 3 available. And therefore we can use free cubicle as something that our patient or our nurse is looking for in order to do another action. So it can be a precondition. So now we have this new resource in the environment. So it's not an agent, and it's not a goal or sub-goal. It's not really a state, but its existence causes a state. So the cubicles are causing a state of free cubicles.
Yes, collecting the objects at runtime is bad practice. Some of the things in this tutorial are not necessarily best practice. Excuse me. I'm losing my voice today. But I think some of it is done for the purpose of demonstrating how to do goal-oriented action planning. So if you're a beginner, don't worry, these slightly less performant things that people bring up are not a huge deal, and as you get better, you'll learn how to easily make it better after you've watched the tutorial. Can you find your voice? No. Find voice with tags.
Or I guess no free cubicles, which is kind of, I guess, the opposite. And therefore we need another way of organizing these things that the agents need on them or available in order to complete a task. And that's now where the idea of an inventory comes in. So in our GOAP folder, what we're going to do is create.
Yeah, remember, I can't add to that right now.
An inventory. So let's go C# and we'll call it a G inventory just to keep up.
But I do want to say, I'm sure Penny is great with Unity best practices, but if she did everything that was like the best performance and all of that, it would be way harder to digest. It's already a lot for people to take in. This is meant to be a beginner's course, so she's using beginner stuff for the other things. But the point of the tutorial is to learn goal-oriented action programming. So that's what we're learning, and some of the things, if you don't like them, you can change them. And if you're not familiar with the things people are bringing up, don't worry, this is fine. Unless you're being really, like, you could probably make a game just fine with this thing. But if you want to get really into performance, you might want to make some adjustments. But you can look into performance and those kind of things later on.
With the way we've been coding so far, with the conventions of
her
the name.
teaching style.
Now, the inventory itself is not a mono behavior and therefore will not have a start.
Okay, I'm behind on this. What were we doing? We're making a script called G inventory. Let's do that. G inventory. Yeah, her course is on Udemy are good as well. These ones are free. How nice.
Start and an update. So it's basically just keeping a list. So a list of game objects, which will be our items that we can put in our inventory or backpack or whatever you want to call it. Okay, so let's call it items, and it's going to equal a new list of game objects. Now it's going to require 3 helper functions, and let's just get rid of that S. I always put that in there. Okay, so it's going to have a public void add item, and we give it a game object, I, and it's going to add that to your items, which is quite straightforward because it's just items.add and then I. The next one is going to be a public game object that it returns, and it will be find item with tag, given the string tag of it. Right, so to find the item in here, we'll just loop through it. So for each game object I in items, if I.tag equals tag, then we're just going to return it. Return I. Otherwise, we're going to finish our for loop, not having found it, and we'll return a null so that we know that that item is not in our inventory. Finally, we're going to have a remove. So we've got the ability to put it in the inventory. Now we have to get it out. So public void remove item game object I. And this is, we need to first of all find the index to that particular item. So index to remove equals -1, which means we actually haven't found that item for removing. For each game object I in items, we're then going to set the index to remove equals ++ to increment it. And then if I equals the item that we pass through, which is an I, which is a bad idea to call them that, isn't it? Let's call this one G for game object, and then let's put G down here instead. And if that's the case, then we're going to break out with the index set for the one that actually just matched. And then we'll go if index to remove is greater than or equal to -1, then we can do an items dot remove at index to remove. Now, we need to do it this way where we loop through the whole thing first and then remove it using its index afterwards, because lists do not like to have things taken out of the middle of them when you're looping through them. So that's why we've done it like this. Okay, so that's our G inventory. So save that. Now that all agents are going to require access to the inventory, go back into your gagent.cs script, and up at top we're going to add in a new item, which will be our inventory. So public G inventory equals a new
I don't see, what do we have? World states beliefs. I remember putting that in. Is that here? G agent. Am I missing something here? G agent. Looks the same here. Looks the same here. Looks the same here. Looks the same afterwards. Okay, I forgot to put in beliefs, I guess. Public world states beliefs equals new world states. I'm assuming. We'll see in a second what that one is. And we're going to put in the one that is public G inventory. Inventory equals
G inventory. Right, so now all of our agents, the patients and the nurses, will have access to put things in the inventory and check that things are in the inventory. Now the question is, when do we get hold of the cubicle and put it into our inventory? You don't want it in there all the time, because the cubicles can only be owned by one patient at a time, or one sort of nurse-patient pair. What we're going to do in this particular case, and this is not the only way that you could do it, but first of all, we're going to have the nurse, before it even starts the get patient plan, and it will become a plan. Currently, it's only one task that we've got in there. We're going to add a second precondition. So we don't even want the plan to be able to start until there's also a free cubicle. So add free cubicle into there. Make sure your spelling is correct. Exactly the same spelling as you end up seeing up here when the cubicles are added to the world state.
So that was preconditions, and it was free cubicle. Okay.
So now we've got this condition that we know there's a free cubicle in the world when the get patient is actually running. Now that the agent has an inventory, then the actions can get hold of that inventory from the agent, but you'd have to do a get component call to get hold of it. So what I want to do in this G action class is actually just grab hold of it in here as well, so that we can refer to it without having to write such long code or go to the unoptimized version of running get component every time we need to. So it's G inventory in our actions, and that's just going to point back to the agent that has it. So up in here, when we're constructing our action, we're going to add into there, actually I'm not doing it in the constructor, I'm doing it in the awake, and in here we'll have inventory equals this dot get component, which will be our G agent dot inventory. Okay, so that's going to make it a lot easier to work with. We can go to get patient, so open that up, and the first thing we're going to do is get hold of a resource, and I've actually already started this code, you can see it there. The resource is going to be whatever you want to put into your inventory, and in this case, in get patient, it happens to be the cubicle. So we're going to get the cubicle after the target has either succeeded or failed, because if we don't get the target, we don't need a cubicle. So let's go down here and add in resource equals gworld dot instance dot remove cubicle, and that will give our resource a pointer to the cubicle that's first in that queue. Now we also want to test if it's null or not. So first of all, we will say if resource does not equal null, then we're going to add it to the nurse's inventory. So inventory dot add item resource. And if it's null, if resource equals null, which I guess could be an else statement, couldn't it? Makes more sense, because if it's not null, it's going to be null. Okay, so let's just get rid of that. Else, if it happens to be null in this case, then gworld dot instance dot add patient target. So what we're doing here is, if we can't get hold of the cubicle, we're also going to release the patient, because we don't need the patient anymore, and the whole pre-perform is actually going to fail. So we will also set target here to equal null, and then we're going to return a false. Now, if we get beyond this else and we're down here, it means that we are in fact have a true state. We had a free cubicle, we took away a cubicle, so we need to affect the world state as well. So gworld dot instance dot get world dot modify state, and in here will be free cubicle, and we're going to do modifier of -1. So what's that going to do? Well, it's going to reduce the count that's on that world condition by 1. Now remember, back in modify state, in this particular example, we've got it so that if it gets to 0, it actually removes the state completely out of the environment. So therefore, when you run out of cubicles, there won't be any cubicles sitting in the state, because we're taking them away as we pick them up here. Now, what's going to be on the post perform? Well, if we've got through and we've successfully done the action, then on the post perform, we want to take away a waiting patient. So gworld dot instance dot get world dot modify state, and in this case it's waiting, and -1. And then we're also going to say if we have a target, which in this case is our agent that we've headed to in the waiting room, then target dot get component G agent dot inventory dot add item resource. So we're adding the cubicle to the agent, the patient's inventory. So the nurse finds the cubicle, and then if the nurse finds the patient, then the nurse gives the patient access to the cubicle. So now they both have the same cubicle in their inventory, which means that we can now go ahead and create the actions where both of our agents head over to that cubicle. And we'll come back and do that in the next video.
Okay. Let's take a look at the resources and see how this works, if it works. I don't know if we've put everything in yet. I don't think we have we? Because we need to still do more, I think. Okay. Implementing the inventory system. We have one video here. It's a longer video. And then the next one is moving the nurse, which is one 7-minute video. And then adding goal challenges, and then that's pretty much it. Excuse me, then we can start playing with it. And then the goal challenges is another short one. Okay, let's get through this one, another longer one, 2 short ones, and then we can play with it.
Okay, so in this video, we've got the inventory set up and we're going to start using it to get the nurse and the patients to go to the cubicle that have just been assigned. So create yourself a new C# file and open that up. Call it Get Treated. And this class here is actually based on the original Get Patients code before we modified it. And you'll see why I've used this in a moment, because it's actually got a few things that are similar. The target, we need to get a cubicle. We don't want to get the cubicle from remove patient or anywhere else. We're going to get it out of our inventory. So in here, we're going to put inventory. Want to get the cubicle from remove patient or anywhere else. We're going to get it out of our inventory. So in here, we're going to put inventory dot find object with tag and give it our cubicle like that. And then if we don't have it, of course, we're going to return false or otherwise null. Now, what are going to be the post perform in this situation? What things do we need to set up? Well, the first thing is that we could actually add a state to the world. So world.instance.getWorld and .modify state, and we're going to add a new state in there called treated, and basically it's just going to count the number of patients who get treated. It's not going to be used for anything, but you'll be able to see the count going up. Maybe if you were turning this into a full-blown medical simulation, you would be keeping track of how many patients were actually treated in this particular state, and therefore you could trigger some other event, like you get extra budget or you get an award or whatever. So it's just another thing that you can keep track of, and you can put all sorts of things into that world state with values. Now, once we've been treated, well, we have to remove the cubicle. So we'll go inventory dot remove item, and we will remove the target from the agent's own inventory. Okay, great. So save that. Now we're going to go back into Unity and get the patient, drag and drop that new get treated onto the patient. So it's one of the tasks. Now we will call it get treated. The target.
Okay. So we're going to add get treated on the patient. There it is. Call it get treated.
We don't need to set up. And the preconditions for this. Okay, so if we don't put
any preconditions on this. It's something that can be done pretty much straight away. And it can't really be done until you're in the waiting area. So there needs to be some kind of situation that gets triggered to say that we are actually in the waiting area. Unfortunately, we can't be looking at the world state for a precondition to being in the waiting area, because every agent that comes in is going to add to the world state. So there will be some cases when your agent needs to keep a set of its own states, and that's where the beliefs that I've talked about in previous lectures come into play. So let's go back into our GOAP folder, we'll go into our agent, and we'll add in some beliefs. So let's have a look here. We've already added in this beliefs structure, but we haven't actually started to use it. So in order to use it, we need to put some values in there. Now, the action itself is going to want access to the beliefs. So let's go back into the action, and just like we put the inventory in there, we're going to add in a public world states beliefs, and then down in the await, we will put beliefs equals this dot get component with a gagent dot beliefs. Alright, so you can save that script. Now let's go into our go to waiting room. This is where we want to inject a state into the patient's own belief system. Okay, so in here we'll put beliefs dot modify state, and we'll put at hospital in there. So now we can use at hospital as a precondition for that get treatment. So back in Unity on the patient, we will now put a precondition 1 in there, and under the...
Oh, sorry, you guys could hear echo for that. I'm typing. So precondition.
First element there, we'll put at hospital.
Okay.
Do make sure that you are spelling these correctly so that they do match. Now, what's going to be our after effect? Well, we
Wait a minute.
need to add...
Precondition for get treated is at hospital. Okay. Get treated, precondition at hospital. Okay.
Add 1 at least, and the after effect, remember, is going to match whatever our goal is. So for here, we're going to put is treated, like that. So this is pretty much a standalone action all by itself, where it's waiting for at hospital to be triggered, and then we have this is treated goal. And you know what that means? It means we actually have to go back into the patient code to make sure that is treated is in fact one of its goals. So let's go in here. While we're in here, I just want to point out this start method and the way I declared it in the GAgent. Now, I know in previous videos I have it as protected override void start, and that's what you should have in here as well. You want to have it for all of the classes that derive from the agent class. So that's going to be the nurse and anything else that you create. Okay, so we're going to create another sub goal. I'm just going to copy this one and put it under here, and we'll put it as 2. And we will add 2, and our treatment is going to be is treated, and we'll put this at a 5 because it's more important than the is waiting, even though we can't obviously get to is treated without that happening first. Okay, so save that, press play, and let's have...
We have so many scripts now. It took me a minute just to find it. And I had to close some, so we're going to have to switch back and forth. So we want new void start. And we want to add in, we have the sub goal S1, goals S1 with 3, and we want to add in sub goal S2 is a new sub goal, is treated 1 true.
We'll put this at a 5 because it's more important than the is waiting, even though we can't obviously get to is treated without that happening first. Okay, so save that, press play, and let's have a look at this. So I've sped up my agent's movement, and I've also decreased the amount of duration for their actions so that there's not so much waiting around. Okay, so the nurse comes in, gives the cubicle assignment to the patient, and nothing happens. Okay, so what's going wrong? Well, what is going wrong is the at hospital, which is the trigger for our get treated. Okay, so we've got this at hospital, but where are we injecting it? Well, you might say, well, we are actually injecting it. We're doing it in the waiting area. So go to waiting. If we have a look in here, there it is there. It's going into the belief system. But what isn't using the belief system at the moment? Well, it's the planner. The planner's not using the belief system. The planner is only considering the world states. Now, if you remember right back when we started working on the agent, if we go to the agent here, and we find where the planner is actually created and fires off, which is somewhere down in, where are we? Late update. Let's go down, down, down. The planner is here. So planner equals new planner. And then we go planner.plan, actions, our goals, null. This is where we're sending through our beliefs. So make sure you put beliefs in here. Now, this is all well and good, but the actual planner on the other end doesn't have the capability just yet to do anything with them. So just save that. We're going to go back into the actual planner code here. And at the very top, what we need to do is create an overloaded constructor for our node that will take in the beliefs as well as the state of the world, which is coming through into here. So let's just grab a copy of that, put it underneath, and then after our all states, we're going to put in another dictionary. Let me just copy that, put it in there, and let's call this belief states, so that we have the world and the belief states. Now, this is putting the world states into there. What we need to do after that is also add in the belief states. So for each key value pair, which will be a string int b in belief states, if not this dot state dot contains key, b dot key, then we're going to go ahead and add it. So this dot state dot add b dot key and b dot value. So now you can be assured that you have both things being fed through. So that means also, just another little change, is that when we create our very first node, that we send through the world states and the belief state. So let's go down into our planner where that very first node gets created. So here is where the first node is getting created, and it's getting sent our world states that we're grabbing here from our singleton. We've just made an overloaded method that we can send through the states that come from the agent. Now, when we initially set up our queue creation or our plan creation up here, we allowed for another set of states to come through, but we were setting that to null. So these states here are actually the belief states. So let's call them belief states. And then down here, we want to add them in as a parameter. So belief states. And it's going to be dot get states in order to actually return them in the right format for the node. Now that takes those parameters. Where we create the other nodes, which is down in build graph, where it creates more nodes, you don't need to change this, okay? Because the world states that are coming through into here are the concatenation of both sets of states. And so any other child leaves that get created for our graph are always going to have the concatenation of those two initial states, the world state and the set of beliefs inside of them. Right, okay, so let's save that. And now that we're actually getting our at hospital from somewhere, let's go back into here, press play, and let's take a look at what happens. So they're going to spawn as before, then here they come up to the reception desk. And then after they've registered, they'll start making their way into the waiting room. And that's going to trigger the nurse who'll go across. So here he comes.
Let's test ours and I'll catch up on chat and then we'll double check what it's supposed to look like. Hello, Dragon Labs. Yes, this is C#. If you guys get feedback or whatever, let me know. I'll try to turn off my mic when we're listening, but I think I've been pretty good for the most part. Okay, let's see. So, patient comes in, opens the door, goes to reception, checks in, goes to the waiting room. Oh, we got a problem. What is missing? Add item resource. Did I forget to? Let me see what this video shows. Did I forget to put the resource?
There, the
somewhere in
nurse
the
wants
inspector?
she and him get in the same space as a goal location. He's going. Wants she.
Okay. This is where it gets tricky once we're this far into things. So we got object reference not set to an instance of an object. And that is in get patients inventory add item resource. Oh, do I need to actually put a... Let me see something. This is in get patient. Get patient. Here it is. Oh, resources is actually private and not exposed or serialized. So I should get... We have resource here. Oh, you know what? Let me close everything. Oh, just want to see if everything was saved. Looks like it was. Okay, so this is the problem. So I almost feel like I might need to watch this one again. GWorld remove cubicle. Let me open GWorld again. GWorld. Okay. So we get remove cubicle, which DQs cubicle. Does anyone know if you need a co-design certification for Steam game? I don't even know what a co-design cert is. Oh, are you talking about like the C# like application thing? You don't need certifications. I think Steam handles that stuff for you. Code sign. Yeah, no, oh, code sign, yeah, thank you. Yeah, I don't think you need to do that, so I wouldn't worry too much about that one. You're good with Steam. Okay, so remove cubicle. Actually, sorry, you know what? Unity's handling that. So if you use a game engine, I think it handles it. So you might need it if you're not using a game engine. I don't know if Steam needs it. Are you using a game engine? Using Godot. Godot probably does that as well. I would be surprised if it didn't, to be honest. Okay. So, our resource is remove cubicle. And if we go over to remove cubicle, it's just dequeuing it, same as it was with the patient. So we have patients in queue. Similarly, cubicles in queue. Remove patient, cubicles dequeue. So that's all the same. And we can get rid of this because it keeps getting in the way. Where are we here? We added the belief states in. Belief states dictionary. Now, these ones are caps compared to the tutorial was not, so let me just change that. Sure, everything's saved. Let me run it again. Oh, see you later, Pen, and have a good sleep. Okay, let's check it out. He comes in, opens door, goes to registration. I should speed up his agent speed so he just like zooms around. I can test everything faster. Goes to the waiting room, and we get the exception, or null or exception. It's actually happening in both. So first it's happening with get patient, then it's happening again with get treated. So let's see. Get patient. This is in the planner. Get patient. A in results. Get patient. Get treated. Get patient in 18. Get treated in 19. So get treated. Remove item target. So inventory add item resource. And inventory remove item target. So the inventory. That's probably the problem. I don't have an inventory on here, do I? What was it called? G inventory? G inventory. I don't think I have that in here. No, I didn't add it to the game yet. I didn't catch where we do it though, annoyingly. Let me watch this as fast as I can.
And the patients to go to the cubicle that have just been, we've got a few things that are similar.
That was in the last one.
State, and therefore you can trigger some of the...
Okay, hang on. We are in implementing this, so this is where we made the inventory system. I just need to find where we're supposed to add it. I think we just added to like...
The actions can get hold of that inventory from the agent, but you have to do a get to get hold of it. So what I want to do in this G action class is actually just grab hold of it in here.
I think I'm just going to like skim through until I see her adding the G inventory script. Here it is. Let's start from the beginning of this.
An inventory. So let's go C# and we'll call it a G inventory, just to keep up with the way we've been coding so far, the conventions of the name. Now, the inventory itself is not on a behaviour and therefore will not have a start and an update. So it's basically just keeping a list. So a list of game objects, which will be our items that we can put in our inventory or backpack, whatever you want to call it. Okay, so let's call it items, and it's going to equal a new list of game objects. Now it's going to require 3 helper functions, and let's just get rid of that S. I always put that in there. Okay, so it's going to have a public void add item.
I wonder if inheriting from mono behavior is what was causing the issue. Let's take a look. Two times Australian accent. Hey, okay, dog, what's up? Now it's working. Oh, okay, that's why we didn't need to add it, but it can't be a mono behavior. Okay, so now she gets the patient, and the patient goes to the cubicle, I'm assuming. There he goes. Very good. Okay, now we're up to speed. Cool. Okay, back to this one. How far into this were we? Oh, we finished this one, didn't we? We're just watching her test it.
Cubicle as the concatenation of those 2 initial states, the world state. Nurse who'll go across, so here he comes to there. The nurse, once she and him get in the same space as a goal location, he's going to shove off over to the cubicle whilst avoiding the other guys that are coming in. Alright, so that's working really well. So what I'm going to do now is actually leave it as a challenge for you to try and create a new action for the nurse that is going to get the nurse to go over to the same cubicle as the patient. So it's going to involve creating a new action and basically just setting up the correct preconditions and after effects and put that onto the nurse. Now, one little clue that I will give you is that we've just created our get treated for our patient, and the code that you need for your nurse is very similar for her action. So go ahead and give that a go, and when we come back in the next video, I'll show you one way to do that.
Okay, we're almost there. So we want the nurse to go over to the cubicle with the patient. Should we do it ourselves or should we watch the video? I kind of just want to watch the video and then we can mess around. And then the last one is going to be the big challenge, is when we add our own stuff. And what I'm thinking is, just for fun, we could take what we have in this scene and just re-skin it so that we can like change it from being a hospital and we can make it into something else and just like work with the code so we get familiar with it.
Hi, welcome back. How did you go with the challenge that I left you with in the last video? It takes a little bit to get your mind around what values are where and your preconditions and your effects and the inventory and all of the world state, doesn't it? And that's why going through this step by step and adding in the functionality as we require it works to our benefit as far as getting our minds around all of the logic of the code. Okay, so let's get going. Now, I said that we needed something that was pretty similar to the patient's get treated code. So what I'd like you to do is make a copy of it, like we usually do, and then let's call this one go to cubicle. Just so that the nurses is different, open that up and we'll call it go to cubicle, go to cubicle. Okay, so the same thing has to occur up with the target, exactly the same thing. The target is the cubicle, and that's all that we need up there. Now, with the world's modify state, what we're going to put in here instead is treating patient, because the nurse is the one that's doing treating patient, and it's a patient who's being treated. Okay, we then need to also add a cubicle in our post perform back into the world's inventory, I guess you call it. So all the items that the world has ownership of, we're going to give it back one of the cubicles. So world.instance.add cubicle, and the cubicle we're adding back in is the target, like that. Now, as far as removing that same one from the nurse's inventory, you also need to do that down there. And then the last thing that we can do with the nurse, which we haven't done with the patient, is to set the world status of free cubicle and add another one back in there. So gworld.instance.getWorld.modify state, and that will be free cubicle and 1. So adding 1 back to it. It would have gone down to 2, now it'll go back up to 1. Now, the things such as this, you only want to happen by one of the agents involved in the act. Okay, so it's the nurse and the patient, but it's the nurse only giving back the cubicle and setting the state of the world, because both of them can't do it. You don't need it to happen twice. So just be aware of that. And I guess it makes sort of sense that the nurse, being the staff member of the hospital, so to say, is the one who has the code that's actually releasing those resources. All right, so let's save that. How did you go, by the way? I hope you had something similar to that. Now we're going to attach that to our nurse. So here's the nurse, and we just create a go to cubicle, drag and drop that onto here. Now we need to work with the preconditions and the post conditions. So what
Okay, let's see. Let's add it to the nurse. Go to cubicle. So before it was get patient. So before needs to be waiting and free cubicle in the world. Excuse me. And after we have treat patient. We would just go instead. Go to cubicle here, I guess. And copy that for the post. Let's see what she does.
What is the precondition for going to cubicle? Well, there's a whole bunch of.
Also, Projectoroid, that's a really fun suggestion. Make a mini game of people getting cyberpunk enhancements. Okay, maybe we'll brainstorm some ideas after what we'll do with the project once we have it running and we have a kind of a rough idea of how things work. It is a lot to take in a span of probably 6 hours when we're done. It's a lot of information, a lot of code, complex code. So it will be a good practice will be to take it and to work with it. Let's finish this last video and then we'll do that.
Of them isn't there. But in this case, what I'm going to do is link get patient to go to cubicle. So with get patient, down in the After Effects, I'm just going to change this treat patient to patient picked up or something like that. Okay, so patient picked up, and then I'll use that exact same condition. So if I copy that and I'll put it down in my preconditions for go to cubicle, which will link those together. Now, the reason I've not made go to cubicle a separate action like we did with the patient is that this go to cubicle is part of this nurse's plan. So it's get patient, go to cubicle, and it's not actually going to happen, the whole sequence, unless, you know, there's a patient and a cubicle right at the beginning. So that's why I'm doing it like this, and it also saves a lot of extra sort of coding throughout. Now, the after effect for go to cubicle in this case is going to be the nurse's ultimate goal, which is treated, I believe. We just remind ourselves of what the nurse is. No, it's treat patient. So that's our final goal. Let's just copy that and go back into Unity, add that to the nurse's After Effects. And so the goal will now trigger this one, which is going to follow this full plan without having to do, well, you know, anything else. Okay, so we're ready. Let's now press play and see what we get. So patient comes in. Again, I'm just working with one patient. Makes it so much easier to debug. He goes and waits. The nurse will come around and say, I've been allocated to you, and we've got a cubicle allocated to us. So let's go to the cubicle. Both of them will head off to the cubicle. Great, and all of the world states have come up. And you might notice that your other patients are making a headway for the door. Just ignore that for now. Right, now, why didn't I assign the agent or the patient to the nurse so the nurse could follow the patient? Well, it means that the duration of the task for the patient over here in the cubicle could be like 5 seconds, and the nurse might take 8 seconds, so which means that the patient's free to go after 3 seconds, and the nurse kind of stays behind because she's got to clean up or whatever her task is. So even though they end up in the same cubicle together, they're not actually linked directly to each other for that particular task. And that is fine because it's working the way we want it. And remember, creating computer games, and especially AI, it's all about the behavior that you can get them to do, not the perfect way to do it or some other way to do it. However you get it to work and it works fine for you, then go with it. Okay, so that's my sage advice, I guess, at this point, because AI is a very complex topic, and this GOAP system is complex. But once you figure it out and how it's all working in that, and it might take you a while and a few practices, then you'll start to see just how powerful and flexible it is, and that there's more than one way to do something.
Okay. Let's test our thing, and then if it's all good, we'll go to the next one, which is, I think, the last one. Guy comes in. Let's turn the spawner on. Let's get some more people in here.
If you want the perfect...
Wait a minute, it didn't work. Wait, when I turned the spawner on, it broke? Is that what happened? Because it was working a minute ago. The only thing we did was change her last couple things. What's going on here? I might have missed somebody's thing. Let me see. Go to cubicle. Preconditions, go to cubicle. I'm not getting any errors. Let me try it again. They pushed him.
Starting with a blank page can be overwhelming.
Get patient. Oh, conditions are waiting. In the game, was it at waiting? Let me see if the waiting comes up this time. Oh, the ads. The ads are like non-stop. They just played it. It's like you get half the amount of YouTube content for the double the amount of ads you watch. Okay. Free cubicle. Waiting. Free cubicle and waiting. So why is she not doing this again? Go to cubicles here. Precondition is there. You know what? Maybe I should review the last video. Maybe I did mess something up. We'll do it in double speed this time. It's only 5 minutes. So make it just a few minutes.
Hi, welcome back. How did you go with the challenge I left you with in the last video? It takes a little bit to get your mind around what values are where and your preconditions and your effects and the inventory and all of the world state, doesn't it? And that's why going through this step by step and adding in the functionality as we require it works to our benefit as far as getting our minds around all the logic of the code. Okay, so let's get going now. I said that we needed something that was pretty similar to the patient's get treated code. So what I'd like you to do is make a copy of it, like we usually do, and then let's call this one go to cubicle. Just so that the nurses is different, open that up and we'll call it go to cubicle, go to cubicle. Okay, so the same thing has to occur up with the target, exactly the same thing. The target is the cubicle, and that's all that we need up there. Now, with the world's modify state, what we're going to put in here instead is treating patient, because the nurse is the one that's doing treating patient, and it's a patient who's being treated. Okay, we then need to also add a cubicle in our post-perform back into the world's inventory, I guess you call it. So all the items that the world has ownership of, we're going to give it back one of the cubicles. So world.instance.add cubicle, and the cubicle we're adding back in is the target, like that. Now, as far as removing that same one from the nurse's inventory, you also need to do that down there. And then the last thing that we can do with the nurse, which we haven't done with the patient, is to set the world status of free cubicle and add another one back in there. So gworld.instance.getWorld.modify state, and that will be free cubicle and 1. So adding 1 back to it. It would have gone down to 2, now it'll go back up to 1. Now, the things such as this, you only want to happen by one of the agents involved in the act. Okay, so it's the nurse and the patient, but it's the nurse only giving back the cubicle and setting the state of the world, because both of them can't do it. You don't need it to happen twice. So just be aware of that. And I guess it makes sort of sense that the nurse, being the staff member of the hospital, so to say, is the one who has the code that's actually releasing those resources. All right, so let's save that. How did you go, by the way? I hope you had something similar to that. Now we're going to attach that to our nurse. So here's the nurse, and we just create a go to cubicle, drag and drop that onto here. Now we need to work with the preconditions and the postconditions. So what is the precondition for going to cubicle? Well, there's a whole bunch of them, isn't there? But in this case, what I'm going to do is link get patient to go to cubicle. So with get patient, down in the After Effects, I'm just going to change this treat patient to patient picked up or something like that. Okay, so patient picked.
Maybe I'm using the same thing in multiple places. Patient picked up. Let me try that. Patient picked up.
And then I'll use that exact same condition. So if I copy that and I'll put it down in my preconditions for go to cubicle, which will link those together. Now the reason I've not made go to cubicle a separate action, like we did with the patient, is that this go to cubicle is part of this nurse's plan. So it's get patient, go to cubicle, and it's not actually going to happen the whole sequence unless, you know, there's a patient and a cubicle right at the beginning. So that's why I'm doing it like this, and it also saves a lot of extra sort of coding throughout. Now the after effect for go to cubicle in this case is going to be the nurse's ultimate goal, which is treated, I believe. We just remind ourselves of what the nurse is. No, it's treat patient. So that's our final goal. Let's just copy that and go back into Unity, add that to the nurse's after effects. And so the goal will now treat.
Okay, I think that's what I was missing. This is blocking it. Okay, and the after effects.
Going to follow this full.
Treat patient. Okay, let's take a look. Oops, we're still in play mode. Let's do that again. After Effects, treat patient. I guess with a goal-oriented action planning, you need to make sure that the goal is there. Let's take a look and see if it works. You didn't see the videos? Okay, so this is the link. There's, oh, so now it's working. Good. Oh, okay, that's what I was missing. And then in artificial intelligence for beginners, you can go down to goal-driven behavior, and this is the ones that we're following along. We just finished this one. Oops, no, I didn't. I'm on the wrong one. We finished this one, and we're on that last one now. Moving the nurse, we just got it working properly. Let's mark it as complete. And let me double check we're in the right place on the sidebar here. Adding goal challenge. I think this is where we are now.
We're going to begin this video with a challenge. What I would like you to do is to add a new goal to the patient so that the patient goes home after he's spent his treatment time in the cubicle. Now, home, if you remember right back to the beginning, is actually a location in the map. So there's an item called home here. It has a home tag. And if we click on it and just zoom out and have a bit of a look where that home is, you can see that it's a position over here. Okay, so that will just get the agent to walk out of the hospital as though he's going home. So currently, when our patient gets to the cubicle with the nurse, if we just have a look at our patient code and come down to our get treatment, this is the last stage. So it's just going to stay there and not go anywhere. Now, there's no duration set up currently for our get treated. So if you do want to give that, say, like a 5-second duration, so it does take, you know, a bit of time for the treatment to occur.
Have a good one, Roger. We'll see you later.
Then you want to figure out how to get him to leave and go home. So this is the challenge for you. Pause the video now, give it a go. When we come back, I'll step through that with you.
Okay, once again, I think I'm going to just follow along. There's a lot of moving parts, and I think I'll understand better with everything as I start to mess around with it more. Okay, see you later, Dinara.
Okay, so how did you go with that? Well, the first thing you need to do is actually create another action. So we want to pick a script to duplicate that's quite simple. Go to hospital, there's not really much going on in there. Let's duplicate that. We're going to call it go home. And then you want to open that up and also change the name of the class to go home. Now, to duplicate that's quite simple. Go to hospital. There's not really much going on in there. Let's duplicate that. We're going to call it go home. And then you want to open that up and also change the name of the class to go home. Now, there's really nothing you have to do in this script, okay? There's no pre-perform and there's no post-perform. Everything gets set in the inspector. In fact, you probably could just use the same script as go to hospital and attach that again and just rename the variables in it. But in this case, we've got something separate. So let's just save that. Now, while we're here, let's go into the patient. The patient needs to have another goal that is to go home. Plan without having to do, well, you know, anything else. Okay, so we're ready. Let's now press play. And
oh, I went and picked up, I went and opened the patient script, but I missed what we're supposed to do with it.
Goal, which is treated, I believe. We just remind ourselves of what the nurse is. No, it's treat patient. So that's our final goal. Let's just copy that and go back into Unity.
You know what? I think I have 2 videos open. Moving the nurse. Yeah, this is not the right one. This is the right one.
Of course, you could have go home after is treated as well. You could do it that way. But in this case, I'm just doing it with an extra sub-goal. Okay, so what we're going to do under here is copy this one, put it down here, call this 3. And in here, we will have is home as the goal. Okay, so save that.
Now let's go back into Unity and select our patient. So we're going to put go home onto the patient there, and let's name it as go home. The target tag in this case is home. There's no duration. The precondition, we're going to add in a precondition one here, and we don't want the patient to actually go home until they're cured. So I'll put is cured here as the precondition. The after effect, which has to match the goal, we want one of those, and it's going to be is home. Okay, so where do we put is cured? Well, it's not going to be a world state because...
Hang on, I'm getting confused. I'm going to go back a little bit. Sucka. I'm not going to read the full name. Sucka, thank you very much for 2 months. How are you doing? Bonjour. You should watch... This should be state machine. Well, there's an option to do it as a state machine. We're exploring a different approach to it, and it's got some interesting applications. If you were here during the intro, Robin, it talks about some of the benefits of this type of goal-oriented action planning instead of a state machine. So it's kind of like just a different flavor of doing things with an interesting. I kind of like what it is. I'm gonna watch this because I want to make sure I get the right stuff in here.
Okay, so save that. Now let's go back into Unity and select our patient. So we're going to put go home onto the patient there, and let's name it as go home. The target tag in this case is home. There's no duration. The precondition, we're going to add in a precondition one here, and we don't want the patient to actually go home until they're cured. So I'll put is cured here as the precondition. The after effect, which has to match the goal, we want one of those, and it's going to be is home.
Okay, where are we here? So go home, and then it has to match is home as the goal. So it's basically just to see if I can describe it as well as they do. They have some graphics and stuff. If you watch the intro to this specific part of the tutorial, so in the link, this is artificial intelligence for beginners. In the goal-driven behavior, the introduction to it, they kind of cover why it's interesting. And basically what it's saying is like, you're instead of your NPC, I don't know if I can summarize it very well, but basically you can have your NPC do things with a goal in mind, and it can have preferences on what it wants to do. Instead, it can pick between them, and you can assign things like, they made an example of the NPC wants to eat dinner, and if you have the ingredients and this and this and this, then you can cook it. And the other path would be like, it's basically they want to be not hungry. So it's like, do you have the ingredients, blah, 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 and it eventually goes to like cooking it, eating it, not hungry. Then there's another path that goes through a different way. It's like, if there's money, order pizza and this and this and this. And then you can basically choose to have that NPC prioritize one path versus another based on other conditions. For example, if you want it to be the least expensive version, then it will do like the cooking. But if you want it to be the fastest version, it will do the ordering or something like that. So it's a pretty interesting approach to character behavior. I think Dinar just headed off, Jo. Have you ever watched Building a Better Centaur talk with the whole influence maps thing? I think RimWorld did a video on how they use these. Interesting. I'd be interested to watch that. RimWorld's very complex. They can choose their own adventure, pretty much. Well, it's almost different. It's like instead of choosing their own adventure, their adventure is chosen. They're choosing the path to walk on. I guess that's what this one is. So hopefully that helps explain why this approach is interesting. And let's. Did I put it in? I've had to put in is home on the goal, because that's what they're trying to do, and it works backwards from there. So is home there. And I believe the post condition of getting treated, we don't have an is cured here. Okay, let's see what they say. I think I'm jumping ahead. Let's put this back over there.
Add that to the nurse's after effects, and so the goal will now trigger this one, which is going to follow this full plan without having to do, well, anything else. Okay, so we're ready. Let's now press.
Go to cubicle, treat patient. Go to cubicle. Treat patient, we have. Go to cubicle, treat patient. Well, I don't know. Is cured. Did we do is cured anywhere? It should be the duration. Get treated, is treated. Why are these two different? Should I add a second after effect that is cured? Let me watch those last few steps again. I think I might have missed something.
But in this case, what I'm going to do is link get patient to go to cubicle. So with get patient, down in the after effects, I'm just going to change this treat patient to patient picked up or something like that. Okay, so patient picked up, and then because it has to apply to the actual patient. That means that whatever action is happening to cure the patient will need to inject that belief into the patient. So the patient is getting cured in its get treated script. So if we go into get treated, you can see that I've already added this in here. And all you've got to do is just add beliefs.
That's where it was missing in the script. Okay, so here we can say beliefs modify state is cured, and that should
Dot modify state is cured, and that will go into the agent's beliefs and then allow that extra task or action to execute. Now let's go back into Unity to play it. Actually, before I do, let's just go into G World, and I just wanted to show you a little bit of code that I've put in here to make things run a hell of a lot faster. So you could speed up the agent's movement, but that's going to give you inaccurate sort of, I guess, movement and physics on the nav mesh. Instead, you just want to speed the entire simulation up. So you can do that by changing the time scale somewhere within your code that runs like first up. That's why I've got it inside of the instantiator for the G World and set it to 5. So it's going to do 5 times the speed. Okay, so save that. Now with all of that done, we can now check out our full plan for our patient.
I want to check it in our thing rather than watch it. Let's see. Hey, Alban. How do I say Albane? How's it going? Welcome in. We're following a tutorial today. Oh, let's see it from a top-down view. So he goes in the patient's waiting room. The nurse brings him over to the cubicle. He stays there. He gets treated. And he goes home. All regular occurrence. I wonder what happens if I have multiple of them on. Let's test that now. I wonder if the nurse will come back and treat the others. That would be cool, actually. I don't know if that's going to happen yet, or if we would need to add that in. Oh, she didn't actually. You know what? Let me do that. Oh, I didn't apply all the overrides. Okay, apply the overrides. Turn off that one. Yeah, we'll need some more nurses. If it does cure them, that would be cool. That's funny. So he goes home, but she doesn't come back to treat more, which would be an interesting next step for us to try. There's so many. So many. Why is there so many being added? What did I put in the spawner? 5. Oh yeah, because it's twice. It's you add 5 and then just keeps adding them after that. Okay, we don't need that many patients. That's for a real hospital situation to deal with. Okay, they're all close talkers. Yeah, they are. Okay, let's watch the last bit of this.
If you've been using the patient like I have and turning it on and off, and then make sure you also override it while it is turned on, and then you can turn it off. I'm going to leave this going on now. I've just moved him outside so he can be the first guy that comes in. Let's have a look at how this runs and what does the nurse do when the patient goes home. So let's have a look. They're coming in. The nurse gets the patient, go over to the cubicle. He goes home. She's like thinking about picking up someone else, which she does. She goes and gets him because that's her goal. That's what she does. She just wants to treat a patient. As long as there's a patient available, she's just going to keep running that goal over and over again. And as you can see, she's doing a great job of it. Okay, so she's getting a bit overwhelmed. This has been an introduction to goal.
Oh, she is supposed to treat it over and over. Okay, so maybe that's our last thing to figure out.
Goal-orientated action planning, and I'm sure by now you can see the power that is in it. If you're very interested in continuing on and learning more about this system and building a more interactive hospital, like the one you can see here on the screen, then please do visit my learning website where you can interact with other students who are also building the same simulation.
That's cool. All right. Last item.
In this lecture, we're going to make the nurse take a break.
Spanish slang for getting banned. El ban. Oh, I see. Getting into game dev. Well, welcome to the game dev world. Let us know if you have any questions. We're just finishing off this tutorial. I think, yeah, let's finish this last one and then, I know, I think I need to go back and fix it so that she takes a break. We need to go back and so that she continues to treat other patients. Because if we want her to take a break, she'll need to be continuing to work. So let's take a look. Nurse. First of all, let's apply these. So go to cubicle, get patient. I wonder which is missing. If it's waiting. No, waiting and free cubicle show up. And I think that there's more than one of each. So that means that those should both be fine. Go to cubicle. I think it might have to do with, let's see. Preconditions, waiting, free cubicle. Go to cubicle. Might want to watch this one more time real quick.
We're going to begin this video with a challenge. What I would like you to do is to add a new goal to walk out of the hospital. Okay, so how did you go with that? Then you want to open that up and also change the name of the class to go home. Now, there's really nothing you have to do in this script, okay? There's no pre-perform and there's no post-perform. Everything gets set in the inspector. In fact, you probably could just use the same script as go to hospital and attach that again and just rename the variables in it. But in this case, we've got something separate. So let's just save that. Now, while we're here, let's go into the patient. The patient needs to have another goal that is to go home. Of course, you could have go home after is treated as well. You could do it that way. But in this case, I'm just doing it with an extra sub-goal. Okay, so what we're going to do under here is copy this one, put it down here, call this 3. And in here, we will have is home as the goal. Okay, so save that. Now let's go back into Unity and select our patient. So we're going to put go home onto the patient there, and let's name it as go home. The target tag in this case is home, and there's no duration. The precondition, we're going to add in a precondition one here, and we don't want the patient to actually go home until they're cured. So I'll put is cured here as the precondition. The after effect, which has to match the goal, we want one of those, and it's going to be is home. Okay, so where do we put is cured? Well, it's not going to be a world state because it has to apply to the actual patient. That means that whatever action is happening to cure the patient will need to inject that belief into the patient. So the patient is getting cured in its get treated script. So if we go into get treated, you can see that I've already added this in here. And all you've got to do is just add beliefs.modify state is cured, and that will go into the agent's beliefs and then allow that extra task or action to execute. Now let's go back into Unity to play it. Actually, before I do, let's just go into G World, and I just wanted to show you a little bit of code that I've put in here to make things run a hell of a lot faster. So you could speed up the agent's movement.
Okay, that won't affect it. So something's missing. Something's missing, and I think it has to do with the nurse. Get patient, go to cubicle. Let me look at these. Get patient. In fact, let me close everything. Let's open get patient. Let's open go to cubicle. On our patient, let's make sure everything's applied. Let's look at go home. Let's look at get treated. When is she is waiting is when I think the nurse starts paying attention. So go home. I don't have anything on because we just get there. That's it. Let's see. Go to waiting room. Go to waiting room. One more item is waiting. We add this patient to the queue. Beliefs at hospitals true. And then get treated. Treated is cured. Is cured. On here says to go home. Go to cubicle. I don't know if we need that one. Treating patient. Free cubicle. Oh, this is from the nurse. Treating patient. Free cubicle. Treating patient. I'm thinking if there's something I need to do to complete that. Get patients. Pre-perform free cubicle -1. So we take up a cubicle. And remove cubicle, remove patient. Hello. Hello, Cool. How's it going? Thanks for the streams. Helps me to get focused working. Oh, I'm glad to hear that. And you're welcome. Welcome into chat. Hope you're having a good one. Okay, let's let it play with only spawned visitors and see what happens to each state of things. Glad to hear an Olahobin. What's the best way to say your name? I feel like there's a lot of syllables and I'm not sure. Okay, so free cubicle, waiting, treating patient, one treated. Now, let me see. The nurse. What is the nurse doing? Go to patient, go to cubicle. Go to patient, requires waiting and free cubicle, which we should have we should have both. Go to cubicle is the result of getting the patient. And in go to cubicle, put some music on, let me figure this out. Go to cubicle, treat patient. And post perform of go to cubicle is treating patient and free cubicle. Let me make sure those are both happening. Ole. Oh, okay. Ole. Hey, God, Kimmy. Okay, so let's run and see if that comes up in our debug. I know, they're cute, aren't they? Yeah, free cubicle happened. So neither of these are running. What if I did that again? Would it just go? No.
Empower your students to be more
See what I mean? I have to wait for a minute to continue watching. Oh, there's the... That's really aggressive. What kind of guide is this? Is a Unity Learn guide. Hang on a minute. Kind of got, oh, sorry, we read that already. Hang on a sec. Okay, let's see. Those people are all working fine. I don't think that we covered the nurse moving, did we? I wonder if I should do the last tutorial and then look. Let's see.
In this lecture, we're going to make the nurse take a break every so often, which will have her go into the staff room for a certain amount of time. Okay, so first of all, let's edit the nurse code, because this is where I guess maybe the magic is happening, if you want to call it that. So the nurse currently has treat patient as its only goal. So we're going to add in another goal in here for resting. So let's just copy that and put that down there and make this S2. And let's make our resting one a 1 as far as it being important to us, so it's not so important. And in this case, our goal will be rested. Now, we're going to have false for the removing of the goal because we just want it to keep coming up and keep coming up. Next thing we're going to do is...
I think I might know. Okay, I need to look at sub goal. I want to look at sub goal again. I want to know what this part is for, the false part. That would be under what? G planner maybe? Let's see, sub goal. No, was it under world states? No. G action maybe? Nope. What was it under? G agent? Yes. Sub goal. The bool is just labeled remove. There, okay, I think that was actually it. So remove that goal after it's done, I think is what that means. Let me double check. If I set that to false, let's see if the nurse will go to the next patient. See you later, Sale. Have a good one. Okay, let's check it. Okay, She went and got another patient before the guy was even done getting treated. Maybe they need a second after she just gives them some medicine and they have to sit there and take it. That's why that's the explanation for these actions. Okay, so that was the difference. So now we're going to add the next goal, and we want it to be not removed once it's done. So this is whether or not the goal is repeating, and it is repeating, so we don't remove it. Now we're going to add the new goal. Let's see what else we're going to do with that.
Actually write a method down here to make the nurse tired. So void get tired, and then in get tired we're going to set the beliefs of the nurse to modify state and have it exhausted. And then we're also going to invoke exhausted again after a certain amount of time. So we'll just run get tired from inside itself here, random.range between, let's say, every 10 and 20 seconds, which is quite a short amount of time to get exhausted. But anyway, she's going to get exhausted like that. And then down here in the start, we want to invoke it for the very first time. So invoke get tired. And again, the first time that the nurse gets tired, random.range between 10 and 20. That means when you have multiple nurses, they're all not going to go on a break at exactly the same time right at the beginning. Okay, so we now have this exhausted being injected into the nurse's belief system, so we can use it as a precondition to actually creating a rest action. All right, so save that. Now we're going to create this rest action. Let's go back in here, and we want another sort of simple looking action to duplicate. Okay, that go home's pretty good. So let's Control D that. We're going to call it rest. Open it in your editor. Then in here we will call it rest. The pre-perform can stay as it is. The post-perform actually has to remove the exhausted.
Okay, rest. Okay.
So it'll be bullet.
I should have copied the other one. What was the other one that was similar? I'll copy it from one of these. It's got to be a G action too. I better remember to do that. Not a mono behavior. And
leaves dot remove state and exhausted, so that it takes it away after it has been performed. So save that. Let's go back into Unity, and we want to get our nurse and put that rest onto the nurse. Okay, let me just close a few of these other things up. Now, the precondition is going to be exhausted. So we put a size of 1 in there, and we will type in exhausted. And then our after effect that we want a size 1 of is going to be the sub goal that we've set for the nurse. Now, if we have a look at our nurse's code just quickly, it's called rested. So we can go back to the nurse and we'll put rested in here. And make sure you've spelt it correctly. Now, the duration is going to be, let's say 5 seconds, and the target tag will be our rest area, which is the staff lounge. There it is there. So let's just see what it is. It's a lounge is its tag. So back to the nurse, let's put lounge in there, and we will just call this rest for the action name. Okay, ready to try it out. So press play. Now the patients will start coming in. She's going to be treating these patients.
wait a minute, she went on break before she even treated anyone.
And because there's so many patients, she actually doesn't get a chance to go on a break. Okay, so let's just stop playing. Let's go to the spawner and turn that off. So we've only got 1 patient coming in. We'll just do that. Press play, and she's going to get him. He will then go home, and then eventually, there she goes to have a break.
Okay, let's try ours again with just 1. Or we'll make the spawner only spawn 1. Fucking lazy nerds. Wait a second, why did she go there first? You know, it's probably because the seconds passed is longer than it takes for the thing to get to that spot. Okay, so she's going and getting people. This part's a bit of a mess though, isn't it? Let's make the spawner spawn patients only once every 10 to 20 seconds. And we will not have a bunch spawn at the beginning. And then let's take the nurse script and let's have her rest, need a break every 20 to 30 seconds. And let's try that. There we go. Now the timing's better. Oh, I should make her wait with the thing. So she took a break. Don't forget, this is going in 5 times speed. So 20 to 30 seconds is actually passing in game time much faster. Oh, okay. Now hopefully she'll go on a break again soon. Or was that what we need to do now? So I think that's what we need to do now. Okay, that's better. Now, where were we here?
Now, when another patient comes in, then she'll obviously have to come out, but she's got nothing else to do after the take a break rest action has...
Oh, wait, what did she do to turn on taking a break, even though there's a lot of patients? Let's go back a little bit.
Going to be, let's say 5 seconds, and the target tag will be our...
She's resting for 5 seconds. I should put that in. I should also put her waiting with the patient for a little longer. So resting 5 seconds, go to cubicle. Yeah, she doesn't stay there. I'll say 3. Okay.
Rest area, which is the staff lounge. There it is there. So let's just see what it is. It's a lounge is its tag. So back to the nurse, let's put lounge in there, and we will just call this rest for the action name. Okay, ready to try it out. So press play. Now the patients will start coming in. She's going to be treating these patients. And because there's so many patients, she actually doesn't get a chance to go on a break. Okay, so let's just stop playing. Let's go to the spawner and turn that off. So we've only got one patient coming in. We'll just do that. Press play, and she's going to get him. He will then go home, and then eventually, there she goes, to have a break.
Okay, let's test
now,
that.
When another patient comes in, then she'll obviously have to come out.
So if we just have the one patient come in, let's turn off the spawner. Let's say that she goes to the break room after she treats that person. Okay, good. And let's do the last part of this.
Now, but she's got nothing else to do after the take a break rest action has happened, so she will just stay there. Right, so at this point, we can actually turn our spawner back on and create a whole heap of duplicates of our nurse. So you can make the nurse into a prefab at the moment, or you could just duplicate the nurse. So I'm just going to duplicate her. So with her selected, I'm just going to come down in here and Control D and just keep moving them out. Okay, hit the W key if you want to get the axis system so you can see them. And it looks like an awful lot of nurses. Okay, so now we have a whole hospital of nurses. Let's press play. And we should see the system in action. So some of them have gone on a break. Others are going to get their patient, taking them to free cubicles, going and having a break. And then others come out to clear the patient backlog. Okay, so we've used the goal-orientated action planning system, which is an artificial intelligence method to work on the behaviour of these agents. So it's a very powerful, it's not that complex. I know I've said that before and it might seem complex as you're starting to put the whole thing together, but essentially once you get your head around the order in which the actions are going to get put together based on your preconditions and your postconditions and the inventory stuff, you should be able to build some really complex systems with these agents. One last thing I'll show you before we finish this section is how to get rid of the agents that have gone home. So currently we have these patient agents and they're coming in and being treated, and
My day is going to end, Lana. Thanks for keeping people motivated and also helping me on my C# journey. For me, it's time to go to sleep. Good night. Good night, Ole. Have a good one. Thanks for hanging out today. Okay, we're gonna check out this last bit of this thing here. Then I've got a fun question.
Then they're going to the home point. Now the home point is out here, and you can see them now. They're starting to come out and they'll start to bunch up, which means they're taking up memory and you don't really need them anymore. So we may as well just destroy them, and that's easily enough done. In the go home code, which is pretty empty really, when they get home, the post perform is actually going to run to end off that go home action. So in here, we can just put in a destroy. So if you add a destroy for this .game object, like that, just with one simple line, save it, and then the post perform is actually going to run to end off that go home action. So in here, we can just put in a destroy. So if you add a destroy for this .game object, like that, just with one simple line, save it, and then try that out again, your agents will, of course, get destroyed when they get home. So we'll just wait for them to start coming home. So here comes the first guy, and he's just going to start popping.
Okay, she's testing hers. Let's test ours. Let's add the extra things. Okay, no more overrides. That. Okay. Do your agents have agency? No. Okay, so she picks them up. They all go on break. Huddle time, huddle. He gets destroyed over there. Huddle, aggressive huddles. Oh yeah, I forgot to turn the spawner on. Okay, very cute. Super cute. COVID conspiracy theme hospital. They're doing some kind of strange nurse ritual over there. Okay. Let's watch that last bit of that video.
Being out of existence, you'll also see them go away in the hierarchy here. So it's a good idea to clean them up if you're not going to use them anywhere else in your simulation. Alternatively, if you wanted, you could create a pool of patients where you just reuse the same lot of prefabs over and over again. But this is just one option. Okay, so that's the end of this section on GOAP, and I hope you really enjoyed it and you've already thought of a whole bunch of different scenarios that you can use it in, and even how you might extend this hospital. If you do, please get in touch and show me what you've created, because I'd love to see it and I'd love to share it with other students.
Okay, that's exactly what we're going to do. So, as I've mentioned earlier today, this is the goal-driven behavior section of the AI tutorial for beginners. This bigger course here has a lot of things if you guys want to look into it. This is just one of many different things to control NPCs and enemies. This is the second last, goal-driven behavior. There's different ways to control NPCs and enemies. There is a finite state machine section. There's an autonomously moving agents, crowd simulation, behavior trees. So I highly recommend digging into each of these if you guys want to have any kind of interesting NPC or enemy behavior in a game. That way you have a bit of an understanding of each one and you can choose which one's the right one for your game. We have dug into the goal-driven behavior. So the next thing I think would be really fun to do would be to, well, let's mark this as completed now that we've done that. And I think we're going to, I would like to spend some time tomorrow working on taking this and converting it into something with different assets. And it doesn't even have to be a hospital. The hospital was a good example. It's clear to understand. But I'm thinking we do one where I can use assets I've bought before or got them in or made or whatever. Let's see what Unity asset store. I was thinking of even using some that I have, some characters that I've gotten before and putting them in. What have we got here? I mean, technically we could use a time ghost character, but I think that would be too complicated. But I've got some here. Let me see. I have settings we can use. I have all different assets. We have some let me hang on. I think my one complaint with the Unity Asset Store is like I want to open the asset in a new tab often in fact, but I have to like open the module and then do that. Okay, so like here's characters we could use. They're very cartoony. We could use goodies characters, but I was thinking of doing something more realistic. Let me go through assets that we have that we could potentially use. We have this one. We could make some kind of cool river setting, beach setting. We have, just looking at other stuff here. Default city pack. I'm trying to remember what this one is. We have a city we could use here. Could make something out of the city. That could be interesting. It's for also free. We've got these characters I was thinking of. Some kind of survival characters maybe. And have them moving around instead of this what do you call it? Capsules. We also have techwear girls, super cute. They could also be used. We could be doing... What else have we got here? There's a forest pack. We could use a forest in it. And what's Nebraska? Arga, I keep hearing you talk about this. What else have we got? Ooh, you know what might make another interesting thing? We could use ray fire. So ray fire is destruction. Okay. So hypothetically, car wash. Hypothetically, we could do a city, right? And then we could have characters who are in the city, and they could be... There could be one group that's destroying the city and the other group stopping them. That might be very complicated. But I'm just throwing ideas out there. Or they could be in a forest. If you guys have any suggestions, ideas, this is just a fun thing that we're gonna mess around with tomorrow. We're not gonna be too how do I put this? We're not gonna get stressed out about it. We're just gonna do it in a chill way and see what we can make with it. We also have this gorgeous asset. So we can make some cool... Yeah, it's very Strain-esque. It's like a Strain spin-off or something. What else have we got? We could also replace the characters in here with Goody characters and Goody's assets. That might be actually easier because I know those ones really well, and I know that they're straightforward to use. If we use Goody's assets, what could we do with that? A pool party. We could do a pool party. We could just have people doing different stuff at the pool party. Thinking like you walk in, go to one place, nurse goes to another character goes to the first character. Could be like a shop, could be a restaurant. All different ideas we can think about. AI cats going around knocking things over. Another set of AIs going around picking them up. That's a cute one too. It's a really cute one. I should do just a person in a cat outfit and a cat costume just knocking things over. Then I can just use humanoid animation. Pool party, but the pool's filled with acid. That's a horrifying party. I don't want to get invited to that one. I would just go in anyway. I'd be like, oh, a pool. They're like, no, it's full of acid. Oh, we keep telling them too late. Should have put on the invitation. Camping's cute. What other assets have we got? These are more tools than 3D stuff. In any case, if you guys have any thoughts or ideas, think about it overnight. I'm going to probably start tomorrow spending a few hours just like reskinning this, re-changing a few things around just to see it in action. And then we'll see it as like a more put together thing instead of just a tutorial. And we'll probably get more used to how it all works in the meantime, which is nice. So, hopefully... Oh, Gervais, are you getting a passing grade with this course? Yes, we just passed it, in fact. We just completed it and everything works perfectly. So, we did good. And there's more to learn if you guys want to go in. Again, here's the link. And we'll look at it again a bit tomorrow. And I think that that's it for today. So, it's time for us to say goodbye now. Aww. I know, hardest part of the day. And let's see what's in show and tell. There you are. Oh, stuff from Taper. Let's see this one first. Worked my chord trainer. It's an MVP now. Whoa. Cool. There's another video from Taper on the same thing. Let's take a look at this one. Next update now with chromatic key mode. I just mirror what the default push config does and octave shifting. Whoa. Can you break this down more in the next update and explain it? Is it like an arpeggiator? Hey, Squam. This is cool. Oh, way to learn chords. Well, that sounds handy for a lot of people. Please share more. Looking forward to it. Vault is the theme of today for Steve. Very nice. And here is a image from Schulenheimer. Building my own keyboard at the moment. Made this case in Blender. 3D printed it and hand soldered all the hot swap sockets. Now I'm programming the Raspberry Pi Pico microcontrollers because I wanted to learn more C. I'm writing the keyboard logic myself and rely on the Pico SDK and Tiny USB for all the host interfacing. Basic layer works so far, and now I'm working on the whole layer switch functionality. That's a really cool project. Really cool. That's crazy. You 3D printed it and you're doing the hot swap sockets, soldering them by hand, and programming everything. I respect it. That's a lot of different skills all in one project. Nice work. This is from Magetz. I finally got Open Web UI working, and now I have a way to communicate with Olama. The text generation takes a while, but it's not actually using my GPU, it's using my CPU. But yeah, here's a result when I ask it to generate number guessing game in C. Whoa, that's so cool. So you have this working locally, like you are in control of it? That is cool. Keep sharing. This is really cool stuff you guys are doing. Thank you for sharing that stuff so far. Thank you for hanging out today, guys. I hope you enjoyed learning a little bit about some goal-oriented action planning in games, specifically with this one in Unity. Oh, by the way, if you guys are on Blue Sky, I got Blue Sky. If you guys are using it, add me. I'll add you back. If you have thought about getting it, you may as well get it now. That's my take anyway. You know, I probably won't use it, but maybe I'll start using it. I don't know. But got it now. If you guys are Blue Sky folks, come say hi. And yeah, I think that's everything. We'll see you tomorrow. We'll do a little more of this, and then I might do either modeling with Strain, or we'll go back to the Twitch API mini project. The next 2 weeks will be a little bit all over the place, but we'll be back on track in a little while, and then and I'll be working on Strain throughout that time. So where are we gonna go? Let's see. Oh, a few people are on. Let's see. Who have we not rated in a while? What do I rate? Theo-y. No, you know what? We rated Theo recently. Maybe Steph? Steph we haven't rated in a while. Let's go over to Steph. Alright, guys. See you guys tomorrow morning. Have a good one, everyone. Take care. Bye, everybody. Bye.
like